Hello, 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 hello. Okay.
Hello, hello,
Hello.
Dreams that would make us sustainable and self-reliant. Dreams of growing together in a future-ready world. Dreams
Hello, hello.
Hello. So, good morning to all. After an exciting and highly interesting lectures, yesterday's sessions by Professor Dr. A.K. Ganguly sir of IISER Barampur, Dr. Sumanta Panda sir, BSSUT Burla, industry delegates, faculties, scientists and research scholars, students. We now enter into the day 2 of the National Conference on Recent Advancement in Materials and Manufacturing, RAMM-2023. So today we are having one plenary lecture, 2 keynote lectures and presentations by research scholars, scientists, faculties and students. The first session will be the plenary lecture by Dr. Ashok Kumar Ganguly, Chief Scientist, CSIR, IMMT-Bhubaneswar. The session will be chaired. Sorry, sir. Yes, sir. Yes, sir. Sorry, sir.
Good morning to all. Myself Dr. P.C. Padi. I am the principal CIPET IPT-Bhubaneswar. Today's session will be very encouraging. I first of all welcome everybody to the dais, and I hope all the students fraternity and all academicians, researchers will definitely get immensely benefited out of the today's conference outcome, and it will be very encouraging. First of all, I welcome Dr. Ashok Kumar Sahu, Chief Scientist, CSIR IMMT retired. Sir has devoted immensely to the nation in the area of developing new materials and in the sector of minerals, many ferrous and non-ferrous materials, extraction concepts and its waste management. He has got a very eminent role in that, and Sir has developed one terrafill water filter, and which is a special type of terracotta type, and is having 15 years of academic experience, skill training and technical support. He has worked on basically on mineral extractions, and we are associated for a long time. I hope his lecture will be very encouraging, and similarly this session will be chaired by Dr. Piyush Kant Mandal, our associate professor, CIPET IPT Bhubaneswar. He will chair the session. I request now, I'll call, now I am inviting Dr. Mandal to start the session, and I also welcome to Dr. Ashok Kumar Sahu to start his presentation. Yeah.
Very good morning to all. Today, first lecture will be given by Dr. Ashok Kumar Sahu. Dr. Ashok Kumar Sahu is the Chief Retired Scientist of CSR IMM team. He has a vast knowledge on mines and minerals. He has developed terrafill filter and many more areas, and he devoted his research work for a long time on minerals, and he has a vast experience and published more than 30 papers in reputed journal. He has also 6 number of patent in his credit, and also he has a major award in CSR from CSR and National Geoscience. Moreover, he was the member of National Committee BIS and also other professional bodies. So he will deliver the lecture importance on critical material achieving sustainable development. Now this is the emerging area today. I would like to request Professor Dr. Ashok Kumar Sahu, please come on the dais and deliver your lecture. Sir, please.
Hello, good morning all, respected guests and dear delegates. Thank you for your kind introduction. Okay. This is a broad topic I have chosen for this session of this RAM 2023. I am thankful to CIPET and RAM Management Committee for inviting me for this talk. Also my alma mater CSR IMT for giving me opportunity to work with it. And I'll start my topic as the importance of critical minerals in sustainable development. Now critical mineral is coming in a big way because of development of EV and decarbonation. So people are looking to for different mineral which is more suitable for this type of development. So my work, I'll just in my presentation, this is okay. Just slide change. Okay. Which one? This one. So my topic broadly covers this ores and minerals and how it is defined and how it is categorized. Then comes critical mineral, where we stand as India as a country, a developing country, where we stand as far as critical mineral is concerned. Then some of the R&D works in critical mineral field in my institute, that is CSR IMT, and some other institute also. That is recovery of valuables from 2 sources, that is primary sources and secondary sources. So I'll be talking little bit about all these manganese, the critical mineral which we have already, Government of India already defined. These are the critical minerals and we have to work for having this deposit or recovering values from these sources. And I'll be giving more on graphite and graphene, whatever we did, then conclusion. So which one? This one, no? So ores and minerals, actually we are all working in materials, but coming the origin of your metal or material, it is ores and minerals, and is available in earth crust, also seabed, and some of the that is in metallic or native form or in a compound form. They are available in these two forms. So Indian scenario, India has a vast economic potential in mineral sector, owing to significant development, diverse mineral resources, and country produces nearly 95 minerals, including 4 fuel minerals and 10 metallic minerals and 47 non-metal minerals and 3 atomic minerals and 23 minor minerals, including your construction and other materials. And India's GDP is around in the mineral sector contribute nearly 2.4% of our GDP. So categorizing these ores and minerals, that is metallic, what I told, that is ferrous, non-ferrous and precious. This ferrous it coming what iron, manganese, chromite, nickel, cobalt, it is coming in the ferrous category. Then you have non-ferrous, and where it zinc, copper, lead, bauxite, tin, etc. is coming non-ferrous. Then we have precious, gold, silver, platinum. In the non-metallic, we have lot of non-metallic minerals, that is graphite, silica, quartz, limestone, mica, granite, salt, potash, lot of these are non-metallic categories. Then fuel mineral we have categorized coal, petroleum, natural gas. Then nuclear mineral, that is uranium, rutile, ilmenite, monazite, thorium, etc. So it is all categorization of these minerals in different format. As far as ores and mineral concerned, we categorize in 3 types. Bulk mineral. What is bulk mineral? These minerals are transacted in high volumes. Iron ore, chromite ore, bauxite, granite. These are all coming under bulk mineral. And we have a strategic mineral. This category mainly comprises non-ferrous and metals such as copper, lead, zinc, which also 12 associated metals, which are strategic to our requirement, maybe defense or aerospace. These are categorized in that. Then we have precious mineral. We know it is gold, silver, platinum group of metals, diamond and precious stones. So our reserves, actually coming to reserve, what we have in this, in our country. Coal, we have presence in Jharkhand, Odisha, MP, Chhattisgarh and this West Bengal area. We have 148 billion ton and lifespan is 204. It is going up. Lot of exploration is going by GSI and other agency. They are day by day they are increasing our reserve category. Then iron ore is 5.4 billion. Then bauxite 0.65. We have nearly 28 years left. These are all data collected from IBM annual report. Copper, manganese, limestone, these are all available in bulk, and we try to extract, recover the values from these ores and minerals for our sustainability. So telling just one thing, that is we are a second largest steel producer till date, third largest coal producer, then fourth largest iron ore producer comparing to the world scenario, the fourth largest bauxite producer, then fourth largest chromite reserves we have, and sixth largest zinc producer. So ores and minerals, when we are in Odisha in a mineral rich state, you know, and when comparing Odisha stand, when comparing the other state, we have a lot of major minerals, that is chromite. We are here nearly 96% of chromite reserve in Odisha. And bauxite we have 51% reserve. The iron ore 34%. Then nickel and PGM is platinum group of minerals, that is 90%, more than 90%. In our chromite overburden and chromite area, you will find this type of minerals. Then manganese 44%, then coal is 25%. Then we have also some of the minor minerals that is mica, monazite, cobalt, vanadium, fair clay and sillimanite. These are also some percentage we have as far as this is collected from OMC, our Odisha Mining Corporation report. So what are the challenges? Challenges are depletion of high grade ore. We are having luxury of utilizing high grade ore and dumping the low grade ore in the mine site or other area. So we have to, since all the countries in the world, they are planning to have their stockpile of their mineral. So we have to utilize judiciously our own resources. Then when we have recovered the mineral values from this low grade, then we have to add cost to the process. Then we have to again obey the regulatory norms of our system, that is all process should be economically viable and environmental sustainable. Otherwise, there is no use of, I mean it is all will be violating all government rules. Then maintain the supply chain system, otherwise all the production metal industry will close down if we are not have a sustainable supply chain of raw material. Then recovery of mineral value and reuse of industrial waste into valuable product, because we are always thinking earlier to have a linear mode of utilizing of ores and minerals. Now now government is enforcing and system is enforcing us to make a circular mode. This is all we can tell zero waste process, zero waste technology. So nothing is waste, everything will be utilized as our resources. Another is mineral resource security, that is most important for our country, and we are working in that direction. So ways of mineral conservation, because I told we are all working for zero waste process and zero waste technology to recover values from ores and minerals. So mineral conservation plays a very important role, and use of minerals so in a planned and sustainable manner. Then waste reduction in all our process system. It is a mining system or our process metallurgical system, metal extraction, all the waste whatever we generate we have to reuse or have a add value to the art and use it for our use. And that is three buzzwords, that is recover, reuse, recycling. That is the main thing where we can have this mineral conservation. Then use of alternate renewable substitute. People are working to find the good substitute for the mineral which is not available or which are critical to our point. Then use of improved technology. That is all technology which is age old and it have a lot of carbon footprint. We have to reduce the carbon footprint and have a improved process flow sheet so that you use less energy, less resources to recover these values. So this is a typical mineral processing process. All this raw material, when you find raw material, then we characterize, because characterization plays a most important role. Unless you characterize, have its mineralogical, physical, chemical, all analysis, then you cannot know how it is formed, what phase it is there, how it is associated with other mineral, what is our value and what is our reject. So we have to find out it through characterization process. Then we have all process mineralogy, then our liberation procedure is there in mineral processing, how it is behaving, you have gravity separation, you have other combination process to separate the mineral. Then you have size reduction to find further liberation required. Then you have classification procedure. Then separation procedure, how to separate our concentrate, then reject, then apply for metallurgical uses. So what I told earlier, just we will be following, or we are looking for circular economy for our sustainability. Then we are getting rid of this linear economy where we are putting all our waste beside of the industry. Now people are working on how to recover value from the waste, because it also gives value and it gives also profitability of the process. the critical minerals. Coming to critical, so it is defined by Government of India. Now it has put a committee to find out what are the critical mineral for our purpose, our country, because each country has its own way of finding their own critical mineral. So manganese may not be critical mineral for us, but manganese may be critical mineral for USA or for other countries. So India has already found out 33 critical mineral for our purpose, looking to the development in our future decarbonization process and decarbonization method and decarbonization ecosystem. So we have to have these critical minerals in our as our reserve, so that we will utilize for our own benefit. So these are the some of the these are all the minerals identified by Government of India by Minister of Mines recently. This antimony, beryllium, bismuth, cobalt, copper, cadmium, gallium, germanium. So all these minerals. So the colored one I have put it here because these are the area, these are the mineral we are in our institute IMT who are working for recovering these are the minerals. So critical minerals are already defined by Government of India. That critical minerals are those minerals which are essential for economic development and national security. And the lack of availability of these minerals or even concentration of existence, extraction or processing of these minerals in few geographical locations may lead to supply chain vulnerability and disruption. Just one example I will give. Earlier China was giving us graphite. Though we have some graphite mines in India, China was supplying plenty, but now they have stopped supplying graphite because they know what is the use of graphite in future. They want to control the whole EV in that area. So battery is one component that will be used in EV. So this is the criticality. So when you have supply chain vulnerability, this here comes the criticality. So graphite is one part. Cobalt, like cobalt, copper, lithium, nickel, PG, those were all rare. It is not plentifully available. It is somewhere locally available, but it is rare, and you have to find a way to recover it for our industrial purpose. So these factors impacting criticality, the economic importance and supply risk, I don't want to go through that. But identification, the core objective of our criticality is, first is supporting economic growth and competitiveness and job creation. That is first objective. Then driving research and innovation exploration, this is the second objective. Then enhancing the global security and partnership, because unless we partner with some countries, some organization outside India where you can source this critical mineral, it will be very difficult. So this third is enhancing global. Now Government of India has already set up a organization called CABIL for sourcing this critical mineral outside India which are not available here, and raw material security for the state of art defenses. The fifth is promoting climate action and environmental action. These are core objectives for identification of critical mineral by Government of India. So coming to this data, net import of critical minerals in 2020. So we have nearly 100% import from of lithium, cobalt, nickel, vanadium, niobium, germanium, rhenium, beryllium, tantalum, strontium, zirconium. Then we have 80% import. These are the major import sources because they have plenty of sources there. And manganese also we import, though we have some manganese mines, but there is not suitable, that is a low grade, and it is not applicable for high application area like battery. And chromium we have here, but very less, and silicon. These are the critical value pillars of critical value chain, that is upstream. We need to have exploration, mining and extraction, that is must, to find out these values, find out these minerals. Then midstream is processing, refining, where our institute stands here, midstream, refining and semi-finished input metal for others. Then downstream also we are there for component preparation, clean and digital advanced technology production. So these are all coming to critical mineral value chain. Coming to the next slide, I think it is not working. So I'll be taking some time on some R&D work, whatever we did in Institute CSR IMT, and some other institutes are working on that. That is a primary sources. We try to find this critical mineral value from primary sources, that is ores and minerals, and also secondary sources, that is waste. We term it as a waste or secondary sources which we don't touch, but now we will be touching that. So coming to manganese ore beneficiation, we have some manganese ores in Maharashtra, Odisha, and these are all low grade. And we are nearly importing 50% of our demand from other countries. And these are all beneficiation process. Then we have some pyrometallurgical route to upgrade the manganese content. And these all have different product ranges to find places in different application, like alloying, alloy making, or any the battery material. Lot of these applications are there for manganese of different grades. So one of these electrolyting manganese dioxide, which is our department of hydroelectrometallurgy, it works, and it is working on a big scale to prepare this electrolyting manganese dioxide for lithium ion battery grade type. It is working with MOIL, that is Manganese Ore India Limited, and these are they are trying to reduce the impurities so that it will be best fit for battery material. So and RE rare earth element, we are not blessed with this material. We have plenty of that in a very distributed form, not in a concentrate form, because when you get RE, it is very in ppm level. So what you will have, suppose you process, so you have to, for example, in 100 kg ore, you will find only 100 grams. So what will happen to the 99.900 grams? So you have to find utilization of that waste. So it may be a construction material, or maybe some mass utilization as a mass utilization material you have to find. Otherwise, your sustainability, then what we are thinking about circular economy a lot, we cannot follow that route. So some of the areas where we try to find the primary rocks, that carbonate and pegmatic rocks in area of Gujarat. Now government of Gujarat through GMDC is trying to put a RE plant in Amba Dugra, that is near the border of Maharashtra. They put a plant to recover this RE. It is first time in India they are trying to, but it is also very less quantity. We are also depending on outside countries for this RE. Then we have very good sources from secondary sources, that is fly ash. Already our hydroelectrometallurgy department, they have worked with NALCO, and they found this lot of value in fly ash. Not only RE, but they also try to find some of the calcium, produce calcium silicate, then alumina also they are getting, then iron hydroxide which contains RE, then quartz bearing residue, then alumina. So these are all, this is a hydroelectrometallurgical process for the recovery of alumina and calcium silicate from fly ash. It is having Indian patent with NALCO. And these are the photographs showing some of the bench scale studies, and I think now they are ready for a pilot scale with a Ministry of Mines funding with an NALCO. These are very beautiful things produced from fly ash. So we know fly ash are used as a construction material, as a brick or any other area, massively cement. But now Also again 30% are not utilized. So we can have this process in a pilot scale to find out what are the economics of the process, so that all the waste from this coal ash can be utilized. So this is the typical process for recover of RE. 1 ton of fly ash can produce 200 grams of RE. This is the process already established in bench scale, and IMT and NALCO is trying to put it in a pilot scale to have its more operating parameters, to get more operating parameters. Another secondary source is bauxite residue. You may be knowing NALCO or Vedant or Hindalco, they have plenty of this. When they are processing bauxite, they are producing red mud as one of the process, and red mud contains very value material, but since we are having lot of alternatives, we are not touching that. But time will come when we will get this residue to work to have value addition and find out iron, alumina, then also these critical minerals from that. These are the processes. IMT along with 3 national labs, that is CSR NML and JN RDCC, that is Nagpur, they are working for the process, and also this industry NALCO, Hindalco and Vedant, they are involved in this technology development. And I think once this is a process is coming to a stage where they will put a pilot plant to have recover these values from red mud. Then cobalt, nickel, tungsten, these are all critical minerals for us, and from secondary sources like another primary source is polymetallic manganese nodule, which is in our seabed. So IMT is involved in the Ministry of Oceanography, that is to collect this polymanganese nodule, which is having this copper, cobalt, nickel and manganese in it, and we have a metallurgical process to extract this copper, cobalt, nickel, manganese from this, and it is in a pilot scale. I think it is still work is going on to make it in a better way, how to recover in a better way. And technology for tungsten metal production from the waste of gold mines, the Hoti gold mines, we recover through beneficent process concentration of this tungsten mineral, then we process it through hydrometallurgical route to make it a metal, tungsten oxide to tungsten metal. Then in Odisha we have the maximum chromite, that chromite mines we are having in Sukinda area. The chromite overburden is having some nickel percentage, so that is very less, that is 0.5 to 1% nickel it is having, containing nickel. So we had a big pilot plant in our premises to extract nickel from that, but it has also created a lot of waste. So we found out process to utilize that waste, that is a magnetite and other waste, so that it will be economically sustainable. So this nickel, whatever we process, we got the nickel, that is recovery of nickel ratio is 96%. Of and the iron also we get 63%. So we have a lot of application for these values, whatever we get it from this processing of this tailing on overburden of chromite mines. These are lithium another here, because it is a buzzword now, because it is battery material, it is used as battery material, but India is not blessed with any lithium mines. I am telling you, it is commercially not viable, any lithium whatever available, it is very less quantity and less percentage, so that it is economical not viable to produce, better to have a source from outside and produce it here. And we have IMT has having process of beneficent process, and including beneficent and hydrometallurgical process to recover lithium carbonate and to make lithium carbonate and lithium oxide for this recovery of values from lithium ore. That is a pegmatite ore from Ankleshwar, that is Karnataka area, and so Bihar mica cyst, that area we collected some of the samples, but it is not available for commercial exploitation. Then we have lot of batteries because we use mobile, we use laptop, we use this battery for different purpose, and it is all thrown. But we have processes in a very small scale how to utilize this to collect this spent material, to separate this material and reuse for again making these batteries. So some of the processes in a very small scale people have done it in our lab, and we try to have this in a big scale. Some of the companies are coming to take it up to the larger scale. Let us hope for the best to have process of recovery of battery material from spent lithium ion batteries. Then recently we got a very good project from OMC. You know, OMC, that Bola mines and other area, they are having PGO, some presence of PGO, the platinum group of elements in that ore. So we did some work in a bench scale. We found very good recovery of this PG from 3.8 ppm to 79.3 ppm level. So government of Odisha is more interested to have this because it is very critical mineral, and also we will have our own source of PGO. This PG platinum group of element, that is platinum, palladium, ruthenium, rhodium and iridium and osmium. These are all available in Odisha, and we are going to have a pilot scale of 100 kg scale, because it is all bench scale you get it, but 100 kg scale once you have, then you can have a lot of operating parameters with you, then you can have your economics, you can study your economics, how it is beneficial, suppose OMC is putting a commercial plant. Then high pure quartz and silicon from natural low grade quartz. That is the silicon. We don't, unfortunately in India, we don't have any silicon producing industry here. We all import. You know what is the use of silicon in all electronics and other high end instrument and material. We won't require silicon as a base material. So these are all we have a beneficiation process. Then we have a reduction smelting in arc furnace. We got nearly 99.9% purity, but we require more. It is 99.9949. So we require good R&D, investment in good R&D to prepare that, but it is a very preliminary stage. But we hope that scientists of INT will do it with support from ministry or any industry. Then prepare some silica acid is another area where we do it with CSR-NL, that is National Aeronautical Lab, for application in aerospace or aerospace industry. We have a electrospin equipment where we create silica fiber sheet and produce silica sheet, and this utilized conductive polymer is used to make fiber sheet fabrication with polymer, and these are characterized by null for application in aerospace. So whatever it is all coming from mineral sources and find a good application in our high-tech area. So these are the area, but I'll tell you graphite. Graphite is a very, you know, we from childhood we seen the use of graphite through pencil and other area. We have found in battery we found graphite. It is a 3 distinct types of natural graphite occurs in earth crust, that is flake graphite, amorphous graphite and high crystalline graphite. In Odisha, in India, you will have graphite deposits in Tamil Nadu, that is huge deposits. That is a commercial plant is working on 28 tons per hour capacity. Then Odisha have pocket deposits, graphite mines are there. People, small industry, they are working to recover graphite from these ores. And I will not go to details that what is the use of graphite as a non-metallic mineral. It is having a lot of large number of application as a graphite as a mineral. So we have process flow sheet, and you know graphite having a different products. You know, high flake graphite, that is if size is big, then you have high value and high application. So we have to keep a note of while processing the graphite ore, you have to find a way to preserve the flakiness to preserve the size. So we have a process flow sheet through physically beneficial graphite, and to have different products which is having which is going to have or is having a very good application in different areas. This is another process where IMT is having a patent, that is high pure graphite. We make it a 99.99% carbon graphite for application in high tech area, like graphite as a battery or any other area, or as a lubrication in our mechanical system, or adding some nano graphite to oil, I mean fuel, what we are running out in a vehicle for more efficient burning and more efficient energy extraction. So these all are use of graphite, and we IMT is having a patent for this high pure graphite using alkali for leaching, and then physically separating the carbon value. These are all some marketing things. High purity flake graphite, when carbon content is 99.9% over there, but particle size is 3 micron to 500 micron. These are big particles, and these are all applications. It all application you will find vast application in different areas. As a lubricant, as a ceramic material, or as a additive metal for plastic and rubber products, the raw material for graphite foil, then fuel cell application, then high temperature coating, then high quality synthetic diamond. Then we have microns. I mean these are particle size plays a role, and also cost. When high particle size, I mean more particle size more than 75 micron, 100 micron cost you nearly 2 lakh rupees per ton, but this fine material also cost you more than that. Then from graphite we have expandable graphite, and it is used treated in nitric acid and some other solution to expand the volume of graphite, okay, and so that your density goes down, and you have a high application in some other area where thermal insulating area or any other area, and this expansion volume is nearly 100 to 300 milliliter per gram. And this another is colloidal graphite. With nano graphite we use colloidal material as a base material, as a water or oil or alcohol or glycerol, and we find different application for that, and people in India have already put a lot of plants using this colloidal graphite as a base material to produce this produce with this solution. These are all lot of applications are there. So coming to graphene material, so thing is that graphene, it is a already lot of people are working in graphene material, but I am talking about only graphene produced from graphite. And interesting is that with this graphene material produced from graphite ore does not require any chemical treatment. CBD and other chemical methods are there to produce graphene oxide, but this graphene oxide, whatever we produce in IMT, and also some private institutes they are also producing now, that requires only milling, through mechanical milling, because graphene, suppose you take an example of book is a graphite, but the pages are graphene, okay, just think in that way. So we have to find the graphene, I mean to take out, how to take out these leaves from the books. So we have mechanical system, and already in our institute we have 4 jar system and 2 jar, the planetary ball mill system. We have small jar, but we in our institute is a big jar having a 4 liter volume of 2 jar, and it is a planetary milling unit where both the jars rotate in one direction and the whole system rotate in the other direction, and it creates a G inside the ball with the jar mill, so that it will have a high impact on the particle to take out this graphene material. But this is the, I think this is graphene oxide from natural graphite is mechanical milling. That's why I told the graphene material what we produce, it is from purely from mechanical point of view. Now we don't use any chemical or harsh chemical to prepare it. These are our properties. It's all available in book. I'll not go through that, but I'll tell you one thing. These are the some of the analysis result what we get it from different sources. It also depends on different sources. Graphite from Odisha sources will give, will have a less graphene metal preparation ratio than graphite from Madagascar and Mozambique. We found it that. So we find in SEM image high purity graphite how it looks like. This TM study, it find in 10 nanometer also you find this seeds type thing. It is showing this type of seeds, and we find this having good quality which we can use it with a different material to produce a different effect on other material. So these are all specification whatever, and these sources I am thankful to International Prangraph Private Limited company, which has already taken over 2 mines in Madagascar and Mozambique to produce graphite in a big way, and they are importing that graphite to India, and they are having a value addition in India, and their one value addition is graphene oxide preparation. This is another sample. The other is graphene aluminum. One work was done by this group on graphene aluminum composites, which is to replace the copper, increase the conductivity of this composite so that copper can be replaced. But only 70%, 65 to 70% conductivity they could find, achieve, and still work is going on to achieve more conductivity as far as copper, and this is done in mechanical milling. No any other method on mechanical milling. So another composite people have worked on that. This is aluminum graphene composite coating on mild steel. This coating on mild steel to improve the quality and improve the properties of hardness and young modulus. Then this is also done by this milling, planetary milling method, and the property we know this coating is done by plasma touch technique, and you find this through this image you'll find the bare steel substrate, and also by mixing graphene with this alumina in the ratio of 1 gram or 2 gram or 4% by weight. Sorry, 1%, 2%, 4% different weight percentage. They found this quality of this aluminum composite coated steel is better, and it gives a very good result as far as steel is concerned. And these are the analysis report where we find this morphology of aluminum in the 4% weight graphene coated steel with graphene distribution, and no defect in coating is observed. These are the preliminary studies, and it will have a lot of future in this area. So these are all the analysis report where we get this young modulus nearly 370 BHN and gigapascal to nearly 300 gigapascal respectively from 200 gigapascal when you have a coating of this aluminum graphite material. Then also some work is conducted in silicon graphene composite just to have a battery, replace the battery metal graphite from the battery material as to replace silicon, but silicon is having a weakness, that is it expands when it is charged, and that's why suppose you mix graphene and do it, we found some of the theoretical capacity it increases nearly 3578 milliampere hour per gram we found using lithium and silicon composite. So these are some of the application. I think it has a lot of future when you go in a big scale, and I think India will have a lot of future, and India scientists in IMT and other institute, they are also working to find this application. And I think these are the area where we control the criticality of the mineral, what we get, the way we use the criticality as a term as a criticality, but judicious use of this mineral and material, we can have our own reserve of source to find a lot of application in future area of development. So one application of graphite oxide is cement. We found is added at nearly 0.3 to 0.5%, and you find the settling time, you know, M20 structure of cement RCC is increased to M50 with the few addition of the geo in that cement concrete slurry. These are also these all are working, and this I mean these are all lab scale and bench scale studies. No industrial industrial scale has been made, but future is there to have industrial scale. So I can come to the conclusion that minerals are indispensable part of our lives. Almost everything we use is made up of minerals, and minerals are finite and non-renewable. So we have to be careful about our uses of minerals, and also we cannot restrict our economic development due to restriction of minerals, but we will have also economic development, and this sustainable development is most of our as meeting the needs of our present without compromising the future generation. Though we will require a balance to attain this, and we have to see our environment, see our economics, see about the resources. So coming to another conclusion, that total of 17 elements, these are having a supply risk and having high economic importance for the country. This cobalt, graphite, lithium, Pg, nickel, tin, phosphorus and gallium and other niobium, magnesium. Out of this a total of 7 elements, that is highly supply risk, we don't have anything. That is Re and bismuth, germanium, indium, tantalum, vanadium and rhenium. Similarly, 9 elements have a very high economic importance, which are copper, silicon, titanium, potassium, molybdenum, tellurium, zircon and selenium and cadmium. However, 3 elements, namely manganese and boron, they are all critical, but we have plenty of sources in our, we don't have a risk of supply risk, but we have to use it judiciously for our own purpose. And borax, we find a very good substitute to replace borax in glass and porcelain industry. So it is right time to shift the focus from consumption to conservation. Time has come to think how much we consume, not consume the natural resources by judiciously utilizing, using innovative technology, adopting phenomena of reuse, recycle and maximize recovery. Then development of new technology has outpaced our knowledge of how to extract available resources to match the demand. Then sustainability of a given resource could potentially be improved using innovative mineral processing technology, and reject of one process may be utilized as a feed for the other process, that zero waste technology. I am grateful and thankful to CSR IMT for their contribution in this field. Also Dr. K. Sanjay, Head HEM, then SP Das, Chief Scientist, those who have contributed for this preparation of this presentation. Also I am thankful to International Prangraph M.Tech Research Center placed in Bhubaneswar, those who are working on graphite, and they are going to put a plant of graphite for spheroidal graphite and expanded graphite, which will be used for battery application in Odisha. And also thankful to CSR NML, CSR NL, who are associated with for this R&D work. Also thankful to CIPET and RAMM-2023. Thank you very much for your kind patience.
Thank you, sir, for your very good, excellent and informative lecture regarding materials, minerals, like that. Today discussion, sir has given various sources of the materials, along with different states, and percentage of the percentage wise composition, and beneficial of this material for the sustainable development nowadays. It is very important part today. So critical material, very rare earth element materials nowadays used in various industries for various application and their process. Now I am requesting from audience side, if any question from your side you can ask sir, because sir described very good information regarding minerals, so you can ask question
Hello.
from audience.
I have one question, sir. You are telling regarding graphite. Graphite is a brittle material, and graphene, you told it is 200 times stronger material. So what are the molecular changes or internal changes happen from graphite to graphene?
Okay. It is a 2D material.
Yes.
And actually that
Is there any internal molecular changes happen during
no, there is
extraction
no
of like
internal
that?
change.
Not like that. So how it is?
It is a form, it is a pack of graphene with formed graphite, okay. It is all geological formation, but when you find some application, it is I mean the finding of graphene is a very, it is accidental, okay.
Graphene is the byproduct of graphite, no?
No,
So how this graphene comes?
graphene is not a byproduct of graphite.
So it directly extract from graphite to graphene.
Yeah, it is a directly external graphite, and it is a pack of graphenes makes a graphite. Okay, just think in that way.
Okay.
So it is a layering material, and when you pack it, just like I told you in a book, leaves, pages, pack it is called a book. It is just like that, and is having maintaining that properties, but the properties are astronomically it is better than.
Okay.
And it is better than the graphite. That's why the formation of graphite, as you told, it is a very raw application, but graphene is having very high precision application in mineral sector and metal sector.
Okay. But graphene is a strong material. You are saying it's not brittle.
Yeah, it is strong material. It is in a nano level. It is a strong material.
Yes.
Yeah.
So that is why I just asked you what are the internal changes happen during this process.
Some molecular, actually, I'm telling you, I'm told about broadly about this area. So deeply, I've not worked, but broadly, whatever work I've done in a mechanical way, that I've done. That all this milling is my development. I mean, I worked for a scale up of the milling machine, so that I can tear out, I mean, leave out, I mean, take out all this graphene metal from graphite, and this works very well.
Thank you.
Thank you.
From audience side, any other question? No. Sir, I have one question from my side, just my queries. Sir, can we extract active carbon from your graphite, which can be suitable for the application for the removal of arsenic and fluoride? Nowadays, arsenic and fluoride is a global issue, and few areas of West Bengal, particularly Odisha and Andhra, the drinking water, along with drinking water, particularly in the rural area, arsenic and fluoride is coming. So this is a hot topic nowadays.
The specific area of graphene is more. You find so people have used graphene as one of the component in preparing some material for absorbing this arsenic. And I think IMT, some scientists are working on that. They are using graphene as one of the material to increase the specific area of that. So graphene having a lot of specific area which absorb this arsenic and other fluoride. People are working on that.
Okay. Thank you, sir, for your nice presentation and excellent informative lecture for today's first session. Okay, thank you, Professor Ashok Kumar Shah.
Thanks, sir. Thanks for your nice lecture. With the rapid depletion in the coal and oil reservoirs, there has been a demand for renewable energy resources and batteries, supercapacitors, this energy storage, conversion devices. They have a key role, and there comes graphite and graphene, which importance all of us or most of us are aware, and sir has extensively told about the extraction of graphite, graphene and minerals. The minerals are the starting source for materials, and then we will be manufacturing the products on which we have focused during this 2 days of national conference on recent advancement in materials and manufacturing. Thank you, sir. Now I request Dr. P.K. Mandal to felicitate our plenary lecture, Dr. Ashok Kumar Sahu, sir. Thank you, sir. Now I request Sri K.K. Mahapatra, sir, Director and Head, CSTS Balasore, to felicitate our session chair, Dr. P.K. Mandal. Sir, please. Thanks, sir. Now we will be having the presentations by faculty, scientists and research scholars, their contributory papers. So the session will be chaired by Dr. Akshay Kumar Pallai, and now I request Dr. Trupti Ranjan Das, the co-convener of this conference, to introduce Dr. Akshay Kumar Pallai. Sir.
Thank you, Dr. Syama. So, good morning, delegates. As you know, we are going for a parallel session right now. One session is here, and I am fortunate and I am honored to introduce the session chair of this particular session. Let me introduce Dr. Akshay Kumar Pallai, currently working as scientist, CIPET, SRP, LRPM. And Dr. Pallai did his PhD in polymer chemistry from University of Mumbai. Then afterwards, he joined the prestigious Tata Institute of Fundamental Research, TIFR, as a postdoctoral fellow in Department of Chemical Science for a year. And subsequently, he moved to South Korea and joined as a KU Brain Pool Research Professor with a prestigious KU Brain Pool Fellowship. And he carried out research and development activities on particularly organic electronics for a period of more than 3 years, and then returned back to India and joined CIPET as a scientist in 2014. And he has bagged several national awards, 2 times national awards winner for technology innovations in petrochemicals and downstream plastics processing industry. And he has more than 60 number of peer-reviewed articles and patents. He has guided numerous number of master theses and PhD theses. And if we talk about his current area of research or domain of research, his research area included in the development of organic semiconducting materials, advanced materials for energy storage and harvesting applications, and small molecule organic fluorophores for multifunctional bio applications, and covalent organic framework for photocatalytic hydrogen evolution. So it's my pleasure to welcome Dr. Pallai to carry forward the session. Please, sir.
There is one announcement. This session will be on theme materials. There is another parallel session on manufacturing at 2nd floor conference room. Those who are interested for the manufacturing theme lectures, please proceed to our 2nd floor conference room. Volunteers are requested to guide the participants. Thanks, sir.
Thank you, Dr. Das, for your introduction. A very good morning to all of you. I am Dr. Palai. On behalf of organizing committee, I welcome all the participants to this 2 days national conference on recent advancement in materials and manufacturing, RAMM-2023. This session, the same theme will be continued as we continue for the parallels for the plenary section. This session theme will be materials. This consists of 5 lectures, and I will name those speakers. Please confirm whether they present, and I request them to be they will be ready with their presentation, and the lecture will be allotted for the 10 minutes. Please stick to this timing. First lecture will be from Dr. Akshay Kumar Behera. Next will be Abhilash Swai, then Amulya Ratna Panda, Ritupanna Rao, and then M. Sanmukha Rao. I hope all are present here. I welcome first speaker, Dr. Akshay Kumar Behera, to present his lecture.
Very good morning to all. Jai Jagannath. We are at National Conference at CIPET IPT-Bhubaneswar, recent admin in material and manufacturing, respected Director General and CIPET fraternity. Being Ram Bhakt, being Hanuman Bhakt, being Desh Bhakt, I want to sing this. Jai Raghupati Raghav Raja Ram Patita Pavan Sita Ram ईश्वर अल्लाह तेरो नाम सबको सन्मति दे भगवान रघुपति राघव राजा राम पतित पावन सीताराम. Thank you. So being a part of organizing committee, I expect that everybody will take some message out of this national conference. So my talk will be not in details to the core engineering, rather science and motivating. So I was a research student as well as I completed my study career and joined CIPET Bhubaneswar as an assistant professor. Basically my background is physics. You know that engineering is the application of basically physics. Fundamental science, physics and chemistry are the fundamental science. And to understand CIPET, may not, it takes time actually. So since I have been in more than 1 year in CIPET, I want to tell you about this organization. So CIPET has crossed 50 years. So it is a basically star institute. We call it the skill, technology, academic and research. And this is the organizational structure. So head office at Chennai. So if you deal with the plastics, so many codings are there, polypropylene, polyethylene. So these are polymer means these are mostly related to chemistry. Whatever previous lecture was there, mostly related to chemistry. Unless you understand chemistry, so very difficult to handle plastics and polymers, which is dealing by CIPET. So myself, Dr. Akshay Kumar Behera, basically my research interest is accelerator physics, electron spectroscopy, quantum mechanics, nanotechnology. So my topic will cover introduction to organization, my research work, fundamental concept of physics, technology support and lifelong skilling. If you look at this, ये श्लोक है जिसमें सारे स्टेट्स का नेम है. राम नाम जपते अति महसूस गाओ पंख में उगवहमी के छवि जाओ. इसमें सारे स्टेट्स का नेम है, वो ओडिया में लिखा गया है. Basically, what is plastic? It is defined as the organic material that has its ability to flow into desired shape when heat and pressure applied and retain them withdrawn. Mostly they are plasticizer filaments are there. Then, so why plastic? Because it is lightweight and strong and cost effective. Why it is? Because these properties they have, elasticity, stiffness, all these properties are there in the plastic and polymeric material. A plastic or polymer or commonly rubber, they will follow Hooke's law. Hooke's law is the spring. The physics and mathematics is there. So we can characterize them through structural, optical, electrical, like SAME, XRD, SQUID, superconducting quantum interference device. If you understand, this is actually universe. We are interested in materials, engineering, and manufacturing. So how to, where is the sources? What is your motivation to work in this? So these are the earlier scientists that whatever textbook we read, their theory, their concept, their findings. What should be next interest? If you want to work first, then work alone, according to Ratan Tata. But if you want to work further, then work together. You cannot change your future, but you can change your habits. Surely the habit will change your future. So basically, these are the motivation I am saying. So physics is the broad thing, then it's under cosmology, then astrophysics, biology and chemistry. So astrobiochemistry. Basically, if you understand a star, planet, star has also birth and death. So life cycle of a star also died. Stars are nothing but hydrogen, fusion, so sun we see. What Einstein and their scientists give us information, how it is used in our application. So that is in engineering. This is Einstein field equation. If you understand, it's good. We also worship, our motivation is God. So God actually Bhagwan bolte hain, lekin ye bhumi, gagan, vayu, agni, earth, sky, air, fire. These are all filled with materials. Where is the materials? So this is your environmental science. Ethics, biology, chemistry, atmospheric science, oceanography, geology, sociology, history, political science, engineering. That combined is your environmental science. Basically, these are the 17 mathematical equations that concept changes. So everybody analyze these equations. What is second law of thermodynamics? So where we are working. So length scale, the material length scale basically changes. When you call nanometers length scale, it's called nanomaterial. So quantum physics is playing role there. So chemistry people work in this length scale. Astrophysics, the material science means all length scale. So material means it has engineering application, mechanical, electronics, telecommunication, electrical and robotics. What I did my research careers, take a sample and radiate with laser, get the spectrum. So Raman spectra, X-ray spectra, basically characterization of samples. We understand that Rutherford experiment, scattering experiment. Raman also did scattering experiment. We call nanoparticles. The dimension length scale basically changing. So it's called nanomaterials. So graphene is the carbon compound. If you particles again further, these are the standard model that there are number of particles within the subatomic length scale. How a material is understood? By XRD. XRD will always follow Bragg's law of X-ray scattering. It is X-ray diffraction, which is 2D sin theta is equal to n lambda. D is the basically this crystallographic spacing where atomic dimensions are measured. How lattice arrangement is there. So nanotechnology means manipulation of those material in nanometer length scale. Why nanotechnology? It has this kind of so many applications. So carbon nanotube, say lacquer, metallic, non-metallic, ceramics. In biologically, length scale also varying. So these are the fullerene, carbon nanotube. So graphene is, last one is the graphene. If you irradiate So photoelectric effect tells that light falls on metal, we get a photocurrent. So it is a light matter interaction. When it is a same or tame, it is a electron matter interaction. But we are dealing with the ion matter interaction. What is the, when a ion is incident in a material, what happens? That is my research. So nanotechnology has other application in agriculture also. Why? So matter, we have duality. We have to understand light, we have to understand electrons. Because there is a dual nature, duality. And wave, so quantum mechanics is coming, so we have to understand quantum mechanics. Why nanometer? Because surface to volume ratio basically increases. इसलिए nano material के ऊपर लोग काम करते हैं. Why? Size dependent properties, मतलब length scale को अगर low dimension में जाएंगे, these properties are distinct. So thermal properties, mechanical properties, optical properties, electronic properties, these are distinct. So we try to understand nanomaterials. And these are band structures. These are density of states. There are 3 dimensions: 0 dimension, 1 dimension, 2 dimension, 3 dimension. 0 dimensions are called quantum dots. This year Nobel Prize is quantum dot. And attosecond laser is the physics Nobel Prize, and quantum dot is the chemistry Nobel Prize this year. So I work in the field of accelerator. What are accelerator? Basically particle accelerator. How do ion will be accelerated and irradiate in the sample, then we get the material modification, then properties are understood. So worldwide several accelerators are there. Institute of Physics is having one accelerator and accelerator. Accelerator means how to take the ions to high energy. So this is sample studies by radiating laser. Laser means it is a light matter interaction, but ion matter interaction is our study, interest of study. What happens when an X-ray is going to penetrate, when of different energy, 20 mega electron volt, 4 mega electron volt, so depth penetration is about 15 centimeter. So red one is the proton, but the bluer X-ray, and these are electron beams. And this is the Raman scattering, which is the Nobel Prize in Physics, India. What happens in electron matter interaction? These backscatter, secondary emission, X-ray characteristics, visible light, Bremsstrahl lung. This is the formula, mathematical formula to understand electron matter interaction. Sorry. So what happens in ion matter interaction? Ion penetrate in a material and get slower and reside inside it. So it is called ion solid interaction. But photon matter interaction, the nucleus, it will be scattering. So it can be understood by Bethe-Bloch formula to understand the stopping power, how it is stopped. Saha ionization equation, Saha nuclear physics is ठीक है. So I did this kind of experiment. This is my ion beam experimental apparatus available at IIT-Bhubaneswar. I did the simulation how ion is going to impact. So TRIM means transport and range of ion in matter. So these are ion is a simulation studies that how ion is penetrating inside the material. These are 2D plot, 3D plot. So these are the nanowire where the irradiation takes place, and the modifier structure is a tame image, optical characteristics, and Raman spectrum is there. Simulation result. Actually, we have to understand electromagnetic spectrum. So these are the physical constant, scientific constants. What are cyclotron? What are basically European countries? They do this particle accelerator. A ion implantation system is like this. So linear, this way particle is getting accelerated. Linear means linear accelerator. The particle will go straight. If it is cyclotron, it will circularly rotate. So God particle is there. So Large Hadron Collider experiment was there. This is the mathematical formula where Stephen Hawking told that the entropy formula, pi mathematical constant, A is the area of the horizon, K is the Boltzmann constant, C is the velocity of light, H is the Planck's constant coming from quantum mechanics, G is coming from the Newton's law of gravitation. So So all these material properties can be studied. Magnetism, electricity, charge, heat, topology can be studied by ion matter interaction. Basic electronics you have to understand. So length scale, material length scale will differ for different applications. So this is the graphene. If you want to understand graphene, then only you can understand polymer, then only you can understand plastics, then make it product. So graphene is the nowadays interest material. So it has a wide application because biomedical coating, composite, sensor, supercapacitor, then batteries, quantum dots. So it has a 0 dimension, fullerene, carbon nanotube, graphene, diamond and graphite. Why? Which materials we are using? For what product? How it is processed? What are the instruments used? So CIPET has some facility to manufacture those. We are interested in electrical vehicles. How it can be made? Which material is suitable for it? Recently, it is successful. That story you know very well. Now it is the 5G. Our science should relate to society as well as should develop technology. So CIPET has the mission visions, work on the STAR concept. It has the training department, tools, processing, testing, like this. So polymer, one has to understand. So natural polymer, synthetic polymer. So products. Then how petrochemicals. Petrochemicals. We have to understand chemistry. So chemistry mein functional groups are there. How which reaction takes place and the interconversion takes place. A chemistry person know better. The organic molecule means there are basically 4 types: lipid, protein, nucleide, and carbohydrate. So they are polymer, monomer, and they are polymer. We understood that these are chloroplast, chromosome. Our DNA is a biopolymer. Polymer are categorized commercially for manufacturing and business. The coding is a PET, HDP, like this. So products are there. So these are the actually natural and synthetic polymer. Synthetic polymers are basically called plastics. So these are the products we make in our facility. Technology support, whatever the engineer or science, one has to understand. So how plastic is recycled. So these are the used plastic in the data from internet available. So plastic money, we are using the card. These are all plastics. We never, so no plastic and no plastic. NO plastic and KNO plastic. How production can be done, what are the facilities should be there. So my life learning, so 2 minutes only. So we should understand what are the, earlier we have been set to set our life. शांति से रहना है, स्वच्छता रखना है. Life is like a camera, focus on what is important, capture what is good, develop from the negatives, and if you don't work, take another shot. Increasing your materialistic position in growth. Growth is added by ethics, that is discipline, honesty, norms, and called progress, and the progress plus humanity, morality, spirituality is called success. Thank you.
Hello.
Yeah. Only one question, please. We are running out of time.
Hello.
If there is no question, let's thank to Dr. Behra. Our next lecture is from Abhilash Swai. He's there? Okay. The topic of this lecture is application of metal foam in thermal management application. Please stick to the time, 10 minutes only.
Okay, so respected dignitaries and participants, good morning. Please, my slide. So myself, Dr. Abhilash Swain. So I'm working as assistant professor in KIIT. And I've done my B.Tech from IPT-Bhubaneswar and PhD from IIT-Bhubaneswar. And basically, my research area is on heat transfer and thermal management of devices. I'm not so into material science. So we have been granted with a DST project on application of metal foam in boiling heat transfer. So that's why we carried out some review of these materials. So that's why I thought of presenting this topic on before you. Yeah, thank you. So this is a metal foam. So you can see the structure is very much similar to the foam or sponge you see, which is of general domestic use. So but instead of that sponge material, here we have metals. So generally aluminum, copper and nickel, so these are used as base material, okay, and so you have a very porous structure, okay, just like your sponge. So you have so the it is not okay. So these are the various properties of the metal foam. So it is of lightweight and you get a very high surface area in the same volume. Okay, so that's why, because it has a porous structure, the voids are there, so it can easily absorb the suck. Okay, so there is no solid, so you know the momentum changes takes some time, so it can absorb suck. So that's why, you know, it can be applied in helmets and all those shock absorbing structures. So as there is void, so air gap fills in the void space, so it can act as a thermal insulators also from some application. So sound absorption, structural integrity, buoyancy and different customization application also can be done based on the same structure. So one good thing is that the same metal foam can be applied as thermal insulation because of the air voids present in that, and also if you attach it to a hot surface, then you get a contact and the solid structure, so that it acts as a fin or extended surface through which, you know, thermal dissipation or heat dissipation can be easy. Okay, so it serves both the purpose. So these are various porous materials, okay, through which, you know, fluid flows and you can transfer the heat through convection mode, and similarly it has the porous structure. So by allowing air to move through that, okay, so you can use it as a heat exchanger or dissipating material for heat reduction through convection. So convection is normal fluid flow through the structure. So these are various manufacturing process through which metal foam can be manufactured. But the irony is that you know, I could not find a single manufacturing plant in India which manufactures metal foams, and it is abundantly manufactured in China, and they are using it as your architectural application, like sound absorbing in the walls. Okay, so it is that cheap as your normal foams what we use in auditoriums and halls. So these are different characteristics of metal foam. So it has the pore size is one of the important parameter, and the strut diameter, the wears what you see, the diameter of the wears, and porosity. So what is the relative density, and the thermal conductivity is one of the important factor as far as your thermal management is concerned. So obviously you have a large surface area to the volume space. Okay, so that is the biggest advantage in thermal management application. Thermal management means just day by day your application of electronics is increasing. So if you have a chip, then definitely it will produce heat, and the heat needs to be removed out of that. Otherwise, if the chip temperature goes beyond 80 degrees Celsius, it is not going to perform good. Okay, so that heat needs to be removed. Okay, so that is called as thermal management application. If you see your computers or laptops also, so you will find a heat sink above your chip. Okay, so that is the thermal management. So these are used as the heat sinks. Directly they can be used. In two-phase application, two-phase means you have liquid getting vaporized also. So in that application, we have got the grant. So we are going to work on that. So these are the various porosity materials. So these are various observations we have seen. This is a comparison with respect to plane surface. You can see the H is the heat transfer coefficient value. Okay, so H represents the rate of heat going out of a surface. Okay, so you can see you have a very comparatively large amount of heat transfer. If you see nickel foam is having more H than plane surface, and the blue line is copper foam, which is having much more heat transfer coefficient than plane surface. So these are different literatures. So you can see here, this is the metal foam above which the boiling is happening. So boiling is important from thermal management perspective, because if you compare the H value, so in normal convection, if you have a single phase liquid, either it is a liquid or a gas, the H value will be of the order of, let's say, 400, 500 and go up to thousands. Okay, but if boiling is there, then you have the absorption of latent heat of vaporization, which is very high as compared to the H value, means convection value. So it is of the order of, so H will be of the order of like it can go up to 10,000, 15,000 like that. So there is a huge different or magnification of H value. So that's why boiling nowadays is focused on application in thermal management side. So and the point is, if you have a large surface area, then the boiling is magnified. Why? Because the bubble formation occurs at very discrete points which are called nucleation sites. Okay, so that is the roughness. If you have a roughness and you have cavities, so bubble will be forming on those cavities. Okay, so if you have high surface area, then the number of cavities will be more. So one factor is that. Second is that because of the extended surface, so it will act as a fin or large surface area through which heat can be dissipated. And third point is, because of the porous structure or the gap-like structure, once the bubble gets removed from one place, so there is entrapment of liquid again to that same cavity. Okay, so that is beneficial in case of metal foam. It is easy because you have packets kind of structure.
Sir,
so
you have 3 minutes.
Yeah, sir. So this is the advantage. So you can see, so if you increase, so it has a significant effect on boiling heat transfer. The high porosity metal foams create a large surface area for boiling to occur. Enhanced surface area promotes nucleation sites for boiling, which means more bubble can form and express, leading to improved heat transfer. Additionally, interconnected pores facilitate better fluid circulation. That's why replenishing the coolant around the heater surface. So these are the advantages. But at the same time, if you take much thicker metal foam, it will add to the conductive resistance. Okay, so your convection and that will be problematic, and bubble forming on the lower surface cannot dissipate easily. So these are the disadvantages. So that's how we think that this will be the future in thermal management of electronic devices. Thank you. Any questions, please?
Okay, thank you, sir. Only one question from audience.
Yes.
Good morning, sir. So what is the main difference between the metal foam and the normal foam we use? And sir, an example of the usage of metal foam over the normal foam, means in which it has replaced the normal foam in today's day. Is there any kind of example of that?
See, the first thing, the difference is normal foam doesn't have a strength. Okay, so that is the problem. So the one of the example direct where you can imagine is helmet, the inside foam of helmet. Okay, because it is soft, so once the outer surface breaks, okay, it doesn't get time to hit your head if something outside is hitting. So if you have a metal foam, it will absorb the shock, but it will take time. It will longer take time, and it has a strength also. So it can prevent that damage. So that is the one example you can imagine. Otherwise, it has different application because a normal foam doesn't have the strength to bear certain thing. Okay, that is the thing.
Sir, as you gave the example of helmet, helmet is a thing that we use in our day-to-day life. Then, sir, why there is no manufacturing unit of this metal foam in India? What is the main drawback for that, or what is the lacuna that we are not able to develop a manufacturing unit for this metal foam?
That is, I'm also not sure why it is not there, and probably everything is going on in the traditional way and nobody has thought of, and last few years this has been developed by China in a big way, and let's see, I think one of the scientists has recently, they have thought of getting produce it commercially. Okay, so that facility I think is lacking, so I think it will develop in next few years. Let's hope. Thank you.
Thank you, sir.
Okay, thank you, sir.
Thank you so much. Thank you.
We'll move to the next lecture from Amulya Ratnapanda. The title of this lecture is Multifunctionality Exploration of Dye Substituted Nickel-Based Iron Oxide, an Efficient Bifunctional Electrocatalyst towards ORR, OER. Okay, you can continue.
Good morning to all dignitaries present over here. I am Amul Ratnapanda, research scholar, Ravenshaw University, present before you to present my topic, that is multifunctional exploration of device substituted NiFe2O4 for a bifunctional electrocatalyst. With increasing populations and rapid development in economy, growth, there is need of energy, and the energy exploration what we are using is because of non-renewable fossil fuels. So technology driven has also came into picture for energy conversion and storage, and that comes the fuel cell. Fuel cell is a device that converts chemical energy into electrical energy. So basically I am working on fuel cell, that is bifunctional behavior, that is OR and OER. My contents are introductions, material synthesis, material characterizations, result, conclusion and reference. What is basically fuel cell? Fuel cell is a device that converts chemical stored energy into electrical energy. As you see here, this is a direct methanol fuel cell. We are using methanol as a fuel, and in the cathodic side, anodic side and cathodic side, the methanol is converted into carbon dioxide with H plus in the direct methanol fuel cell membrane. The H plus is carried out, and the oxygen, the electrons, and they are combining with H plus and they are releasing water. So this is the overall reaction of the anode is CH3OH plus water, CO2 plus 6 H electrons plus 6 H plus. The 6 H plus is been transmitted through a membrane, and the cathodic reaction is oxygen reduction. 3 oxygen is reduced to water. This is a mechanism of ORR. Basically, what is ORR? ORR is oxygen reduction reactions, and OER is oxygen evolution reactions. These the basic mechanism of ORR in acidic, in alkaline medium, in aprotic solvents, and OER in acidic and alkaline medium and aprotic solvents. There are basically two pathways for an OR to take place, a direct 4-electron pathway or a 2-electron pathway. The 4-electron pathway will give H2O as a major product, and the 2-electron pathway will give H2O2, hydrogen peroxide, as a major product. Basically, the first OR in acidic solution is 4H plus, that is 4-electron pathway. And the second H2O2 production is 2-electron pathway. In alkaline condition also, the 4-electron and 2-electron pathway came into picture. Now over here also, if you see, it goes through the 4-electron pathway for the oxygen evolution reactions from water molecules. Over electrocatalyst. Basically, electrocatalyst has been used for so many years, but there is first electrocatalyst were noble metals, platinum-based electrocatalyst. They are also using platinum-based electrocatalyst since now also, but platinum has lower stability and durability. So after platinum-based catalyst, they were moved into transition metal catalyst, transition metal oxides, because of the greater stability they bring. And now rare earth catalyst has exploded due to higher stability and greater catalytic activity. Basically, transition metal oxides, there are a lot of structures, that is peroxide structures, AbO3, or double peroxide A2B2O6, and spinel type oxides, AB2O4. So what is a spinel actually? We will say what is a spinel is. Spinel is AB2O4, example NiFe2O4. These are inverse spinel category. Inverse spinel means suppose A and B, the cations, where A occupy the octahedral side and half of the B occupy tetrahedral and half of the B occupy octahedral sides. This is detection of electrocatalytic activity. This is our setup basically which we are doing. This is the CB setup, potentiostat. This is LSB setup, and there we are using a catalytic ink to drop cast on the glassy carbon electrode. Basically, this one, the RD electrode, and another is RRD electrode. RD electrode, we have disc electrode where we load the catalyst in the loaded catalyst area, counter electrode, 3-electrode system, counter electrode, working electrode, and reference electrode. Counter electrode, we use platinum. Reference electrode, we use AgCl, and working electrode is what we drop cast our material on the glassy carbon electrode. This is RRD, where basic difference between RD and RRD is RD there is disc current, RRD along with disc current it is ring current. Why ring current? Because disc current we cannot measure, as I have already discussed that OR is basically 4-electron pathway or 2-electron pathway. Disc current value will not give H2O2 production, but ring current will give H2O2 production, whether we can confirm it is a 4-electron or 2-electron pathway. This is synthesis of ferrite nanoparticles by co-precipitation method. This is NiDyFe2O4. Dy is substituted in NiFe2O4 at B site. So basically the precursor are nickel dysprosium ferric nitrates, distilled water. We got in a ferrite solution NH3 we have added pH 11 to generally make the precipitate. The stirring for 6 hours. The brown color precipitate forms. Then washing. Then it is dried at 100 degrees centigrade, calcined at 600 degrees centigrade for 5 hours. Then crossed by mortar pistols, and then we got our nanoparticles. That is NiDyFe2O4. This is material characterization. Basically, we prepare the material. We need to characterize whether we have bought our material or not. So material characterization basically XRD, SEM, EDEX, and TEM. This is the XRD pattern of NiDyFe2. As you see, that NFO means NiFe2O4. This is the base material, and NDFO means NiDyFe2O4. Dy percentage 0.25. Gradually is increasing 0.05, 0.75, and 0.1. And the XRD pattern, if you see the 311, all the peaks confirms that the NiFe2O4 and DyFe2O4 has been formed. This is the enlarged view of 311 peak, the highest peak in our material. So the enlarged peak suggests that the shifting in the peak to lower angles suggests that the Dy has been incorporated into NiFe2O4 successfully. The particle size of NDFO 0.025, 0.0575 and 0.1. You see the particle size increases with decrease in the concentration of dy. Now result discussion, we have same images of the material of Ni dy of 0.1, NDFO 0.75, 0.05 and 0.05 at 2 nanometers. The index elemental compositions, if you see here, the oxygen, Fe and Ni and dy, that confirms that our material is Ni, dy and Fe and O. This is elemental distribution mapping, it is uniform mapping. Now the TEM images of Ni, dy, Fe2 for 0.05 samples has been taken, and this is a cubic structure. Now the electrochemical ORR and OER study. This is the application part, electrochemical ORR and OER study. The first graph you see in CB curve, a cyclic voltammetry curve. The cyclic voltammetry curve is a curve in a plot between current and potential. And the first seen the black color, that is nitrogen we have used as a flow to laminate or to make the solutions in it.
Hello, you have 2 minutes left.
And now the color that is given in the other colors, that is the oxygen reduction. So CP we are performing to show that this oxygen reduction is happening or not. If it is happening, we will move to LSB, where we have seen the oxygen reductions taking place. Now this is the OER, the oxygen, first one is the oxygen reduction, and second this OER, oxygen evolution reactions. If you see NDFO 0.05 in both the cases, it is oxygen reduction is also performing better, and oxygen evolution also, it is tremendous results we are getting. Actually ruthenium oxide is best for oxygen evolution reactions. It is 0.57 in AGG cell, but our material is 0.05, which is better than ruthenium oxide in oxygen evolution reactions. So that suggests that Ni dy 0.05 is a bifunctional behavior, because bifunctional behavior is must for a fuel cell to increase its efficiency. This is the KL and RRD plot, where we can calculate the N value, which I have already discussed, that it is a S2O2 production. So by this we can calculate the S2O2 production. It is if it is a full return pathway, the S2O2 production is very less, and it is 2 return pathway, the S2O2 production is very more. So basically we prefer the full return pathway for the water production, not S2O2 production. This is the Tafel slope of Ni dy Fe2O4. The Tafel slope of 0.05 is very less. That suggests that Ni dy 0.05 is better catalytic activity than the remaining ones. This is the impedance plot of the prepared catalyst, and also 0.05 you see the value is very less, the RCT value is very less. So the conductivity of that material is more. This is the chrono and stability test of the material, and it is showing more stability than platinum based catalyst, which we are using as an oxygen reduction reactions and all. Now conclusion is that I have synthesized dy doped NiFe2 material successfully, and we have seen the OR and OER activity. The chronoamperometric Tafel slope also suggests our findings, and the successful completion of B side doped NDFO 0.05 shows a bifunctional catalytic behavior. This is a reference and acknowledgement. I sincerely thanks to BRNS BARC for support. Thank you.
Thank you, Mr. Amulya. Now only one question we can take.
Yes, sir.
You did a very good work.
Yes,
Okay,
sir.
but my question is that why did you choose diaspiration?
Yes, sir. Basically, what we in literature I have already told, that rare earth based system has greater catalytic activity. So now comes to the part of dysprosium. Why dysprosium? Because rare earth contains 4f orbitals and d and f orbitals that will decrease the energy barrier. And also dysprosium, basically what happens is lanthanum and cerium, if you see, they have all the research work have been already done, the literature has been over already. So next element, if you see dysprosium as a flexibility required, they got f orbitals, and d and f orbitals interactions will decrease the energy barrier, and the electron transfer will get more facilitated for OR and OER study.
What is your starting material here?
Sir, NiFe2O4.
No, you are entrapping dysprosium in there.
In
na?
Fe site, I mean B site.
B site. But no, what is the material of dysprosium you are using?
Nitrate, sir, dysprosium nitrate. Yeah.
And what is the cost of it?
Sir,
Have you ever checked on those things?
Yes, sir.
See,
Yeah.
this work is very good. Only I am a bit worried about the cost part.
Yes, sir. Yeah.
Okay,
Actually, cost
so
part, if you are saying dysprosium.
If you talk of dysprosium with regards to ruthenium, lanthanum, cerium, the cost will be very big difference. There will be big difference.
Yeah, almost.
Okay.
In lanthanum, we've got a cerium also, something
And
around.
with whom you are working there?
Sir, Dr. Punendu Padi.
Good work, very good work.
Yes.
Have you published it or?
Sir, working just last part, and I have some characterization left, XPS and all that. And then
Good. Very good. All the best.
Thank you, sir. Thanks.
Hello.
Hello.
Yeah, thank you.
Thank you, sir.
It's a very good talk. The thing is, what I was thinking to ask, Dr. White has asked. So, okay, so you are working in chemistry department.
Yes, sir.
Okay. So, I was also thinking to ask who is your guide, what he has asked. And the thing is, your title is exploration of some multifunctionality after doping DY. Okay. So what are the multifunctionality properties you are seeing in your materials?
Here, sir, we have seen.
But you didn't say in the multifunctionality. Your title is what are the multiple functions?
Yeah, yes, sir. I'm getting into it. Sir, here the multifunctional, bifunctional study we have done. We have seen overall oxygen reduction reactions and oxygen evolution reactions. Multifunctionality mainly depends. There are a lot more. You can also go for hydrogen evolution reactions. Nowadays, we are hydrogen evolution reactions. Hydrogen is a fuel. It is growing in demand. So we have seen here in this work that is OR and OER, oxygen and reduction and evolution reactions.
Okay. Okay, thank you.
That means that is bifunctionality.
Okay. Yeah. Okay then. Yeah, thank you.
Yeah, I have a question. Are you planning to fabricate fuel cell device, or you have already fabricated fuel cell device?
Fuel cells are actually, we are planning to have a fuel cell, basically what we are thinking.
You have not done.
But we have not got actually.
And how you confirm that the material is a single component or a mixture of this nickel iron oxide you are saying?
Sir,
whether it is a mixture of two or more, or it is a single component?
Sir, exactly, if you see all the peaks corresponding to NiFe2O4 and dy, there is only shift in the peaks because dy is incorporated in the B site. So there is no much more any change in the XRT patterns, or and also elemental distributions. If you see, it is coming all things. But more characterizations we need actually, that is XPS and all.
Okay, thank you.
Thank you, sir. Thanks a lot.
We'll move to the next lecture from Rituparna Dev. Her lecture will be on effect of reducing agents on the synthesis of reduced graphene oxide from graphite flakes.
Good morning, one and all present over here. I am Rituparna Dev, a PhD scholar from KIT deemed to be University. The today's topic of my presentation is effect of reducing agent on the synthesis of reduced graphene oxide from graphite flakes. So this is the plan of my today's talk. Before going to the details of the topic, I need to know you about my focus is on reduced graphene oxide. And why we need reduced graphene oxide? Because of its vast application. But as sir said that it is very costly, that graphene itself is very costly. So we are trying to make it very cost effective way using lesser chemical and to enhance more electrical conductivity of it. Moving forward, graphene, as we all know that it is a wonder material, and we all know graphite a century ago, but graphene it comes into front in 2003 by Andrei Jem and Konstantin Novoselov in 2010. They synthesized graphene, a single layer of graphite, by shearing it by a sellotape only. Graphene is a wonder material because it is thinner than a human hair, but it is stronger than diamond itself. And but there is some lacuna of graphene, that we cannot access all the properties of graphene without making it, put some functionalized group in it. Like the derivative of graphene is graphene oxide and reduced graphene oxide. It has the oxygenated functionalized group like carboxyl, epoxy and carbon group. So moving forward, let me introduce you to graphene oxide. Graphene oxide is sp3 and sp2 hybridized. The sp3 hybridization is the oxygen region in graphene oxide, but the sp2 region is the non-oxygenated form. But graphene pure graphene is sp2 hybridized, and graphene oxide is also a single layer thick of the derivative of pure graphene. So the functionalized group like carboxyl, epoxy and hydroxyl group are present in graphene oxide. Graphene oxide has both property like hydrophilicity and hydrophobicity at the same time. Like it can, the hydrophilicity is for the oxygen group and hydrophobicity is for the pure graphite. But there are some drawbacks on graphene oxide. To overcome this, we need to know or we need to introduce reduced graphene oxide by put some defect in it. This is the procedure to make graphene oxide. We have take pure graphite flakes and adding it to the sulfuric acid, making the composite paste, and the composite paste go to the hydrolysis process, and the peptidation solution undergoes the KMNO4 solution, then it reduces to graphene oxide. Simply we include some oxygenated functionalized group in pure graphene to generate graphene oxide. This is the sample powder we make. So reduced graphene oxide. Why we need reduced graphene oxide? Because there are some limitations of graphene oxide, that the surface area of reduced graphene oxide is much more higher than graphene oxide, and the C/O ratio is also less in graphene oxide. So we need to reduce the functionalized group like the oxygen, carboxyl and the hydroxyl group of graphene oxide to get reduced graphene oxide. So there are so many processes to reduce the graphene oxide, but we need a cost effective way and simpler method to prepare it. So going for the slide, we started from the chemical route of synthesis of reduced graphene oxide. Here we use H2O2, the main reducing agent, to reduce graphene oxide to get RGO. Then similarly we use N2H4, that is hydrogen monohydrate, another chemical to reduce graphene oxide, But from these chemicals are very hazardous to health. This is cost effective, but they are not eco-friendly and are also hazardous to humankind. So we need to synthesize it by the green synthesis process. So I am moving to the green synthesis process of RGO, where we use only lemon juice as the reducing agent to reduce graphene oxide. But it is a complicated process because we include oil bath, centrifugation, sonication, all of these are so a bit complicated. So moving forward, we are also synthesized reduced graphene oxide by thermal reduction process. This is the simplest and easiest with no harsh chemical used in the thermal reduction process of reduced graphene oxide. So we can go for the thermal reduction process. There are some characterization done, that is XRD, EDX and FESMs. Moving forward, we see that the XRD graph in all samples so the phase formation is confirmed. And it is about 26.508 in sample 1, which is thermally reduced, and 26.349 in sample 2, and 26.605 in sample 3, and 26.349 in sample 4. Moving forward, this is the FESM data in all 4 samples, which shows the corrugated structure and layer-like structure of reduced graphene oxide. Moving forward, this is the ADEX mapping of the all 4 samples. We can clearly see that the graphene oxide is very much beautifully reduced to reduced graphene oxide, as the oxygen content in thermally reduced graphene oxide is only 7.6, and the oxygen percentage in second sample, which is your lemon juice, is 8.8, and for the third sample, which we use the hydrogen monohydrate, the oxygen content is 8.8, and for the fourth sample, where we use the hydrogen monohydrate, is 10.2. And we all see that the oxygen is removed beautifully. But we can conclude from all of this that the thermal reduction procedure is the best way to reduce graphene oxide, because there is no chemical used, and a very simple process is followed by to make it reduce graphene oxide. So we can see from the outcome that the oxygen percentage is least in the thermal reduction, that is 7.6. So we can go for the thermal reduction process. So there is a vast application of RGO like solar cell, photocatalyst, biosensor, LI batteries, dog delivery, and supercapacitor. Currently I am working on a biosensor for the sensing of dopamine. These are some references. Thank you.
Thank you, Ritupanna. Keeping this lecture in time, only one question we can take. Okay, if there is no more question, we can move to the next lecture. Thank you, Ritupanna. Our next lecture is from M. Sanmukha Rao. The topic is epitaxial growth of titanium oxide nanoflowers by hydrothermal synthesis of LPG sensing application.
A very good morning to everyone. My name is Mr. Shanmukh Rao. I'm a PhD research scholar. I'm from CSR IMMT, Bhubaneswar, and affiliated with ACSR, New Delhi. And today I'm going to give a presentation on epitaxial growth of TiO2 nanoflowers by hydrothermal synthesis for LPG sensing application. And this is my outline: LPG usages and preventions from the accidents, TiO2 nanoflower synthesis by hydrothermal method, and characterization, material characterization, LPG sensing application. We all know that LPG used in every sector: industrial, agriculture, refinery, and other industries, and it is mainly used as a cooking gas, and most of the households use it as a cooking gas. And here you can see that consumption of LPG is increasing every year. From 2013 to 2022, 28 million metric tons LPG consumption is used. And but at the same time, it is causing several accidents. From the last 6 years, more than 5,000 people died due to this LPG accidents. So why? Because this is a hydrocarbon compounds, and it is highly reactive, and those propane and butane is causing the highly reactive, and propane butane is flammable gases, so it is causing the accidents. So how to prevent these accidents? By synthesize the sensing material it should be low cost, and at the same time it should exhibit good properties. So these are all the sensing materials: zinc oxide, tin oxide, and indium oxide, titanium dioxide, and different hazardous gases are present there: H2, NO2, NH3, ethanol. But to detect the LPG is difficult because this is a mixture of hydrocarbon compounds, and these are the several deposition techniques, thin film deposition techniques, and sputtering techniques, and sol gel, hydrothermal synthesis, chemical box deposition. And here I presented the TaO2 other semiconductor materials to detect that different hazardous gases. Why? Because TaO2 is a chemically stable material, and it is exhibiting good catalytic properties, and superior electron transport rate is high, and strong oxidizing abilities, and this is the 9th most abundant material in the earth crust. And I choose hydrothermal synthesis because this is a low cost method as compared to the sputtering, PVD, other techniques. So here my objective is to synthesize the hydrothermally synthesized TaO2 films for LPG sensing, and it should give good sensing response and short recovery time. This is the synthesis method. Here I have chosen the titanium butoxide precursor and hydrochloric acid and DI 1:1 ratio. And here I have done that I synthesized the thin film by varying the different substrate position. Immerser position, it is a 0 degrees 0 degrees over the surface, and slanting is 45 degrees, and vertical position is 90 degrees. I have prepared that for the hanging position, stand top down method. Here you can see that these are the effect of substrate position. You can see in the immerser position there is a spherical nanoflowers you can observe, and slanting position uneven nanorod growth is there, and some island formation is there. In vertical position, what happened? Agglomerated particles you can see, and hanging position hierarchical nanorod formation you can observe. So here I optimize the growth conditions. And effect of temperature also important parameter in hydrothermal method. There are namely two reasons. One is subcritical region and supercritical region. Here we are giving the temperature above the boiling point. So in subcritical region, our material is formed at 150 degrees centigrade, which is below the 22 megapascal range. So when I increase the temperature, you can see that substrate was completely etched out. And 100 degrees you can see the island formation only. So our optimizing temperature condition is 150 degrees, and after that, because it is, you can see that it is not uniform growth, and after that I thought that maybe its nucleation not occur properly. So one new condition was aging reaction time. I increased the aging reaction time. Here you can see that from 12 hours aging to 24 hours, 48 hours aging, there is a uniform film growth you can observe. This is the cross-sectional image of TaO2 nanoflower. Here you can see that aging growth time from 0 hours to 48 hours. Here what happened? When there is a small lattice mismatch between the silicon substrate and deposited film. So this is causing the epitaxial growth of the TaO2 film. The diameter of the film is increasing when we are increasing the decreasing, we are increasing the aging growth condition, and this is the lengthwise nanoflower growth you can observe. And these are the material characterization. And from the XRD, it was observed the TaO2 rotile formation you can observe. And from the Raman, there is a in-plane modes A1, B1G, and there is a E1G outplane mode at 443 cm inverse you can observe. And from the Raman and XRD, it was confirmed that TaO2 formation is there, and TaO bonds are present there. From the FTIR, there is a TI low frequency vibration bonds we can observe. And after that, I have done the LPG sensing. This is a schematic diagram of a gas sensing instrument. What is the LPG? What is the sensing mechanism? When the sensing material is reacted with that targeted gas, there is a change in the resistance. Here you can see that mechanism. When it is reacted with the air, the oxygen molecules interact with the valency band of sensing material, valency band electrons of sensing materials, and it will form the ions. And then when and it will form ions, and it will create the depletion layer, and the depletion layer is increasing. There you can see that barrier height, and when the target gas is interacting with the sensing material, you can change the barrier height. Barrier height is reducing. Here I have done that LPG sensitivity measurements by using that resistance versus temperature at 100 ppm, 500 ppm and 1000 ppm. I got aging 24 samples gives the good sensing response, 2.7%. And here you can see that resistance versus time measurements of each 100 ppm and 500 ppm, 1000 ppm. Each ppm I got that good response time and short response time and short recovery time at 10 seconds and 80 seconds, and 500 ppm 11 seconds and 134 seconds, and 1000 ppm 12 seconds, 142 seconds. I got good sensing response. Any gas sensing material, it should exhibit high sensitivity response as well as fast response and short recovery time, and it is giving good reproducibility. So because this TaO2 nanoflowers having high active lattice sites, then only adsorption and desorption will occur. When you are injecting the target gas, there should be high active lattice sites, then the adsorption rate will be increased. So I can say that this TaO2 nanoflowers is a good sensing material. And this is the summary. I optimized the TaO2 nanoflowers by varying the different substrate orientation and aging time and temperature, growth time, and I have done the characterization to confirm that TaO2 phases are present there, Rourkela and nanotech, and aging growth is increasing. Is the surface morphology of TaO2 nanoflower. This is a new condition I have done, optimized, and this gives 2.7% response and recovery time. And I would like to acknowledge that CSR, IMMT, ACSR, UGC, and CIPET. Thanks for giving this opportunity to me.
Thank you, Mr. Rao. Only one question we can take. Okay, if there is no more question, we will.
Yes, sir.
Sir.
Moga, it's a very good word.
Thank you, sir.
Only thing is that you are telling it's nanoflower. I see it like nano rods. Okay. So, but it's in the form of flower when you are taking higher concentration.
Yes, sir. Spherically it's formed. I mean nanoflower.
But that's in higher where you are doing.
Yes, yes.
At lower concentration, what is the?
Yes,
because
sir. I changed the concentration.
Because the first picture what you that's looked like a nano rods.
Yes, sir.
Okay. And my second question is that, what is the time difference? Have you ever found out how much time it takes for the cylinder to explode, and what is how the process takes place?
Yes, sir. Actually, I have done that 12 hours time, reaction time, and after that I increase that aging time, the solution.
I'm not talking about the material preparation.
Okay, okay.
I'm talking about the explosion, gas cylinder explosion.
10 seconds, sir. Very short, very fast response. Yes, sir.
Okay.
As compared to the literature, I have seen that 13 seconds, 15 seconds.
And how much time your material is taking to sense it?
Within 10 seconds, like that.
And do you think within that time gap, somebody can find out a way to solve the problem?
Yes, sir. It will send. I mean, alarm will come, and I have to do that.
So you need to do some further study.
Yes, yes, further study.
Okay, good.
Yeah,
thank you. All the best. Huh?
Yeah, thank you so much, sir.
And why did you acknowledge UGC?
Yes, sir. UGC is giving fellowship. Yes.
Okay, good. Okay.
Thanks.
Okay, thank you all for the presence and keeping this session interactive. I declare this session come to an. Thank you.
Thank you, Dr. Palai, for your kind words, and also thank you so much for guiding us for this conference and for successfully running this session. So now I would like to invite Dr. Pijus Kanti Mandal sir to felicitate our session chair, Dr. Akshay Kumar Palai. So please, sir, please. It's a token of respect, just from our side, small token of respect from our side, sir, please. So within 10 minutes, we are going to switch our next session. That session will be led by Professor Sushant Banerjee sir. Just for 10 minutes tea, then we will start our session. Please come just after the 10 minutes. And volunteers, please guide. First floor. Soon after the tea, after 10 minutes, we will start our next keynote speaker which with us. So please volunteer. Within 10 minutes, we are going to start. If you have already done, then please be seated.
Yeah. Yeah, good afternoon to all. Uh, Good afternoon to all. Sorry, we are late. We are running late with the time, and our esteemed chairperson and also the esteemed eminent scientist from IIT is also here for his talk. So now I will request our Dr. Manas Kumar Dalai to chair the session. He is a principal scientist at IMT-Bhubaneswar. Dr. Manas Kumar Dalai is a principal scientist at CSIR, IMT. He is also a faculty of Academy of Scientists, Scientific and Innovative Research. India, Dr. Dalai obtained his MSc Physics degree from Department of Physics, Utkal University, Manibihar, Bhubaneswar in 2002. He obtained his PhD in 2009 in the field of exponential condensed matter physics from Institute of Physics, Bhubaneswar. He was a postdoctoral scientist at University of Augsburg, Germany in 2009. From 2009 to 2017, he was a scientist at CSIR National Physics Laboratory, New Delhi, where he was working in the field of surface and interface study of materials. He has recognized for many of the awards and scientific research contribution to the research society, and he has received several awards which include CSIR Raman Research Fellowship in 2022-23, Outstanding Performance Award 2018 for the dissemination of meteorological traceability through Bharatiya Nirdeshak Dravya BND for 2002 by CSIR National Physics Laboratory, New Delhi, Indo-US Research Fellowship Award in 2013 by Indo-US Sciences and Technology Forum, New Delhi. So I welcome you, sir. It's our great pleasure that you are here to session the chair. Now it is hand over to the session chair, Dr. Manas Kumar Dalai, sir, to take over the session. Thank you, sir.
Thank you so much, sir. Very good afternoon to all of you. It's really a great pleasure for me to be here in this national conference, and I would like to thank the organizer of CIPET for inviting me, and I particularly for giving me this opportunity to chair the session. Now we have a very good session, a wonderful session, and this is the keynote lecture session, and we have with us Professor Sushant Banerjee from Indian Institute of Technology, Kharagpur. So let me introduce our eminent speaker, Professor Banerjee. Professor Banerjee currently working as a professor, Institute Chair Professor at Central Research Facility, MSD, and Professor of Polymer Materials, former Head Material Science Center, IIT Kharagpur. And Professor Banerjee received his master degree in science, master degree in technology, and PhD degree from Indian Institute of Technology, Kharagpur in 1988, 1989, and 1993, respectively. He started his research career with the DRDO, Government of India, and worked there as a scientist from 1992 to 2004. Dr. Banerjee was an Alexander von Humboldt Research Fellow at the Technical University of Munich from 1997 to 1999. In 2004, he joined GE India Technology Center, JFWTC Bangalore, as a lead scientist and worked there till the end of 2005. He moved to IIT Kharagpur in 2006 and currently he is a full professor in the Material Science Center. His research interests include designing new polymers and membranes that offer low-K applications, gas and liquid separation, polyelectrolytes for fuel cells, and polymers for photovoltaic applications. His research work has resolved many of the critical issues in the membrane-based separation, and he has successfully demonstrated new polymers that showed his permeability and selectivity. His work has given a new direction in developing new portion conductive membranes for fuel cell applications. So he has published more than 200 publications in international journals, ACI journals, and made more than 150 presentations at different scientific conferences, either it's national or international conference. So he has delivered several invited talks in those meetings. And actually he has a long list of CV, and he has many more things, but I just want to read some of the important things, then I'll invite Professor Banerjee. So he is the recipient of Material Research Society of India MRSI medal, and fellow of the West Bengal Academy of Science and Technology. He has also been awarded as the Institute Chair Professor by the IIT Kharagpur in the year 2020 for the 4th consecutive year, 2020, 21, 22 and 23. His name appeared in the list of world's top 2% most cited polymer scientists released by Stanford University, and we know all are acquainted with these 2% scientists nowadays, actually Stanford University, and really we are privileged to have Professor Banerjee with us in this important conference. So he has supervised 26 PhD scholars and 40 master students. He handles several external funded research and consultancy projects and collaborates with several research groups in Germany, USA, Russia, etc. So with this short CV, may I request Professor Banerjee to come to the dais and deliver. Thank you, sir.
So many thanks to Chairman for really not short but very elaborative CV. So anyway, thanks to the organizer for inviting me. So I visited this CIPET for earlier also in few occasions, and really it's my pleasure to be here again. So let me go through my talk. I'll be giving 45 minutes as I know, and I'll try to finish within that time frame. So first of all, let me tell you what is high performance polymers, because the talk is concentrated on high performance polymers. So mostly high performance polymers are those having very high glass transition temperature and very high set of mechanical properties. They are inflammable material. So a few of them are shown over here, like say, I don't know, this is also not working. So like you can say the first structure is matrimide, and then next structure is Kapton, and then there is the polyaramide developed known as Kevlar by DuPont. And some of the polymers again polyethylene ethers. But the major problem of these class of polymers are their processability. They are they cannot be processed by conventional melt processing techniques, and most of these classes of polymers are insoluble. So how to process them? So that's an issue. Sometimes this type of, particularly the Kapton type of polymers are processed from their precursor, and they are used mostly in the film for interlayer dielectrics and many of the separation applications. Polyaramide, you know, that is a very high strength fiber used for many applications. They have also very processed from solution route, but using very exotic solvents like sulfuric acids. So typically our goal is to use this, to make this kind of polymers, at the same time to make them processable by some of the techniques, mostly by solution processable, and to utilize them in the form of film for different applications. So typically let us see that total research what I will be talking to you is concentrated within this molecule and this is typically is known as 5-bromo-2-fluorobenzotrifluoride. And to utilize this molecule, you can generate different kind of monomers, because the talk is to creation of different kind of monomers, and which could be later utilized for different kind of your polymers through condensation polymerization chemistry. So mostly I'll be talking to three classes of polymers, little bit on polyethylene ethers, polyethylamides, polyethylamides, and typical application of this class of polymers in their membrane-based application towards the separation of gases, mixture of gases and solvents, and also to utilize them in your fuel cell for proton exchange membranes. So as the issue is solubility, as I told you, referred to my second slide, that how to increase the solubility, and we found that an approach that if you incorporate fluorine, means if you create some kind of semi-fluorinated material in terms of perfluorinated, like Teflon is insoluble material, but if you selectively put fluorine in the aromatic rings, and if you can create a semi-fluorinated polymers, they gives you better solubility. They also gives you relatively high thermal stability, high glass transition temperature. They reduce the dielectric constants, so which is basically for low K application in interlayered dielectrics, and they also reduce your water absorption, less color, and high optical transparency. At the same time, they create more amount of fractional free volume because of their dimension, and that allows high gas permeability. So typically the talk is related to theme is the membrane. So the first point is that synthesis, design and synthesis of new monomers by proper molecular engineering, first task. Second task is the synthesis and characterization of different types of condensation polymers. As I told, polyethylene ethers, polyamides, polyimides. And third is to investigation of their properties and establish some structure property relationship. So in fact, this slide gives you the whole gamut of research what we are doing, and that is based on single molecule, as I was telling at the beginning. That is typically, this is not pointing. Anyway, one can see that red color compound or the molecule is 5-bromo-trifluorobenzotrifluoride, and that could be lead to a boronic acid by conversion of Grignard agent, and then followed by reaction with trimethoxyborate followed by hydrolysis. And then it gives you a boronic acid, and then once it forms the boronic acid, then it can actually coupled with different kind of dibromo compounds in presence of palladium catalyst, that is conventionally known as Suzuki coupling reaction, and then one can lead to different kind of bis-fluoro compounds. So from the blue compound, one can go to different kind of bis-fluoro by coupling with different dibromo, like 1,4-dibromobenzene, dibromo-diphenyl kind of compound, dibromopyridine, dibromothiophenone, any kind of compound you can take, you can couple, and the conventional yield you can go even up to 95%, even after passing through your alumina bed. So one can go, once you have a difluoro compounds are ready, then you can go for a kind of chemistry which is actually nucleophilic displacement reactions. By reacting with different kind of diphenols, one can make different kind of polyethers. So you can have a host of polyethylene ethers or polyethers from this your difluoro compound, and selectively these CF3 groups in the ortho position help in actually electron withdrawing group that helps in actually removal of fluorine and creates that carbon is more carbocation in center, and it's basically helps in nucleophilic displacement reaction once it reacts with some phenoxides. Next step one can go for, if you wanted to again wanted to design little bit more, then you can react with 4-aminophenol, and then you can make different diamines. Once the diamines are ready, you can make different kind of polyimide or polyamide by utilizing condensation chemistry. Another step one can go, amine could be easily converted to the azides. So once you make them agile, then you can make different kind of polytriazoles. And so that area is open, is one way. Again, if you wanted to manipulate the structures, like rigidity of the backbone of the polymer, to control the glass transition temperature, flexibility of the polymer, then you can come to another kind of chemistry, and you can come a different kind of, again, amines with some rigid and flexible units. Other way also, one can go to make a trifluoro compound like a B3 kind or A3 kind of monomers, and that can lead to host of hyperbranch polymers once they are reacted by different kind of bisphenols by A2B3 polymerization mode. The same blue compound could be converted to some kind of your monomers, and what we did, and then finally we can make some kind of derivatives like PPV derivatives, polyparaphenyl phenylidene derivatives. We know that MEH PPV as a light emitting materials used in OLED and or PLED, or used in even solar photovoltaics. So that kind of manipulation is possible, and through this structural manipulation one can also actually manipulate the band gap to get different kind of color from this kind of compounds. So this is in nutshell what we are doing or working for last couple of years, maybe I can say almost for the 20 years, and I'll be showing that what we are doing now. So as I discussed from that slide, one can easily convert that boronic acid to different kind of bisfluoro compound by Suzuki coupling reaction, and whatever the dibromo compounds, you can couple it in presence of toluene and water mixture, in presence of base as a K2CO3 and palladium 0 as a catalyst. So we made many, and few of them are shown over here. And once the bisfluoro compound is ready, as I was telling, you can make a nucleophilic displacement reaction with different kind of diphenols. So you can make many polymers. And typically all these polymers, the aim is to put selectively fluorine, and this fluorine helps you solubilization of these polymers, and you can make membranes through solution casting method, and which we are doing. We try to understand few of the chemistry over here, that how these different kind of groups, like say if you have put biphenyl, you have put phenyl, you have put pyridine, and you have put thiophene through that first stage of coupling reaction during Suzuki coupling, and these monomers once again reacted with the bisphenol A, all this AR, and then you can have suppose for these polymers, and you can see what we are doing. We are in fact increasing the rigidity, and that rigidity is manifested with the enhancement of the glass transition temperature. So once it is a biphenyl layer, then you get 220, and one it is a phenyl, means your terphenyl or quadriphenyl to terphenyl kind of structures, you can come to a glass transition temperature 174. Once it is pyridine, then 119, and thiophene is 120. So typically here, glass transition temperature depends on few parameters. One is actually the rigidity, other is the catenation angle. So if we think about your phenyl to diphenyl, rigidity is actually playing the role which actually push the glass transition temperature from 174 to 222, where the other counterpart is same. Now, in case of pyridine, the glass transition temperature is 119 is expected because it has less extended geometry. So typically, the 180 is the most extended geometry. Beyond that, one cannot go. But if you have a less extended geometry, this is 119. And now the question is that why in thiophene case, it is more extended geometry comparison to 25 pyridine, 26 pyridine, but still it is 120. So along, we try to understand this problem, but this happened again and again. It's not a one-time phenomena. Whatever polymer we design with pyridine and thiophene, the same thing happened, and then we got an answer. In fact, the geometry and along with the polarity. So pyridine is almost 6 times more polar than the thiophene unit, and that in fact effectively pushes almost make their TG, despite your thiophene containing polymers, the catenation angle is more in comparison to the pyridine containing polymer. Another understanding we got that if you have that more rigid structure, but despite that, the polymer with more rigid unit gives you higher elongation at break in comparison to the terphenyl kind of structures. So this possibly somehow that phenol is playing in a different kind of role. And anyway, this TG versus always we got similar kind of many studies have been conducted. But this is another one of the plot is showing to you in comparison to quadri versus star. If you see, means air is your more and more, you can see that in 5C, some of the polymer, despite very rigidity, even you have elongation at break at 120. These are basically casted film. These are not at part the STM, but despite that, in a series of polymer or film, you can compare their properties, and which happens again and again. So then we go for design that how you can make polyimide or polyamide. So let us, so we make different kind of diamines from that bisfluoromonomers. And these bisfluoromonomers, the diamines, different diamines, those are reacted with different kind of dianidates. And if you react dianidates, you can make a host of polymers like polyimide chemistry is open up. So we made lots of polyimides utilizing this chemistry, and then we studied their properties. Again, some of the investigation, I am not showing the detail here, but some of the investigation you find that if you go from quadri, similar kind of repeat unit structure, where there is a continuously 4 benzene rings and 4 we are terming as quadri, 3 as tar, and the glass transition temperature has gone in case of quadri around 300 degrees centigrade, whereas in this case around 280. So this has been manifested again and again, the structure. So manipulation of the structure, and you can, through the manipulation of the structure, you can manipulate the properties. Next approach, what we do, another design aspect, that put some kind of rigid and flexible linkage together. So again, similar kind of chemistry, but little different. So what we do in this case, we make this kind of nitro compound, and which actually reacted again with an equilibrium displacement, you can different kind of nitro and reduce it to different kind of diamine. So in that happening, what is happening, you have a kind of more rigid structure along with the flexible pressure in the polymer, finally once you are making there in the polymer chain. So we made that way also lots of polymers, and again in this case you can find out that TG depends onto the bulkiness, the type of actually bisfluoro in that spacer scoop what we have used. So it can go up to 309 to 264, and similarly when it is, if we compare a similar polymer, 264 comes around 230 degrees centigrade. So these things have been, again, same way you can prove it. So different classes of polymers, if you have a PMDA, more rigid unit, then BPADA, 311 to 282, where the counterpart is same. So that way it can be actually manipulate the TG, and you can make a polymer of your choice of different glass transition temperature, different your say mechanical stability that way. Nevertheless, one of the aim of these polymers was to make them soluble, so that you can cast their membrane, because as I told you that Kapton or Kevlar, very high class of polymers, but you cannot, difficulties in their processability. So the polymers were processable, and it was possible also, because the polymers were processable, it was possible to record their NMR spectrum, and even in CDCl3. So this is your NMR spectrum of this polymer in CDCl3 solvent, and it was possible to detect or identify all the magnetically different protons, and it was also possible to integrate, and that matches with the proposed structures. So its polymers were soluble, and it was possible to characterize even in the form of the imide form. So anyway, these polymers were, some of them polymers were utilized for low K applications, and you can see that your dielectric constant that your depends on to the repeat unit structure, and if you go from TARC to the quadri, 2.72 to 2.78, or even if we go more and more fluorine, then 2.35. Again, the same polymer, one of the polymer we actually electrospin through electrospinning apparatus, and once the mat was formed, even one can go to dielectric constant of 1.43. So typically you can have the approaches to even further reduce the dielectric constant, one by designing the polymer, other by your using a different processing techniques. One can also work for hyperbenched polymers, because hyperbenched polymers are highly branched structures, and branched structures means there is more of free volume. There is the unoccupied volume. I am not talking about the porosity. And if you have more and more unoccupied volume, you can reduce the dielectric constant more and more. So typically this kind of polymers were prepared, and which shows dielectric constant around your 1.78. And these polymers are not very, very strong polymer, but even you can coat on a substrate very easily, because your low K applications in microelectronic application, you are only interested to coating on a substrate surface. And in fact, you can see amazingly high molecular weight, and which was a RS signal maybe extremely high, I should say, and really 44 lakhs actually gram per mole with a PDI of 2 polydispersity index of 2.2. It is just actually before gelation, you can say. So I talked to you, I will not discuss this thing, time is problem. Now let us come to membrane-based separation. So what are the membrane-based separations? So there are many kinds of membrane-based separations, which could be classified like microfiltration, ultrafiltration. So microfiltration and ultrafiltration are basically based on size exclusive principle, that is actually sievings. So small will be come out, bigger will be excluded. Now one can go, so those are mostly driving force at your atmospheric pressure or very low pressure, and they have a different molecular cut depending on the pore size what you have created, or the host molecules, guest molecule you have added during the membrane fabrication stage. You can add some kind of guest molecule during the membrane fabrication stage, and then selectively wash the guest molecule. Then you can create your porosity. That porosity depends on the guest molecule, you can create the molecular cut. So that is microfiltration, ultrafiltration, then nanofiltration is mixed, and then slowly we come to the dense membrane. So our goal is to make your dense membranes, which are basically based on solution diffusion principles. You know that gas molecules like oxygen, nitrogen, size-based exclusion is not possible. And if you wanted to exclude size-based exclusion of nitrogen and oxygen, you cannot reach selectivity more than 1.3. That is the theoretical selectivity. So how you can do it, higher selectivity? Then you cannot do through the porous membrane, but you can go to the dense membrane, which are solution diffusion based process. And two processes I will be discussing. One is gas separation, one is pervaporation little bit. That is your separation of close boiling solvents, which forms azeotrope with a particular concentration, and then conventional distillation is not possible to separate them. You need to break the azeotrope. So that kind of processes, typically membranes are very, very useful. So in this process, what happens? Solution-based diffusion, first the gas molecule or the sorbent molecules adsorb onto the polymer membrane, and then slowly it moves through the white spaces. I am indicating the free volumes, which are generated once you are taking once a membrane forms, and then due to the close packing of the polymer chain, because polymer chains have different type of architectures or spatial arrangements, once they form in a space, they forms a different kind of free volume is generated. These are not poems, those are intrinsically voids which are generated by the packing of the polymer chains, you can say in a cube. So next phase is after it adsorbs, then it moves from one free volume to the another free volume, like this is the diffusion control phenomena. First adsorption is the solubility control phenomena, then diffusion from free volume to the another free volume is the diffusion control phenomena, and then finally it's come to the downstream, which is say the permeability. So overall permeability depends on the diffusion coefficient of the gas molecules into the polymer matrix and the solubility coefficient of the gas molecule to the polymer. So P is actually factors of 2D into S. So typically, most of the polymers so far have been designed, and say this is a kind of plot is been given, commonly known as selectivity, your permeability plot, and this plot was actually given by Robson, so it is in his name. So one direction it is giving the permeability of one kind of gas, and other direction it is showing the selectivity of two different kind of gases. And if you increase the selectivity, if you find what is reducing, slowly these red points are the data points for different kind of polymers. So different kind of polymers, what you find that if you kind to your x-axis in the right hand direction, then what you are finding that permeability is increasing. But what it is reducing, y-axis, that oxygen, nitrogen, selectivity is reducing. This is known as conventional trade-off relation. So if you increase the permeability of one gas through a membrane, then selectivity reduces. And in industry, in fact, what you need high permeability and high selectivity, or at least very high permeability, then low selectivity is also acceptable. So that has been put some kind of line, these are known as boundary line. So this is the latest boundary line. If some polymer have a data point close to this line or above to this line, then that is industrially acceptable for a separation process. So that way you can, so the goal of this actually research is to design a polymer, how you can actually address selectivity, permeability, trade-off relationship. So the polymer I have talked to you, synthesis, now you can make the same polymers, you can make the membrane. So this is we are making by your solution cast membranes, by simple, so some of the polymer have been shown, dissolving in a suitable solvent, cast the membrane, remove the solvent in a solvent atmosphere, inside the oven, and get the membrane and use them for different applications. These are some of the plots I am showing you, that is showing you that with a real plot, that time versus output pressures. This is an instrument you can use, you can take the membrane and you can pressurize the upstream, and gas goes to the downstream as I explained, and then you can measure the downstream pressure. And downstream pressure increases with time. Initially there is an inertia in all the plots you can see, and then it goes to a steady state flow, and then it becomes the linear. So typically this is the output pressure versus the time. If we take it, this same membrane, carbon dioxide and methane, then it shows the carbon dioxide blue plot, blue line having more slope. Slope means it has more permeable to the carbon dioxide. Because if you see the equation permeability, that the parameters V, volume, D, thickness, T0, all are constant. What is varying, that is the dP by dt. So all are machine constant or fixed parameter with respect to a particular thickness membrane or film. So dP by dt is changing as you basically, so that means you can say the X membrane is more your permeable of carbon dioxide comparison to methane. And from here, measuring the individual gas permeability, one can calculate the ideal selectivity. So carbon dioxide permeability by methane permeability, that known as selectivity. Similarly, oxygen and nitrogen. So these are again some of the plots from some of the membranes we are designing. Even we are actually putting different kind of groups to how to address, as I told you, that conventional your selectivity and permeability trade-off issues. So initially we designed this type of polyethylene ether membranes. And you can see that once we go to a kind of bulky structure, the left hand part of the polymer, if I split the polymer in two forms, then we can get that left hand part is the same, but in the right hand part, slowly what we are doing, we are increasing the your bulkiness of the unit by from methyl to hexafluoromethyl, trifluoromethyl, and then to fluorine kind of unit. And that also manifested by their glass transition temperature. Nevertheless, but what we found, that most important thing is that once we increase that more and more bulky unit into the polymers, then we are getting more and more gas permeability. So PCO2 is 41 barar, the same type of units. Then what we do, we plan that let us again design different kind of polymers with different left side you can vary, like pyridine, thiophene, put the same bulky unit. So this is the same bulky unit with the thiophene fluorine unit. Now we put a kind of terphenyl, pyridine and thiophene containing unit. What we got in case of pyridine kind of unit, you have a higher gas permeability, and not only higher gas permeability, the selectivity is also higher, because oxygen to nitrogen selectivity corresponds to 5 and carbon dioxide to methane selectivity 20. So we found that really that pyridine element is actually helping to give you higher and higher gas selectivity comparison to other type of units. The same thing, once again we designed some other kind of polyethylene ethers with some kind of, again to generate more amount of free volume that helps in actually enhancement in the gas permeability, and selectivity trend is also similar once you have your nitrogen element into the polymer structures. These are again a similar kind of trend we got with a different kind of structures, and again we found a kind of spirobiindent kind of thing, that intrinsically porous structure, if you can put some kind of element, then you can have really very, very high your gas permeability and very good selectivity. We try to understand little bit that what is the role of free volume. So we did little bit molecular dynamics simulations here. So with one of my colleagues, he is in Tennessee Tech University. So we simulate some of the structures by taking polymer repeat unit your n equal to 10, and then we calculate. So some of the things, only one or two I will be discussing, PCP1 versus PCP2. If you see both these polymer structures, then one containing some kind of terbutyl unit, and which is giving your higher free volume. Experimental is which basically taking the density of the polymer, and by putting some experimental formula which is 0.143, and simulation is 1.4. So what they are not same, but the trend is same. But what you can see that PCP1 has higher free volume, and which is manifested by higher gas permeability. Say carbon dioxide permeability is 53, whereas PCO2 is 12 in case of PCP2. So question is that if you can generate more free volume, then typically you can enhance the gas permeability, and which was possible that in case of tertiary butyl group, if you put tertiary butyl group, all the polymer structures, then always the same kind of phenomena is observed. I will be not going to this. And definitely we design many kind of polymers, then also we put into the conventional trade-off relationship plot, and we found that some of our polymers are actually surpassing or closer to the upper bound of the trade-off line. Same thing in case of carbon dioxide methane selectivity. Pervaporation, I will be just again taking 2 minutes here. So you know that, as I told you, that it is a liquid separation. The problem is some cases like say benzene and cyclohexane, they have the boiling point difference is hardly of your 0.6 degree centigrade. And they form, that is not even that, they form a azeotrope with a benzene and cyclohexane. When benzene is 55, cyclohexane is 45, and their boiling point is 77.5 degrees centigrade. So at this particular concentration, it is not possible to separate benzene from cyclohexane. So how to do it? And another thing, why you don't want to do it? Cyclohexane is not available from naphtha or the crude oil. So you cannot get cyclohexane, you can get benzene. And benzene you can basically hydrogenate to cyclohexane, and cyclohexane is a very important compound for actually nylon 6,6 or many kind of polymers. So typically benzene too you can get the cyclohexane, as I told you, and cyclohexane is used for say adipic acid, which is used for nylon 6,6, and caprolactam, which is for nylon 6. If cyclohexane was not there, then you should not have benzene nylon 6,6 or nylon 6, because it is not coming from the crude oil or the naphtha during the your distillation kind of process. So typically what happened, we designed different kind of polyamides in this kind of cases, because polyamide has different higher amount of adsorption to the benzene, and we make similar kind of chemistry, and here we, instead of dianhydride, we react with different kind of diacids with all the same diamines. So many kind of polymers could be prepared, and they have been characterized, And then finally, we do some amount of pervaporation study. We took benzene cyclohexane mixture in the upstream and then try to pass through the membrane, and which are collected in different kind of your collectors which are cryogenically cooled. So typically we had taken cyclohexane to benzene 50-50, and you can see the gas chromatographic plot is clearly indicating cyclohexane and benzene 50-50 ratio, and which actually once actually after the pervaporation operation, and which gives you benzene is more, cyclohexane is less. So what is indicating that polymers are more of actually selective towards benzene comparison to cyclohexane. So many such polymers have been designed, and their properties have been calculated, and understanding we got it, and some of the polymer membranes are very useful for benzene cyclohexane separation. Again, this is again a kind of trade-off plot. You can put the normalized flux, means how much quantity of benzene or cyclohexane mixture is passing through the membrane, difference by the separation factor, what you can calculate from the gas chromatographic plot, and you can see that this is the trade-off line is given, and some of the polymers, in our case, we are close to the trade-off line. Next, I will be taking some minutes to proton exchange membranes. So this is again another part. And proton exchange membranes are basically are the polymers which transport proton from one side to the another side, and which is used in fuel cell. And just some of speaker already discussed some of the fuel cell, how it operates. I will be not going detail. So typically in these polymers there are two components. One is hydrophilic component and another is hydrophobic component. And mostly they are made by copolymerization or by the post-polymerization, post-modification of the polymer by using suitable agents. So hydrophobic components typically gives the strength to the polymer backbone, and hydrophilic backbone helps to basically transport the proton by taking the moisture from the environment, and it forms a kind of species sulfonium ion if it is a sulfonic acid base, and if it is and then forms the hydronium ion. So this is the working principle, very simple principle. It's a kind of anode and cathode, and in the anodic reaction, if you take hydrogen as fuel, then that is known as hydrogen fuel cell. If you take methanol, that is known as direct methanol fuel cell. So once hydrogen in anode actually decomposes to its basic elements like hydrogen ion and electron, then this membrane has a property not to allow to pass the electron, but allow to pass the hydrogen. And then what happens? Hydrogen passes and goes to the cathodic side, where it reacts with oxygen and it forms water. As the electron cannot pass through the membrane, they are allowed to pass through an external circuit, and that's basically generate the electricity once the full cell reaction is completed. So this kind of membrane is basically one of the important membrane in this field is naphion, which is known as state-of-art material. So it is a polytetrafluoroethylene backbone and having some kind of pendant sulfonic acid groups. It's a monopoly or the material developed by DuPont. It's a very expensive product, and also but it is the state-of-art material. Even now it is used in many of the your fuel cell cars, it's used. But this material has a problem at high temperature. What happened above 80 degree, it's basically your conductivity reduces because it forms a kind of cluster kind of structures, and the water channels actually breaks. So people are interested to make different kind of, because that's a monopoly and single material, so everybody is interested to jump in this field. So one of the approaches is to take most of the commercial polymers like polyether, ether ketone or any imide, and you do sulfonation. So if you do sulfonations, then you can have that your sulfonic acid containing polymers, and which can be used as a proton exchange membrane. But disadvantage is your direct sulfonation is that polymer molecular weight degrades and you don't have proper control. Another approach is to make a copolymerization. So you can make a sulfonic acid containing monomer and then copolymerize with doing some kind of condensation chemistry. So in this case, the main important part, if you increase the ion exchange capacity or degree of sulfonation, then proton conductivity increases. And proton conductivity increases, the membrane stability decreases. Here is also a trade-off issue. So how to address actually this trade-off issue? that have high proton conductivity, high membrane stability. So many such kind of your article have been come. Here again we found that if you put partially fluorine into the polymer unit, or you put some kind of bulky structure, that basically help in taking the water more without membrane soiling is affected less or less affected. So typically initially what we do as a copolymerization approach, we took some commercial sulfonic acid containing monomers, that is the sodium salt, and take our monomers what we design. So we have some fluorine and then make a copolymer. So we make many such kind of copolymers by doing this kind of chemistry, simple chemistry, condensation chemistry. But question is that this condensation reaction is possible at around 180 degrees centigrade, and sometimes what happens at high temperature desulfonation takes place. But we made many such kind of polymers by changing the repeat unit structure, by increasing the conductivity, by putting some kind of pendant sulfonic acid group, by putting some kind of carboxylic acid, and through some kind of nanocomposite approach. But all those things little bit at disadvantage is that in this case once we go degree of sulfonation, means in this case if your N is your more than 70, that I am telling you degree of sulfonation. 2 means you're 20. So if you go more and more, then what happened? Membrane stability affected. So we go to polyimide, because you know that polyimide is a good membrane, stability wise it is good membrane. And once we do the polyimide chemistry, we took different kind of monomers, and in here we choose selectively 2 different kind of monomers we design. One containing your O-methoxy group and another containing your OH. Because you know that phenolic groups are basically your radical, it's basically scavengers. And in this kind of fuel cell reactions, sometimes hydrogen react with oxygen and it forms hydroperoxide radical. And that hydroperoxide radical, yes, breaks the membrane very easily. So typically what happened, that we designed selectively and we wanted to study that what is the effect of hydroxy group versus the O-methoxy groups. Anyway, this monomer design is also not so easy and it is really complicated. But somehow after doing lots of study, we found that it forms different kind of isomers. But anyway, isomers it forms, but it does not affect the polymerization reaction because it has the same functionalities. So we made 2 series of polymers, one with OH and one with O-methoxy. And properties were characterized. And once we found this is the most important slide, that DHN 50, 60 and 70 means your degree of sulfonation 50, 60 and 70. And methoxy also 50 and 60, same level we put. And then we wanted to study their membrane stability in Fenton reagents. So Fenton reagent is typically a mixture of sulfuric acid and some copper salt, which creates your peroxide radical immediately, hydroperoxide. And we can see that in Fenton reagent, almost basically there was no change in 24 hours, 98, 96, but in case of O-methoxy groups, that decomposes in the pieces. So I will be not going much these things again characterized by different tools, and lots of polymer were prepared the same way, and we wanted to get some idea. But in this case again the major problem starts that imidization chemistry, you need to go for very high temperature. If it is not fully imidized, then your membrane actually what is hydrolyzed in presence of water, and it creates some problem because it's a polyamic acids and water itself get hydrolyzed the membrane and molecular weight deterioration takes place. So we go a little bit to the your triazole chemistry. I have 2 minutes, I believe. So polytriazoles are typically again another chemistry what we utilize to fabricate different kind of membrane, because triazole ring is much more stable than the polyimide, and chemistry wise it's a click chemistry. The reaction could be done at relatively low temperature than imidization chemistry or your nucleophilic displacement polymerization with the phenols one. So this way you can do a reaction chemistry at your 80 degrees centigrade. So only thing is that whatever amine groups, amine kind of monomers you do have, you convert them to the azide monomers. So once you have azide, you do the conventional click chemistry by using azide alkyne click chemistry, and then it's a very easy chemistry, and it's a kind of it looks to be a kind of polyaddition reaction, but it follows the polycondensation mechanism because there is no elimination. So we converted all the amines to different kind of azides. And once the azides are ready, we make different kind of polymers. So you can make different kind of polymers through the azide, and you can manipulate the polymer structures one after another, and can check the polymer properties, that how they are basically affecting the membrane properties. So simple reaction, azide alkyne, and take a kind, this is a kind of commercial monomer, you take it and make the chemistry. So we make many sulfonated polytriazoles, and you can see that sulfonated polytriazoles were made at 80 degrees centigrade. So it is relatively low temperature than 180 degrees centigrade, and there was no issue. Yield was very, very high. Mechanical stability of the membranes were very high, and suddenly in the hydrated state it is reduced little bit, but still it is far above than comparison to the Nafion. And that gives a very nice your phase segregated morphology. Once it is, these are the actually your TAME picture, your lead acetate stained, and microtome, membrane microtome was stained by lead acetate, and then the picture was taken, the black spots are corresponds to lead. So it indicates the distribution of the sulfonic acid groups, because it sulfonic acid groups makes the sulfonate and attached with the lead plus. Anyway, I will be not going to this kind of things. We also little bit attempted to again to increase the membrane stability to the cross-linking approach. So you put some kind of cross-linkable group during the polymerization chemistry, you utilize that way, and then finally cross-link during the fabrication of the membrane. And we perform some kind of MFC also, microbial fuel cell, and at the present we are studying also hydrogen fuel cell. And you can see that performance wise some of the membranes are not very much inferior or even close to Nafion. So possibly these kind of membranes could be utilized. We are planning for it. We are talking to different companies that if somebody is interested, we can make it in little bit larger quantity. So in summary, that we have made several class of high performance polymers, and our main aim, one of the major aim, we had actually to make them soluble, and which we successfully made them soluble by utilizing different chemistry and designing different kind of monomers. We tried to address some of the issues like, say, reduction of dielectric constant. It was possible because Kapton has dielectric constant of 3.4, and by designing this kind of polymers, I should say little bit in your conservative manner, that we can have polymer even up to 2.8, 2.9. So in dielectric constant reduction from 3.4 to 2.8 or 2.9 is also not marginal, it is huge. And to taking another approach like electrospinning or hyperband, there is again possibility to further reduction, but exploitation of such kind of materials in real application need to be checked. Thirdly, we tried to design some polymer membranes for gas separation, and we made some membranes which has very, very high oxygen nitrogen selectivity with a high permeability. And also some of the membranes were very useful for benzene and cyclohexane separation through the pervaporation technique. Fuel cell membranes, proton exchange membranes, we are working different classes of polymers, polyethylene ethers, polyether imides, and polytriazoles. The work is going on, but we found the polytriazoles are the best material candidates among polyimide and polyethers. And now we are at the moment, we are basically measuring the your single hydrogen fuel cell capability, and the work is in the process. So typically I'll basically dedicate these works to my core workers, because this is not my work. I hardly contributed any work in my hand except by supervision. So these 26 students have worked in this field. So these are very summarized work. And I am collaborating strongly with Brigitte Foyt, who is the director of Leibniz Institute of Polymer Forschung Dresden. Then Venkat Padmanabhan, who basically is doing MD simulations. I have not presented. It's not possible to go through lots of data. And University of Bayreuth, I am collaborating with Sima Agoral and Andreas Grener, and in Polaxi from Russian Academy of Sciences. We have joint project also with them, but unfortunately during the COVID time he expired, and so I have another new collaborator. Yes, he's not there in Russia. And suddenly colleagues from Kharagpur, and the funding is CSIR, DST and SERB in India. Water, I had a strong funding from Wakar Metro Chemicals Private Limited. So it's a huge funding. IIT Kharagpur and AVH, Alexander von Humboldt Foundation is supporting always. And thank you all for your kind presence.
Thank you so much, Professor Banerjee, for such an informative talk. I hope all the audience must have enjoyed this talk. So we can now, this is the time to take few questions. So you have a question. Okay, please.
Thank you, sir, for your informative lecture. I have a query related to the molecular engineering of designing small molecules. That you have started with a small molecule having CF3 and the fluorine and bromine group.
It's always from that one. There's 5-bromo-2-fluorobenzene.
Now my query is, sir, can you reduce the synthetic steps like you are going for the boronation? So if you can do direct CHRLation using your starting material.
It's not possible. Like, you know that chemistry depends, you cannot do. Let me tell you why I have put CF3 in the ortho position.
Okay.
If you don't put CF3 in the ortho position, elimination reaction is not possible.
Yes, sir.
You need an electron withdrawing group. So that is the thing has been put. And these are not much steps, because the problem is that I showed all the steps to all in single slides. So that's why it looks to be many steps, but it is 1 to 3 step reaction to up to fluoro. So and up to 3 step you can have a synthetic yield. Roughly we have calculated up to 72%. Okay,
sir.
So it's not less, because if you and with a high purity, because polymerization, you know, the greatest disadvantage of condensation polymers, your monomers should be as pure as possible, if not 100%.
Okay.
If not 100% means people will prefer 100%, because the reaction proceeds through the mole balance. Because if you have mole change, one AB type of polymerization, you cannot get a high molecular weight product and no membrane formation is there. So it's not much step, and some of the things in chemistry is like that. If you wish also, you cannot do.
No, sir, my question is, instead of going the boronation step, you can use this the red one. You use the direct CHRLation.
We have done it, but you cannot go, because this is a monofunctional compound then.
Now you can use other monomers like fluorine.
You cannot do, because see, this is bromine elimination is not that way possible. Fluorine you can do from that. Then it acts as a capping agent.
Okay. Okay, sir, thank you.
Okay, actually, so we'll take one more question because we are running late. After that.
Okay. Let me tell you, in my job is to design the electrolyte. So I cannot comment much of your question if you ask to the electrode part, first of all. So my domain is electrolyte, and we are basically designing solid electrolyte material. So earlier it is used some liquid, ionic liquid, they are corrosive, they spill over, many issues are there. So now we are basically designing single solid electrolyte, not only for fuel cell, we are also going for lithium and lithium-ion batteries also. So this is the main goal.
Thank you, sir.
But I cannot comment that.
Okay. So thank you so much once again.
Your friend Professor Pradhan, you told na? So Professor Pradhan can comment that part.
So thanks once again to Professor Banerjee for such a wonderful talk. So now we'll start the next presentation, which is a industry presentation.
So before going to that, sir, please. So there is a small token of respect from our side. Sir, you came and delivered such a nice talk on polymeric materials and different polymers. And I would like to invite Dr. Manas Kumar Dalai sir for present this memento, please.
Okay, so now we'll move fast because it's already launch time. So we'll go for the industry presentation. So we'll keep actually the maximum 10 minutes for each talk. So all the speakers are requested to actually within that 10 minutes. The first presentation of industry presentation is by Dr. Sivanand K. Nanjundagwada from ITC Life Sciences and Technology Center. So please, Dr. Sivanand. Oh, he will be present. Okay, it's an online presentation.
Oh.
Yeah. So please go ahead.
Thank you. I believe I have 10 to 12 minutes. So good afternoon. I'll try to close within the time. So I'm just going to overview on trends in or advances in the coating materials at the moment, what's happening in industry, particularly in sustainable solutions. Myself is Dr. Shivananda. I'm heading an sustainable material division in Life Sciences and Technology Center in Bangalore. I'll just going to give small brief introduction about ITC. ITC is a conglomerate business which is having more than 13 businesses, which is paperboard, specialty paper, FMCG, and this is a centralized R&D for all across ITC. And we belongs to corporate R&D in Bangalore. And this corporate R&D basically we classified into 6 segments, and I don't want to go more details. And we majorly are looking after sustainable material and packaging division. So this is our management commitment towards sustainability of in India on both climatic change as well as in a sustainability 2.0 in ITC. I'll just take through some overview of how market is moving towards an sustainable solution. If you see in 2022, global paper market has been crossed almost 150 billion mark, and also food packaging has grown drastically, and particularly in the export growth, and majorly in the Asia Pacific region, which is this area is majorly focusing on very high paper-based material for a sustainable alternate to the conventional plastic or single-use plastic. And recent trends in liquid packaging, if you see, this is the biggest concern in the single-use plastic, which is majorly liquid packaging like paper cups or tubs or even the bottles. If you see across in globally, it is almost 460 billion in 2021, and it is reaching almost 800 billion by next 7 to 8 years, which is a CAGR growth around 5%. And liquid packaging majorly is in India. So we are in the paper cups and also Tetra Pak related rigid boxes, and also global production of bioplastics. I'm just summarizing the global production of bioplastics and how it is growing. If you see from 2020 to next 5 years, how much growth we can expect is more than 25% of biopolymer production. The recent example, which the best is PBAT material, which brought down to the no way to the almost equivalent to PA granules. That is the way entire globe is moving towards bioplastics. Some basics about the paper and paper making, what we ITC do. ITC is a leader in a heritage of last 4 decades of pulp and paper making industry, creating wide spectrum of packaging, packaging board and specialty paper. And also we are the leaders in the value added paper boards in India. And we have 4 different places manufacture unit. One is Bhadrachalam, is Asia's biggest paper mill, and also Bolaram, which is value addition to the paper board, and Kobe, which is in Tamil Nadu, which we produces recycle board, and Tribeni, we produces specialty paper, which is total consists almost 9 lakh ton metrics per annum we producing currently in the paper board business. And we are also having a printing and packaging manufacture location in 4 different locations, which is started in during Britishers. Munger in 1925, followed by Chennai, Haridwar, and recently last year is Nadiad. We produces roughly around 75 to 1 lakh tons of paperboard conversion and yearly, and 15 to 20,000 tons of film conversion in the packaging, flexible packaging industry. So these all put together, we are touching roughly around 10 lakh or 1 million packaging material we are producing. Out of that, 98% is in a paper-based substrates. And these are the range of paper products we offer in ITC. Number 1 is paper boards, fine paper and specialty paper. I don't want to get into more details. And these are all normally paper, and how the paper is a basically single layer structure which is both sides surface sized, and cup stock paper board which is a 3-layer board, and the top and bottom is size pressed, and printing folding box board or SBS board is a 3-layer structure with the one side coated with clay, and recycle board is a, both gray back and white back we also produce. These are the major packaging industry boards, and this is the one is a paper in a single use alternate we are using. This is about single-use plastic. I don't want to take much time and food industry. And I just wanted to highlight one point here. We recently, 22, we did some literature survey on a customer or anywhere in India, how much they're willing to offer any sustainable solution when you are offering into the customer. Almost more than 20% people are ready to offer premiumness, are ready to spend money for sustainable packaging if you have a right quality of sustainable solution in the market. This indicates there is a lot of awareness is initiated in India, and people are also having a particularly metro cities like Bangalore, Chennai, Hyderabad. These places are people are ready to spend up to 20-25% of extra money in order to sustainable solutions. So these are the biggest opportunities in the QSR segment. Government is banning on single-use plastic issues and currently available alternate packaging like bagasse and glass and other things. The only thing biggest lacuna at the moment is the credentials of these options, which is a compostable, which is a biodegradable, which is a right material. That is the one is the biggest lacuna at the moment in the industry. And we are majorly working on barrier coatings. I just wanted to come into my main topic. What basically we do is we take in a paper and we apply in a barrier or paper board in order to move the high concentrated material to low concentrated to avoid multiple options like oxygen barrier, moisture barrier, mineral oil barrier, aroma barrier, all these things. So some of the parameters which affects on the barriers is like mineral oil, water barrier, oil and grease, odor, heat soluble, heat resistance, oxygen and food content. And if you see the entire industry classified last 6 decades, how this barrier coatings works. Very beginning, people at least 4-5 decades back started working on wax coating, which is majorly synthetic one, and it is banned laterly. Then people moved in 90s and 2000, which majorly an synthetic polymer extrusion coating, majorly we call as a P extrusion coating, which was ruled almost 2 to 3 decades of entire industry. Then last some 5-6 years or 10 years, people are exploring on a biopolymer extrusion, and people are now is a vigorously market is moving towards an aqueous based coating, which is completely most of all people are working on this particular segment. And what are the critical parameters
you have
to evaluate
two more
barrier
minutes.
properties? Number one. Okay, oil and grease resistance, water deep resistance, heat sealing, and layer adhesion and stretching. And what ITC offering in sustainable material in paper cups? Basically, we are moving towards multi-layer, means non-recyclable to repulpable or recyclable to compostable. This is our executive summary of entire process. We are moving from multi-layer to home compostable. These are the solutions we are offering in ITC through an R&D: compostable coating, plastic-free coating, germ-free coating, recyclable coating, barrier coating, and parameters like OGR, mineral oil, heat seal, eyeglass, antiviral, antibacterial, strength improvement, moisture barrier, oxygen and aroma barrier. So these are the differences between conventional PE coated, emulsion coated, extrusion biopolymer coated, and what ITC has developed an proprietary formulation. If you see, this will cover all the parameters of what is required into the market, like including barrier properties, compostable and recyclable. And these are all our brands, which is in QSR segment: BioSeal, Pillow Wave, Omega Bear, Reduce Reuse, OxyBlock, and Pillow Pack, Pillow Serve, and Germ Free. And Indo base, basically we classified into 4 segments. This is PE base coated. We are no more in this segment. Now we move to biodegradable brands, then recyclable boards, which is majorly water-based emulsion coating. And these are all biopolymer coating again, and these are all again biodegradable coating. These are the various parameters or brands ITC is offering, particularly Indo-Base or Pillow Pack Omega series.
Excuse
These
me.
are all our brands supplying across India.
Excuse
you.
me. Yeah, thank you. So thank you actually for completing in time. So I think we'll take only one question from the audience. If you have any question, please ask. I think there are no more questions. Maybe we'll move to the other talk. Okay, thank you. Once again, thank you, speaker. And the next talk is by Mr. Kuldeep Negi from GAIL India Limited. So I request Kuldeep Negi, please.
Namaskar and good afternoon. It is indeed a great opportunity for me, to be in this conference because we are speakers, from different parts of the country. They have come and disseminate information about their achievements, their technical developments they have carried out, and research also. That is among ourselves. It is really definitely a great platform. At the outset, I thank that is CIPET Bhubaneswar, the entire team, who have really putting in so many efforts, in making this conference a successful one. As far as I'm concerned, I'm Kuldeep Negi, DJ Marketing, GAIL India Limited, okay, and I'm from GPTC, that is GAIL Polymer Technology Center, and at GAIL, as you know that, we are into petrochemicals. It's a Maharatna company under the aegis of Ministry in that is natural gas and. Okay, so at the GPTC, basically this is a technical wing of our department, petrochemicals, and since we are operating two petrochemical plants, that is one at GAIL and the second one in joint venture with BCPL. Okay, so at GAIL we are producing around 8 lakh and 10,000 tons of LLDP and SDP, and in BCPL, which is a joint venture, we are producing around that is 2 lakh and 80,000 tons of LLDP, SD polypropylene. And we are dealing with more than 1,000 customers, that is across the country. So in order to keep pace with the customer demand or market requirements, we keep on doing modification in our polymer raw materials. Okay, we come up with a new grade development. Okay, we join hands with additive manufacturers to develop new additives for our polymers. Okay, and we also join hands with end users, the converting industry, to I would say that for new application development. So basically, and every year we do these kind of modifications and developments. So just I like to share what we have done, that is in just few months back. That is a small developmental work, I would say, and it is going to change the dimensions of Indian market, especially that is in piping sector. It is actually P100 SDP orange compound for CGD business. Okay. And just I like to actually the natural gas industry of a country, it is just contributing, I would say, that 6% in our total energy mix. And our Honorable Prime Minister, he has basically made commitment that the carbon, I would say that emissions, that is going to be reduced by 40% to the level of 2005. Okay, and the contribution of natural gas that is in our energy mix is to be made approximately 15% by the end of 2030. And it is only possible when government, promotes that is usage of natural gas that is in our industry, in our retail sector, that is in our consumer sector. And there are government schemes, or I would say policy enables to promote usage of gas in the country. Okay, that is like you have seen that CNG buses are that is being operated by some state departments. Then you have like CGD business is going on in a big way. Okay, because if you see that the CGD business actually there is a board. Okay, that is called PNGRB. They allot the GAs, that is different graphical areas, and if you look at the data here, you can see that CGD at present it accounts for third largest consumer natural gas. Okay, and this business was started off in 2008, and now this 12th round of bidding is already completed. And after this bidding, almost we can say that the total population of India will be covered that under CGD network. And regarding this piping sector, there has been a significant development in the piping sector. They were basically like conventional materials were being used few years back, but now the middle part, that is the pressure up to 7 bar and pressure up to 2.2 bar, totally the piping has been changed to that is SD pipes or MDP pipes. So there are two kinds of pipes which are used in the city gas. One is your that is yellow in color, which is MDP, PAT material, and the second one is your P100, that is orange in color. Okay, but now the mix is different. Now you can say that 90% of the piping metal is P100, that is orange in color, and the 10% I would say is about MDP P80. And just one more fact which is very important to know is that all the material, that is whether it is P80 or P100 orange compound, they all are imported. Okay, so it is basically definitely a shocking for the industry that this market is growing up, and the government basically has taken a lot of initiatives in expanding the business CGD, but there is no, that is I would say indigenous source of material that is for this application. And I said that the GAIL basically is into petrochemicals, and we are also into natural gas, and we also have I would say a lot of GAs which is we are already using, that is imported material that is for our CGD business. So basically then definitely yes, an idea that is came to our mind that when we are already using this material for a CGD business, and we have already P100 SD pipe producing from a Pata plant, then why don't we basically come up that is with a new grade or with a new developmental work on the CGD business. So basically we took an initiative, and this is some of the demand basically which is growing up. So actually then it triggers, like when market demand is going up in CGD business.
You have two more minutes, huh?
Yeah.
2 more minutes.
So this is basically like steps, which we have carried out or we have followed, to make this a small, I would say, trial lot of this grade for this CGD business. So there are various stages. We conducted a market potential study. We also had a consultant for this, and then the imported material which is coming to India, we have analyzed and we have reviewed all the specifications of imported material, what it contains, what kind of formulation is there, what kind of additives are being used in this. Then we did our technical feasibility of our grade vis-a-vis their imported material. Then we formulated a specification that is for a new grade to be for this CGD application. And then the most important part in this particular that is grade is your pigment. Pigment is a very, very, I would say, key attribute. So like organic pigment is there, inorganic pigment is there. So that we have selected after doing a lot of evaluation. And then you see that we have made a very small base resin lot at Pata plant. And then this is your what we did before compounding resin, after compounding, all machine trials were there. And after making this trial lot, then we have our empaneled vendors. They will process the metal and make pipes. These are the various specifications that we have to comply with before going for commercial viability. This is a 14885. This is the I standard for gas pipe. So after passing all these parameters, that means our metal basically it was well prepared for commercial trials. And we have already made now adequate quantity of this grade for commercial trials. And very soon it will be used in field trials of our own site. Thank you.
Yeah, let's thank to the speaker. So I think we'll take one question only. So if anybody having any question, please. I think no question from the audience. So Let's thank once again Mr. Negi for his nice talk. And now the next speaker, I'd like to invite Mr. Gaurav Gupta from AICTE Research and Technology Center, Ashirvad Pipes Private Limited, Bengaluru. Yeah, please.
Well, by the time the presentation is being loaded, myself, Dr. Gaurav Gupta, and I am basically a physicist who has done my PhD from the Max Planck Institute, Germany, and after that I have had like over 7 years of work experience in elastomeric composites and thermoplastic materials. Okay. So here I am representing AICTE's Research and Technology Center, Bangalore. So basically this is one of the R&D center which the AICTE group has globally. So we are having 3 global research centers, one in Toronto, another one in Paris, and the third one here in Bangalore. So today I'll be giving you some idea about the influence of materials engineering on the acoustic properties of polymer pipes. Before we go into that, I would like to let you know that who we are as AICTE group and what is our vision. So our purpose is to bring solutions for water management. So basically you can think about wherever water is flowing, we try to provide the solution with a vision to provide transition to clean water and energy. Who we are, we started here in India as Ashirvad Pipes Private Limited somewhere around 25 years ago, and in 2013 it was let's say overtaken by the AICTE group of companies. So we have now, we from heart are Indian but Belgian by ownership. So in India, we are popular as Ashirvad Pipes Private Limited. So that's why you see the logo Ashirvad by AICTE. And we are providing solutions from tank to tap. The complete, so wherever you can think about water is flowing, we are providing solutions to the water management. But not just that, our goal is to provide technical and innovative solutions. We are proud to be a part of Make in India, and we have roughly like 4 to 6 plants which are operating all over India. Now coming to the main topic which I wanted to present before you, because time is also short. There is one vertical which is coming up is regarding the sound or the noises, right? So especially in healthcare sector and also in industrial buildings. Now, when you are sleeping in night, right, in high-rise building, if you are having a flat, and if somebody flushes, right, and then you hear disturbing noises, right? So there is a concerted effort to reduce such kind of noises. And also in the healthcare sector, there are, let's say, regulations or need, rather regulations, necessity of having silent or silent atmosphere is coming. So where you have to be below a certain dB level in the room. So now sound can be coming from external noises which you know, road, rail, air traffic, or it could be indoor noises which are coming from conversations, your TV operations or whatever. Another one could be movement of people or furniture falling down around, right? And others specifically concerning the buildings when I'm speaking about is coming from elevators, tap, mechanical, ventilations, or specifically the water which is running through the pipes, right? So what is discomforting is anywhere sound which you are hearing above 85 dB, whatever you are hearing is not good. So you try to be on the lower side, roughly around 25 to 30 dB. So that's where you are more comfortable with that. So what type of noises can originate when water is flowing through the pipes is there are two types of noises, basically airborne noise and the structural noise. So the airborne noise, you can consider it to be like when I'm speaking to you, the sound propagation which is happening through the air, that's called as airborne noise. Structural borne noise is something which passes through your clamps and then passes through your concrete walls, and these vibrations are then detected by your ears. So those are called as structural borne noise. Now, most of the noises in the pipes which is coming is because of the water flowing or falling from a height, and 70% of your noise is contributed by the airborne noise. Okay, so now what are the methods to reduce those airborne or structural noises? From the material perspective, there could be basically gradient structures which you can produce. So you can have multi-layered pipe, or you can have parts which are varying in thickness. Density, you can have foaming in the pipe, or you can make a hollow structure. You can add functional fillers with varying density. You can have multi-layered structure, or you can change the stiffness of your product, right? The second aspect, which on the design part is where you are putting the clamps. So all those things go into your recipe optimization and the design of experiment. And lastly, the structure property and the processes, how you are measuring. And so what I would like to show you quickly is the acoustic capability which we have at the R&T center. So this is only one part of it. We have like more than around 100 equipments for doing the analytics of polymer characterization. So here in this acoustic chamber, what we are having as key points is that it is having a background of less than 4 dB. So this is a very, very silent room. And I think that at least as far as I know, this is one of its kind facility which we are having in India. What this is comprising of is basically a part where you can mount pipes through which the water is falling through. What you can see in the middle is the microphone which captures the sound when the water is falling through, and then over there there are some speakers which are emitting noises. So those are for reverberation, calculation of the reverberation noises. So with this chamber, what we are trying to achieve is it's an eco-free design, and it also provides us non-destructive acoustic property checks of our products, right?
You have two more minutes.
Yeah, sure. I'm just coming to. So this capability is as per the EN standard. Right now, there are no regulations as such as with respect to the sound in India. So what we as Ashirvad are trying to bring in here, technology or regulations or products with certain regulations. So I'll not go into the detail about these mathematical equations. So that was for the products testing. For material optimization or checking the properties of the materials, because every time we are developing a material, we can't produce a pipe to test it whether this is optimum or not. So what we have is another capability with respect to acoustic impedance tube, which we have developed with Technical University of Delft. And here you can measure the transmission losses and the absorption of sound properties within your material. And for that, you only require around 100 mm or 30 mm disc, right? So with the help of this acoustic impedance tube, you can measure the material's property, which then you can do. So what I can show here as one of the example is about the transmission loss. So where we have engineered a material, right, with different properties. So here they are on the scale of length, you can say. And here on the sample 2, you can see a mineralized layer, which is having a different density as compared to sample 1. And also the thickness is different. So you see that the transmission loss in sample 2 is higher as compared to sample 1 in the frequency range between 50 to 400 to 500 hertz. So that's something what you require to have a good acoustic material. Looking at the same pipes which were made from these materials, we can see that with respect to the different rate of flow of water, you find that the sample 2 is showing a smaller transmission in percentage values. I cannot disclose the values, of course. So what we find is that basically you have lower transmission in sample 2, which we have identified using the acoustic impedance tube. So to just wind up, we are building a new capability at the National Lift Tower, London. So just to give you an idea about what type of facility is this tower is approximately 130 meters in height. So we'll be constructing facilities where we can test the complete setup of our pipes and the clamps to mimic the conditions in the room. Okay, and that too we can monitor and operate it sitting here. So we'll be using artificial intelligence. So somebody will just only mount up the pipes and the system over there, and we'll be monitoring and doing the experiments sitting here. So that's what we are doing. So high-rise drainage systems, just to conclude, are having multiple challenges, of which I have informed or told you about. Noise is one of them. So what we are doing is we are working on designing new products and also engineered materials. Okay. So with this, I would like to thank you, and I'll also I forgot to thank the organizers for giving us the opportunity to be able to present this work to you. Thank you.
Yeah, thank you so much, Dr. Gupta. So now it's the time to have some question. At least one question we will take. So any questions from the audience? I think there are no questions from audience, but I have one question. Yes. Oh, okay, Dr. Tripathi. Yeah, please.
Why do you change a tank from tank to tap?
So, well, we are having products basically from groundwater extraction, which is then supplied to the household, domestic household, actually to the top of your buildings where we are having storage tanks. So it's a complete range of solutions which we are having. So siphonic drainage system, air admittance valves, or anything which you can think where the water is going, rainwater harvesting. So that's it. So that's the reason why we call it tank to tap.
Okay, so just excuse me, I'll just ask one question. Yeah, so it's a really excellent talk, and the thing is you are producing this pipe, and the interesting part is actually you talk about the reducing noise, yeah? And with some acoustic standard, there is some number you put, yeah. I want to know actually where you get it standardized actually from where in India?
In India there are no such, let's say, standard or regulations.
No, it's there. It's in so acoustic and vibrational standard department is there in National Physical Laboratory.
Okay. So basically, since we are also looking globally, this standard is one of the global standard for acoustic properties, EN 14366, because we also are having our products being sold in Europe as well as in. So we are looking at global market also.
So what I'm asking, where you standardize actually such materials? If you will standardize also in NPL, NPL is the NMI of India, so it will give the global caliber.
Right now our products are being standardized or verified, let's say, in testing form at the Fraunhofer Institute in Stuttgart, Germany.
In Stuttgart. Okay.
So we are certified from there
Okay.
of approximately like I think 13 dB for one of our products,
Okay.
which we are.
Okay. Okay. Then. Yeah. Thank you. So let's thank once again to the speaker. Now we'll move to the next speaker, Mr. Suraj Kumar Gantayat. So, Mr. Suraj, please. Yeah.
Yeah. So I am representing Radian Fluid Tech. So we have entered into this business means last 1 year. It is not last 1 year also. We have started our operation I think in March and April. So but we are mostly focused on the quality and the R&D part. So as you know, the SDP pipe, which is means aligned with the UNDP sustainable goal, as it is a plastic pipe. But also, if you see the life cycle analysis of this SDP pipe, it is better than the iron and DI pipe in terms of energy efficient, in terms of transportation, in terms of recyclability. So if you see the whole life cycle analysis LCA, so it is better than others, and also it have the lower failure rate than iron and ductile pipe and all. So now everywhere in Jal Jeevan Mission and other thing we are using SDP pipe most commonly. But once we look into more deep, means once we entered into the SDP pipe market, we came to know that the material and the production technology we should improve as part to the iron pipes and better than that. So here one of the standard 14534, this is a guideline where they told we can't use recycled material in the drinking water pipe supply. So the problem is if you use other material or low quality standard material in the pipe, it will have different problems. It will reduce the lifetime of the pipes, also it will leakage and contamination, and that will be a public at risk. But the same thing, if you see the P pipe is used for cooking gas with zero leakage from last 30 years, but in the municipality water distribution the NRW is 30%, which is very high. So then we look into that what is the toxicity if you use different material into these pipes and all. So that will be a problem. Then we came to know that in UNDP there are 13,000 chemicals are there in the plastic. Out of that 3,000 are potentially concerned for the human and other health, and out of that 3,200, 40% is water soluble. So then we thought we should put our money into the R&D and for the cause of the human being. Then we started that. So we came up with the concept, I think first time in India. So integrity of the raw material, traceability, and zero toxic criteria for making of the plastic pipes. So in that thing, we are implementing 3 approach, as I told you. One is first is once the raw material, we are typing with GAIL and other good quality raw material, and in that whatever the prescribed format is there, we are using GPC and DSC for the raw material standardization. Then also we have a complete DTMS system, digital tracking system with IoT and blockchain enabled. Now we are working mostly on the zero toxic materials for the pipes. And digital material tracking system, this is also in-house. We are developing specialized to the pipes and the material tracking, and also we are working with IoT and blockchain. And the second one is zero toxicity. We have come up with a fund. We'll work with CIPET and IIT and other institute to know what are the toxicities are there and how we can use and produce better quality of pipes. And also we are working on with global organization like Pipe Institute of and others to come up, and also we are planning to working with other departments so that in the standard the toxicity aspect will come. And this is our redefining industry standard for the SDP pipe. As I told you, this is our vision. And so this is our expectation from the stakeholder, monitor the recycling route of the plastic, then same standard as the city gas distribution. like GAL come up with the compounding thing and all. So this will be good for the industries. And this is 2 or 3 slides about our company. So as we knew, we have one of the largest capacity in Odisha, 18,000 metric ton at Khorda, and we have got some certifications, and he is our chairman, so mostly he is promoting that. Mostly he is the highest paid CEO in India, 2008 owner, and we have other groups companies, but this is our baby company into polymer. I think we'll grow big at this one also. And these are some references, and this is our tagline. Thank you.
Thank you so much to our speaker. So if any question from audience, you can ask. I think there are no more questions. No questions from the audience. So now we'll move to the next speaker. Thank you once again. Now I'd like to request Mr. Nagraj K from NatureTech India Private Limited. Yeah, please. This is the last talk.
This is one. Left-hand slide moving. Good afternoon, everyone. Unfortunately, time constraints, so I will just go through my presentation, just run through that first. I can understand your feelings. I think everyone is very hungry. So consider that I will finish my presentation soon. So my name is Nagraj. I am from NatureTech India Private Limited. So I'm in technical department. So we are one of the US-based company in a group of Northern Technologies International Corporation. So we are in this field last 18 years in India. So we are one of the pioneer in bioplastics industry. So we are in the business of, one is the compounds, second is the waste solutions, single-use packaging materials, and apparel packaging. This is our business. So our headquarters in Circle Pines, our research and development, quality control labs in various regions in the world. You can see the process, R&D, everything actually. So this is our R&D capabilities. So we working with Michigan University, Dr. Professor Ramani Narayan, and the National Science Foundation, NSF in US Department Defense, and the Clemson Center of Flexible Packaging. So we working with these companies for our development, research and developments. So what we do, as a NatureTech, what we do in material to improve it. So if you take that, there is a polyesters, generally compostable polyesters are, compostable materials are polyesters, homopolyester are copolyesters. We will take the polyesters, we will use the modifiers like monofunctional, difunctional, polymeric linker, these are all the chemicals modifiers we use it. We do use and twin screw compound, and the compounded material like chain end functionalization or block architecture or graft architecture. Usually we use like polyester like PBAT, PLA kind of a polyester we will use with John Cryle and make that chain end functionalization. Block architecture and graft architecture we do work with PDMS and PLA, lot of patents we are filed it. This is our expertise. So today I am taking the concept is like the PLA thermal properties. So everyone talking about PLA for the sustainability or biodegradability or at many concepts. So PLA have lot of pros and cons. One of the cons is that it's a lower thermal stability material. If you take this material above 50 degrees Celsius, it will be deformed. So that is the major disadvantage. So we worked with PLA how to improve the thermal characteristics. So this is our work. So I taken as that PS and PP as the comparison for PLA. So glass transition temperature of PLA is 55, melting temperature 160, PS is amorphous 110 and melting point not available. PP is high crystallinity 0 and 140 and 170. So at room temperature PLA is very stiff and glossy similar to PS. So the glass transition temperature of the PLA is above room temperature, that is the reason PLA is very stiff. This is very difficult to process, low melt strength material. Okay. To overcome that, so you can see that the difference between PP and PLA is the semi-crystalline. PLA is a low crystallization rate. Result is poor performance in high temperature above 55 degrees Celsius. So this is the result for the PLA for 55 degrees Celsius. The reason is the low crystallization rate. How to improve the crystallization of the PLA? Usually PLA is amorphous or semi-crystalline. When you process the PLA, very difficult because of low melt strength and stiff material. So what we done is we have compounded the PLA with some impact modifier and nucleating additives, and taken this master batch as a master batch, taken this blend with PLA like Ingeo 3052D, Ingeo 3001D and the Ingeo 3100 HP. We taken the same compound BM300HT with a different level with a different PLA grades and injection molded. We have got a different properties. I will just explain you in few slides this topic. So the difference is the first grade is you will get just the general purpose PLA product. The heat deflection temperature is only 55 for the first grade. When you take the second grade, when you injection molded with this material in the injection molding process, you need to connect the mold temperature is around 110 degrees Celsius with mold temperature controller. When you take this, the mold temperature controller is 110 degrees Celsius, the PLA crystallization temperature is above 90 degrees Celsius. So the PLA will be crystalline at 90 degree in the process. Since we added the nucleating agent, our crystallinity of the PLA will goes to above 50 degrees Celsius. Sorry, above 50% of crystallinity. When you get the above 50% of crystallinity, you will get the HDT of that compound is like that 80 to 90 degrees Celsius. So the difference between the HT grade and IM grade is this is the heat resistance with impact strength. This is the faster crystallization rate in the mold. Why we talking about faster crystallization in the mold? When you talking the molding, the cycle time is very important. If your cycle time is very high, commercially you cannot process that. Commercially you cannot use the technology. So we use, how to increase that? The crystallinity is a two-step. One is that post annealing. You make the injection molded component and take this component into the oven at 90 degrees Celsius in 2 minutes or 3 minutes. When you taken this component into 90 degree, slowly the PLA will be, the crystallinity will be increased. Okay, but this is the offline process. When you go to commercial, it won't be work as the regular production lines. So what we done is, in mold process, we have done this crystallization increment. Okay, so this is kind of a commercially successfully running product in many industry. We are patent this technology also. So when we taken this process, we run this 8 to 32 cavity mold. So the machine capacity is 350 tons. The post molding annealing seems to be 10 to 20 seconds. Molds at a room temperature similar to PS. Conveyed to oven 1 to 2 minutes. So the post process definitely for the commercial point of it will not work. So we taken the in mold annealing with MTC. Using the MTC, we taken the mold temperature at 110 degrees Celsius. The cycle time is below 50 seconds. So high heat performance, if you taken the range like storage modulus with temperature, if you graph it, so PLA is the green and the HIPS is the orange and the PP is the brown. So the good range is coming into the range of the circle. The PLA is not at all coming into the storage modulus. So that is the reason the heat deflection is less. So when you taken this crystalline 3100 HP, when you injection molding, your storage modulus is increasing. So we are getting in the good range of that, the value of the storage modulus. So this is the reason we do getting higher heat deflection temperature increase in the process. So the toughness is increasing when you using our master batch with PLA compared to PS and HIPS. Strength and flexibility also increase. The toughness also increase. So when you compare that the three grades, the heat resistance is low, medium and high in mold annealing. The toughness is moderate. So cycle times are very faster in the in-mold annealing. The compostability, yes. Because when you're doing this technology, the compostability should not lose. If your crystallinity goes to above 60% in the molded component, you cannot get the biodegradability standard qualification. In disintegration study, you will fail. So we need to manage that percentage crystallinity between 50 to 60. In meantime, your heat deflection temperature to get it 80 to 90. So the bio-based content PLA is almost about 90%. So I would like to just stop it here because of the time constraints. I have a lot of slides. I would like to stop here. If you want to continue, I am continue that. No, we have a different grades and different applications like extrusion coating. So these are all the thermoforming for PLA, profile extrusion, thermoforming, and zippers. The zipper is that kind of a very intrinsic product between the male and female parts needs to be closure. Okay, there should be some intrinsic properties required to when you make that zipper profile. We bring that properties in the compostable polymers. So this is the different grades of flexible packaging grades. So end of the day, the Nature-Tech offers the lower carbon footprint material, bio-based material, reduction of feedstock in fossil fuels, the applications and the product highlights. Maybe I can share this presentation to the CIPET team. If anyone interested, please go through that. Sorry, I couldn't go through detail on the every slides. Any questions?
Okay. Thank you so much, Mr. Nagaraj. So if you have any question, please ask. Okay, please.
Yes. Since you have first basically compliment to you for bringing out innovative product in PLA. Since you have mentioned that you have done some modification in PLA by impact modifiers, which is another polymer.
Yeah.
And which is already you can see that bio-based component is more than 90%. Okay. So how do you ensure, the integrity of biodegradability that is in your compounded material, because PLA is known, 100% biodegradable in nature, okay, and looking at the current scenario, okay, because disintegration will be there, okay, once you add a polymer to a biopolymer, okay, so how do you ensure the integrity of the biodegradability in your compound?
The question is like maintain the biodegradability when you formulating it. Yeah, whenever we choose the material to work on it, we will take only 100% it is compostable or bio-based, then only we will take the material for formulating it. Because today ISO 17088 CIPET is very expert into this technology, this testing. So if you take since we are in the global company, we need to meet EN 13432, ASTM D6400, Australian standard. So all international needs to be, the standard needs to be met. Even these are all the products, more single use applications, more food contact, the compliance is very important. So when we choosing the formulations, we are very careful as a global company and a NASDAQ listed company. Is that okay? my answer? Okay, thank you.
You tell me your this PLA products, how far it is practically applicable for the common man if you want to replace the complete this polyethylene, polyethylene, that olefin group we are using, which is not, it is a big threat. Now government is working a lot on it. How far you can tell? Everybody cannot go for compostability, the general man. And once this polythene also, it is very costly also. That is not affordable by the people. And how you can address this issue to the environment? What way it can comply to it. I am having a doubt. Suppose a common man take this plastic at a higher rate, and it is not possible for the people to make it recyclable or compostable. Generally, it is not biodegradable fully. That compostability, how you can address this issue in the common platform?
Okay. One is that price. First question you asked me, the compared to the polyethylene.
Yeah.
Yes, these polymers are definitely prices very high. Two reasons. One is that these polymers not available in India. Most of the polymers we do import from China, Europe, US. That is the one major reason. Yes, India is working through, we know that IOCL working on the PBAT synthesis, Reliance working on the PBAT synthesis. So maybe once these companies come out, the productions in the India, definitely price will be come down, first thing. Second thing is, this is the new technology. Yes, this is not the, today if you take the polyethylene, polypropylene, last 100 years we are using this material. If you talk about these compostable polymers, last only 5-6 years we are all, everyone talking about this material. People are already started to using it. We believe that once the volumes come to that level, as like polyethylene, polypropylene, everyone should be affordable. I believe that. That is the reason I am in this industry last 18 years. In the first 8 years, we are the loss making company for first 8 years. So and then after that 8 years only, we started to break even. Today we are in the profit company. So we need more patient, definitely. But it's a very good scientifically proven product. It's not a kind of add some 2% of additive into the plastics and completely disappeared the whatever the polymers from the environment. Okay, this is scientifically proven. Whatever the carbons into the polymer reacted with if you put it in the composting site, whatever the microorganism presence, it is eaten. 90% of the carbons converted to carbon dioxide. There is no residue harmful chemicals into the environment or soil. So since that is the reason today the world towards to go for the single-use applications, this compostable as the one of the solution. I am not saying this is the solution. This is one of the solutions to manage the waste. Today our municipality cannot handle this waste because we don't have any segregation system. They don't know what to do these garbages. It's a very difficult to cleaning, recycling, everything. This is one kind of a solution. I am not saying this is the solution.
Okay, thank you.
Thank you, sir. Thanks.
Thank you, sir. And thank you so much to Mr. Nagaraj, and thanks to all of you for your kind attention. So let's wind up this session here.
So it was a nice session with industry peoples. Lot of talks were there. So thank you so much, Dr. Manas Kumar Dalai sir, for your valuable time and chairing the session and running the session very nice in a very nice manner. So now I would like to request Dr. Dalai to come on the stage, and a small token of respect from our side. It will be given by our Principal Chief Manager T. Dr. Pratap Chandra Padi sir, please. And the convener of RAMM-2023. So now we'll meet after this launch, and this exactly 2:45 will be the next sessions, and there is a very nice talk particularly on the mass spectroscopy.
Okay, so there are a couple of announcements. The participants can collect their cash receipt from the registration desk. Certificates will be provided to them after the valedictory session. It will be signed and it will be provided. So we will now proceed for the lunch, and we will assemble here by 2:40 such that we can start the session at 2:45. Okay, thanks. And all the industry delegates, they are requested to be present during the valedictory session. We will be felicitating the industries for the sponsors for their support towards organizing the conference. Thanks.
Success is not a destination. It is a journey, a path paved by continuous growth. India, the land of a billion dreams. Dreams that would make us sustainable and self-reliant. Dreams of growing together in a future-ready world. Dreams personifying Vasudhaiva Kutumbakam. The world is one family. Through a constant pursuit of innovation, at GAIL,
in 1949, we completed the first electron microscope, JEM-1. Based on a philosophy of creativity and research and development, GEOL has been committed to developing a wide range of scientific and metrology instruments and industrial and medical equipment with unmatched technologies. GEOL products are developed future for humans.
At NatureTech, we create bio-based. At NatureTech, we create bio-based and compostable solutions that enable closed-loop zero-waste systems. Goals. Zero-waste goals.
Greetings on behalf of the Supreme Industry. We at the Supreme Industry produce a broad spectrum of plastic products belonging to 8 various business verticals. Our products live up to a
Hello. Very soon we are going to start our keynote lecture by Dr. Manas Kumar Dalai. So all are requested to take their seat, volunteers. Please announce at the outside for all the participants to come into the Visvesvaraya hall. Hello. Welcome back to the post-lunch session. So in this session we are having a keynote lecture by Dr. Manas Kumar Dalai. So to chair the session I invite Professor Dr. Sushanta Banerjee. Okay, sir. So he is the Professor of Polymer Materials, Indian Institute of Technology, Kharagpur. Okay. Thanks, sir. So,
So good afternoon to one and all. Again, we are in the same forum. So it's my pleasure to introduce Dr. Manas Kumar Dalai. Dr. Dalai is a principal scientist at CSIR IIMT-Bhubaneswar. He is also a faculty of science ACSIR. Dr. Dalai obtained his MSc in physics degree from Utkal University, and then later he did his PhD from IOP Bhubaneswar. It's a very renowned physics institute. And then he moved to Germany at Augsburg for his postdoctoral work. And he was scientist from 2009 to 2017 at CSIR National Physical Laboratory, Delhi. And he was working in the field of surface and interface study of materials. He was also visiting scientist at Department of Physics, University of North Texas, USA in March to July 2023, and University of Illinois, Urbana-Champaign during 2013-14 under prestigious Indo-US Research Fellowship Program. He was member of American Physical Society during 2014 and 15. He is life member of Indian Society of Mass Spectrometry and given several invited lectures in various national and international conferences. He has broad expertise in the domain of electronic structure, transition metal oxides, surface and interface study of thin films and multilayers by photoillumination spectroscopy, X-ray absorption spectroscopy, SIM, secondary ion mass spectroscopy, chemical imaging, and depth profiling, etc. He has received several awards, and a few most important one is CSIR Raman Research Fellowship in 2022-23. He received also Outstanding Performance Award in 2018 by CSIR National Physical Laboratory in New Delhi, and Indo-US Research Fellowship Award in 2013 by Indo-US Science and Technology from New Delhi. With this introduction, I request Dr. Dalai to go through his talk.
Thank you so much, Professor Banerjee, for such a nice introduction. So, a very good afternoon to all of you. So, it's really a great privilege for me to be here in the National Conference on recent advancement in materials and manufacturing. So, I'd like to thank all the organizers, Professor Padi, principal of this institute, and all the staff members of this institute actually for giving me this as a keynote speaker. So, by looking into the theme of the conference, advanced materials, so I have designed actually this talk with some advanced topics from some of my research areas, mostly actually electron and mass spectroscopy, study of some transition metal oxides. However, by looking into the audiences and the talk I have faced today, so mostly I will be covering mostly the mass spectroscopy part. Electron spectroscopy I will cover, however actually most of the time I will take in mass spectroscopy. So I think I have 45 minutes, so I'll try to finish within that time. So, Coda? No, it's okay. You want me to move here and there? I think it's fine. Okay, so I have made this slide particularly. I thought actually students from this institute, new students from this institute will attend, so I have put some peaks of our institute, which is CSR, Institute of Minerals and Materials Technology. So you can have, it's not coming. Huh? No, only I can actually slide this. Okay, fine. So we have main building, and we have several buildings actually, departments and buildings, including our hostels, JRF hostels, and guest house, auditoriums. All these things are inside, and one of the important things, though you can find, I have mentioned here, we have a central characterization department, and having so many sophisticated equipments, almost all the sophisticated equipments like XRD, XPS, and electron microscopy, like transmission electron microscopy, scanning electron microscopy. So all these sophisticated equipments are there in our central characterization facility. So it's just a message to all the students present in this gathering. So these are my research areas. As Professor Banerjee already read my CV, so it was included. So I'll not go into this. So today I'll be talking about, I'll give you an introduction about the materials which being used for electron and mass spectroscopy study, and this important spectroscopic techniques, photoemission spectroscopy, X-ray absorption spectroscopy, and mass spectroscopy, which is particularly time of flight mass spectroscopy. And then I will conclude the topic. So this is some extra slide I have made just to highlight one of my research area, but thus this is not related to the title of my talk. This is superconductivity. So I also worked in superconductivity. You must have heard about in 2018. So there was a news from IISc, Indian Institute of Science, Bangalore group, the ambient condition superconductivity found in gold and silver structures. It's a silver nanoparticles embedded in a gold matrix. So however, their process was actually chemical process, but we tried to actually develop such superconductivity in that silver and gold composition. However, we didn't get ambient condition. Ambient condition is very tough, but however, we got at 2 Kelvin. It's a low temperature. However, 2 Kelvin in that silver gold system, and using our physical procedure, which is ion implantation method, it's huge. And this is the first publication worldwide, which was published in Physica B. And we got the transition temperature at 2 Kelvin in AG implanted AU. And this is the first report of superconductor in AG implanted AU thin films. So, as I told, I'll be talking about the transition metal oxide and their electronic structure and their surface and interfaces using time of flight, secondary and mass spectroscopy. So we know actually some of them also in the morning actually there was some Fe2O4 and iron oxide was there now. So iron is a transition metal. So this topic is mainly actually based on the transition metal oxide materials, and transition metal oxide have tremendous application in all fields, whether it is electronic application or magnetic application. So any type of properties you can, as he was telling in the morning, Mr. Panda from Ravensa, so exploration of multifunctionality. So this is the multifunctionality behavior of transition metal oxides. So because the when we are talking about transition metal oxides is related to transition metal or D block element. Okay. So in this type of materials, D block elements, the electrons lies in D blocks or D orbitals, they plays very important role. How to actually tune, how to change their properties. If you are talking about electronic properties means it is metal or insulator or semiconductor, or metal insulator transition in a single materials with application of any external stimuli, whether it is photon or any electron, or you have temperature, pressure, etc. Okay, so main important factor actually here to tune the physical properties, electrons present in d orbitals. So these are the some examples where actually it can be used, transition metal oxides where they can be used. So they are having superconductivity and magnetoresistivity properties, and dielectric, piezoelectric, biomedical applications, optoelectronic devices, solar cells, everywhere we have this scope to apply transition metal oxides in many fields. So, okay. So this is one of the transition metal oxides, which is manganese oxide, manganites. In manganites, manganese is the transition metal, and there the electronically active orbitals are d orbitals. Okay. So when we are talking about manganites, these are basically actually perovskite type of crystal structure. I have not put here the crystal structure. Perovskite means AbO3 type structure. Okay. And the thing is, and my aim is to study the electronic structure. Electronic structure means how your electrons are actually oriented in your materials, or particularly in the orbital or energy levels, how electrons are getting oriented. So that is the aim of the study. So we have actually manganites. This is a mixed valence manganites. The parents compound, you see, this is one of the example, lanthanum strontium manganese oxide. If you will not dope, either it will be lanthanum manganese oxide, LaMnO3, or strontium manganese oxide. So these are two contemporary manganites. One is having Mn3 plus charge state, other one is having Mn4 plus charge state. In Mn3 plus charge state, we have 4 electrons in d orbitals. And in Mn4 plus, there are only 3 electrons in d orbitals. So these d orbitals here, actually the pointer is not pointing because this is LED, na? So we can't spot it. It's fine, but you can see. So this is the splitting. We have 3 d orbitals here in manganites. If you have LaMnO3, the parent compound, we have 4 electrons. इसको power connection देखो ना हाँ हाँ सी आप लोग माइक के नीचे कर चौड़ी वाला जो प्लेट है नो प्रॉब्लम सी जो आप लोग करने नहीं सी माइक नहीं बात बुझी केवल यही चित्र में होता है मैं बेसिक जिनिस तो पूरी
ଦରକାର ମାଇକ୍
ନାଇଁ ଇଟ୍ସ ଓକେ ନୋ ପ୍ରୋବ୍ଲେମ୍ ମାଇକ୍ କାହିଁ ଶୁଭୁନି କି ମୋର କଥା
ନାଇଁ ଏଇଟା ଲଗେଇଦେଲେ
କାହିଁକି ଠିକ୍ ଅଛି ଏଇଠି ରହିଲା ବେଳକୁ ସିଟି ଗଲା ବେଳକୁ ଶୁଭୁନି ଶୁଭୁଛି ଯେ ହଁ so if I move there without mic is it okay na so am I audible so no problem okay Hello? Howji? Hello? हाँ नहीं तो पूरा काई करूँ जो मुझे तो कौची हो है हे shit था वो हेलो हौजी ठीक है इधर नौकरी की कोई ना पायलट को था वाला हाँ Okay, yeah, so it's okay. So as I said, LMNO3 and strontium manganese oxide, these are two parents compound. One is having 4 electrons in their d orbitals and other one is 3 electrons in their d orbitals. These are two. So the electronic structure actually I will not go into detail, but it's somehow actually it's understandable. You can think actually. So this is because of crystal field splitting, these are splitted into T2G and EG states. These are actually related to the d orbitals. And since 4 electrons, we have 3 electrons in T2G states and 1 electron in EG states. And the other parent compound is strontium manganese oxide. As I said, there are only 3 electrons and they will occupy the T2G states and EG states are empty. So we will study actually such type of states in the manganese oxide system, where by using photoemission spectroscopy. And you see why these materials manganese oxides are important, because of their actually one of the very interesting properties, which is colossal magnetoresistance behavior. Colossal magnetoresistance behavior means the change of magnetoresistance means change of magnetoresistance with application with variation of magnetic field. If you apply magnetic field, the resistivity of the material changes. And why it is called colossal? Because the resistivity actually changes a huge with application of magnetic field. And this is one of the example from Tokura of this Japanese scientist, and this is one of the example of lanthanum strontium manganese oxide. You can see how with increase of magnetic field the resistivity decreases, and also with that the transition temperature also moving towards higher temperature. So why it is so? And these type of materials mainly at low temperature they are ferromagnetic metal, and at higher temperature they are paramagnetic insulators. Why it is so? So the thing is, so anything, if we have metal or insulator or semiconductor, we know metal insulator, how to categorize metal insulator, semiconductor, and we with band theory or band diagram. If you have conduction band and valence band, when valence band and conduction band they overlap each other, that is metallic case, then electron can mobile easily from valency to conduction band to make the materials metallic. And if you have a big gap, then it's certainly difficult to hop electrons from valence band to conduction band. So there is no mobile of electrons in insulating materials, and the semiconductor such materials, their band gaps are in between metals and insulator. So how to understand what is happening? So there are so many theories or mechanisms are there to understand the metal insulator transition in this material. And when we are talking about the mechanism, one of the important mechanism is double exchange model, and it says about the electron spin. So how to actually electron hop from one atom to other atom inside your materials, on one charge state to other charge state inside your materials. So he described in double exchange model Digens, the hopping of electrons from one charge to other charge state, Mn3 plus to Mn4 plus state via oxygen. So as I said, this is manganese oxide. This is the hybridization between manganese and oxygen. Manganese 3D and O2P. So they are hybridized, and electron hops from manganese 3D state to manganese 3 plus state to manganese 4 plus state. So this is the concept of ferromagnetism. If you have ferromagnetism nature, ferromagnetic means you have parallel spins. Okay, both the spins are parallel. If parallel, then electron can hop from one charge to other charge state easily, and because I have this actually formula, you can see Tij is equal to T cos theta Ij. Somewhere it is written, yeah, this one, T cos theta Ij, and theta is the angle between two neighboring spins. So if it is parallel spins, you have 0 degree. Okay, theta is 0. So you have cos 0 is 1, and the hopping probability T is maximum. So ferromagnetism in case of parallel spin or ferromagnetism favors the metallic behavior in such materials, and in case of antiferromagnetic the hopping cancel because 180 degree parallel spin means it is 180 degree and cos 180 degree it cancels. So antiferromagnetism does not favor the metallic behavior in such materials. So, but always actually it does not satisfy. Sometimes actually the experimental data in case of paramagnetic metallic behavior, it doesn't satisfy actually, this doesn't double exchange model. So then other things actually, polar and electron trapping and polarionic states and phase separation states, these are coming into picture. I will not go into detail. So to understand the metal insulator transition in such materials. However, when you are actually studying, you are talking about electronic structure means you can probe the electronic structure, their exact orientation, exact densities of electrons, density of states using photoelectron spectroscopy. Photoelectron spectroscopy, there are actually so many spectroscopy I generally do for electronic structures study. Photoemission means ultraviolet photoemission or X-ray photoemission or inverse photoemission. On another electron spectroscopy is X-ray absorption spectroscopy. So this is one of the important state-of-art technique which is photoemission spectroscopy, where we can exactly probe the electronic states in your materials, from where your electrons is coming out. The only thing is the resolution issue. If you have a very good energy resolution, you can find out near the Fermi level in milli-electron volt energy ranges. Okay, and this photoemission spectroscopy is based on the principle of photoelectric effect. And so I think you all must be actually aware about photoemission spectroscopy in our 12th class. So it was there, photoelectric effect, when we apply a photon, a light, so it excites electrons which are called photoelectrons, and when photoelectrons are coming out of your materials, electrons having that kinetic energy. And the main interest is actually we are getting electrons. So electrons having kinetic energy. The thing is we have to think actually that electrons from where it is coming out. So that means it was somewhere inside the atom or inside the materials, so which was having certain binding energy. So we have Einstein photoelectric equation. This one, okay, this one is the Einstein photoelectric equation, and we have the known energy, photon energy, whether you use ultraviolet light or X-ray, then kinetic energy we will measure. Kinetic energy we can measure easily with our detector. Kinetic energy is half mv square, simple. The mass of electron we know and the velocity which actually it is moving. So we have the kinetic energy, and the work function is the work function of the metals. But when we are doing experiments, so when we are attaching the sample, it is just connecting overall instrument. So that's why we consider the work function. It's not the work function of the materials alone, it is the work function of the whole instrument. Okay. So we can derive here the binding energy by using this Einstein photoelectric equation. From this, so you can see this is the schematic of photoelectric effect, and this is the band diagram. You can eject electrons from your materials. If you are interested in valence band electrons you understand the outermost electrons, they are loosely bound. Their outermost electrons, they are loosely bound, so we need less energy. So that's why we use ultraviolet light to excite the valence band electrons. But if you are interested in core levels or deeper energy levels, you can use the X-ray, high energy X-ray to excite core level electrons. So this is the sample I will be talking about, but I will not go into details of the phase diagram, how their physical properties. This is samarium, calcium, strontium, manganese oxide. So these are several phases, structural phases as well as electronic phases, like ferromagnetism is there, antiferromagnetism is there. So I will not go into details. These are the some experimental parameters. How the valence band photoemission looks like, you can see. This is the valence band near the Fermi level. So in manganese, these are the A, B, C, D are the main features. Because of the manganese 3D orbitals, we have EG states, T2G states, and these states, particularly valence band, is the mainly comes from the hybridization of Mn3D and O2p orbitals in this manganese oxide system. But when we are talking about metal insulator transition, other material is metal or insulator or semiconductor, so mainly this, the electron, the states near the Fermi level is 0. So they actually play very important role actually to make the materials, whether it is insulating or metallic. So you have this high resolution data near the Fermi level. You can see actually this is the data actually it's doping dependent. For a different value of X strontium, you have SC, SA, the strontium S value actually we have varies here. And this is the data taken at 50 Kelvin and 100 Kelvin. It's almost similar. Actually, there is not much difference. And you can see maximum density of states at 0 when strontium is 0. You have the black picture. It is this is the maximum density of states, and with increasing it decreases. That is because the thing is actually if you, in the bulk, if you will see, these are antiferromagnetic insulating materials. However, we are getting some density of finite density of states at the Fermi level. But as I said, photoemission is such a sophisticated technique. It can give the very finer changes in your material system. And you have heard about the current discoveries of advanced materials. One of the advanced material which is topological insulator. Topological insulators are recent discoveries, and they are very one of the promising reagent towards the quantum computation application. This topological insulator only discovered by using this photoemission spectroscopy, angle dissolved photoemission spectroscopy. Topological insulator, they are in the bulk actually they are insulator. However, in the surface they have actually very linear states. At the surface actually they show metallic behavior. So in other technique it's very, but after actually discovery by using photoemission spectroscopy, there are some other techniques are being used to correlate, but this is one of the first technique which got the idea about the topological insulator behavior in some chalcogenides. So as I said, so this is somehow we are getting some finite states in these materials. Even in the antiferromagnetic insulating, but when we are doing some neutron diffraction or other sophisticated analysis, we found there are some fluctuations, ferromagnetic metallic fluctuations inside the antiferromagnetic insulating background. So though because of that actually ferromagnetic metallic fluctuation, we are getting such limited finite density of states, and this type of behavior particularly we call this a CG behavior, cluster glass. Magnetic cluster glass ferromagnetic fluctuation in antiferromagnetic insulating matrix, or ferromagnetic metallic behavior fluctuation in antiferromagnetic insulating matrix. So these cluster glass behavior are very important. So even these small metallic things can be applied in many sectors, and this is one of the finding here, and this is called pseudo gap kind of pseudo gap type of states, pseudo gap behavior in this. So why this this is a bit advanced. So the basic concept is when in one materials we are getting actually it's a half metallic nature. In one temperature it is metallic, and when with other temperature it is insulating, or with magnetic field it's metallic, or by removing magnetic field it is insulating. So this type of things can be used even in the your logic gate kind of things when we are talking about 1 or 0 flip-flop kind of things. So this type of things can be applied. But somehow this pseudo gap behavior, firstly actually we have reported in the samarium calcium strontium manganese oxide, and when we are at higher temperatures we are comparing, we have almost on the similar like metallic states, we have a high density of states, you can see the structure is bit different, and the paramagnetic metallic behavior, because of the paramagnetic metallic behavior we have actually finite density of states. I will not go into detail. Okay, so this is, I'll leave this slide. So as I said, my title of the talk is electron spectroscopy. So some of the spectroscopy, electron spectroscopy I said about this photoemission spectroscopy, another one is X-ray absorption spectroscopy. Photoemission spectroscopy I said one has to remove electrons from the occupied states below the Fermi level, means those states are occupied, occupied with electrons, then we can remove electrons from that state. But in X-ray absorption spectroscopy what we do, we tune the unoccupied states, because this is above the Fermi level, below the Fermi level we have occupied states and the electrons are occupied. What we do, we have to exactly tune the X-ray so that the core level electrons can be excited and sit into the exact place of that unoccupied states. Where actually means which states, unoccupied states you are interested to study. So that is the concept of X-ray absorption spectroscopy. So you can, these are the states, suppose you have 1s states, 1s to 2p, the transition is, you can make electron transition 1s occupied state to 2p unoccupied states, or 2p transition, 2p states to 3d transition. So all these things can be done using X-ray absorption spectroscopy, and there are particularly when we are talking about X-ray absorption spectroscopy, that is actually for unoccupied states. Okay, clear. So there are actually two kinds of things, GENS or EXABS, X-ray absorption near-edge structure or extended X-ray absorption fine structure. For crystal structure, crystal orientation, all these things we have high energy, means high range EXABS, and for GENS only the unoccupied states or electronic structure we study just near the Fermi level. So the thing is, now we have two things from electron spectroscopy. One is photoemission spectroscopy, other one is X-ray absorption spectroscopy. One is occupied, other one is unoccupied. So when we will combine occupied and unoccupied, then we have overall information about, and Fermi level is in between, and then above it is unoccupied states, which is conduction band, then below we have valence band structure occupied. So we have a detailed study of electronic structure across your Fermi level. So as I said, these are the transition can be possible since we have manganese oxide, we can do whether manganese 2p absorption or oxygen 1s absorption, in oxygen 1s absorption. So these are the things, transition can happen, electron can transit from 1s to 2p orbitals. So we have different states like Eg, T2G, as I said in the schematic of electronic structure. So let's combine. So this is the combination of photoemission and X-ray absorption data, and we have charge state Mn3 plus and Mn4 plus. There is a charge transfer energy for if you have electron transfer from one charge to other state. So we need some charge transfer energy. So we have deducted the charge transfer energy for this system, PR calcium manganese oxide having concentration calcium 33%. So by combining this, we have deducted the charge transfer energy. So this is quite built, means old data. It was published in 2006. So I thought I should actually show this comparison. Okay, so we have deducted the charge transfer energy by using photoemission and X-ray absorption spectroscopy. So these are, I think I'll not go into this slide. So how much time I have? Oh, I have another 15 minutes. Huh? Okay, yeah. So yeah, at least I have covered 50%. At least electronic structure using electron spectroscopy technique, and the main thing is, and this technique particularly, maybe the electron spectroscopy, some of you may not have actually acquainted with the topic, but this secondary ion mass spectroscopy is very much applicable to all fields of people, whether it is you are physicist or chemist or a biologist, so everywhere actually one can use secondary ion mass spectroscopies, and particularly this spectroscopy when I was in National Physical Laboratory, so I was using this SIMS technique to analyze the surface and interface of the materials. Those SIMS, what is this? So this is one of the mass spectroscopy technique. So why we are calling this secondary ion mass spectroscopy? Because here we are using a primary ion beam to excite secondary ions. Okay. So using the primary ion beams and excite the secondary ions, whether it is positive ions or negative ions, and by analyzing those secondary ions, we can determine actually what are the elements or molecules or isotopes present in your materials. So this technique is particularly actually for the compositional analysis of the materials. This is one of the powerful technique among any analytical techniques, and the sensitivity, means detection limit, is very high, of the order of ppb, parts per billion, you can imagine. So, and using this, the SIMS I will be talking, time of flight SIMS, where one can actually analyze whole periodic table starting from hydrogen, and there are very rare techniques where you can detect hydrogen, but this is the technique where you can detect hydrogen. Okay. And so any bigger molecules also, organic, inorganic, small molecules you can, but organic, in your case, if you polymer people, so big molecules are there, organic molecules, and that can be detected very easily, because this is very high mass resolution and high spatial resolution and high depth resolution. So in this particular technique, we have three types of analysis. Simple mass spectroscopy, where you can identify your composition, means the elements, molecules or isotopes present in your materials, and you can visualize even how they are getting distributed, the elemental distribution, how they are, some speaker was talking about actually the elemental distribution in the morning. So that distribution can easily, even not only in two-dimensional, in three-dimensionally also, you can visualize how your elements or molecules getting distributed over your sample. So this is very important technique in the material science. I will not go into the history, but it was first used in studying the moon rocks kind of stops. So there are actually three types of SIMS. Three types means depending on their analyzer, because we use any equipment, there are various types of analyzer, but here also three types of analyzer. One is magnetic sector mass spectrometer, another one is quadruple mass analyzer, and the third one is time of flight mass analyzer. Mostly actually I have been working in time of flight mass analyzer, because this high mass resolution, high spatial resolution and high depth resolution. So how it works in time of flight mass spectroscopy, how it works. So in time of, when we are talking about time of flight, you understand time of flight means it's flying. Something is flying with time. So means the ions, here since we are talking about secondary ions, then so we have to actually measure the flying time. So how? So we have different masses, atomic masses or molecular masses. So having different masses, whether it is lighter or heavier. So accordingly, we will analyze the lighter mass will reach faster than the heavier mass. That is the concept of time of flight. So we use that actually concept, heavy or light elements or molecules which are flying inside the time of flight tube. By using that, we can analyze. So this is the mathematical principle, and finally we will find. So it depends on the mass. If it is lighter mass and time is less, if it is heavier mass, time is more. So I'll not go into detail. So I'll not go into detail also all these instrument. So how actually this time of flight looks like. You can see this time of flight seems when I was working in NPL. So this is the machine and this is the schematic of that equipment. Exactly it looks like same. So we have a primary ion gun. So this is the primary ion gun we are using here. This is a pulsed ion beam. Since it is time of flight type analyzer, we have here pulsed ion beam. So the next pulse actually does not come from the source, primary source, till the secondary ions which are getting out of your materials is not clear in your time of flight tube. Otherwise there will be some collision kind of thing. So that is the concept behind this pulsed beam we are using in time of flight sims. And as I said, actually there are 3 types of modes in analyzing the data. We have surface spectroscopy, depth profiling, and chemical imaging. So surface spectroscopy is simple. You just get, when you are getting the secondary ions, we know the atomic masses or molecular masses. So at their respective masses, m by z value, mass to charge ratio we are detecting here. So in their respective mass to charge ratio values, we will get the peak. Suppose if you have carbon or hydrogen, all these things in their respective atomic masses value, you will get the peak. So you know the atomic mass of, okay. So atomic mass of carbon. So anybody can say the atomic mass of carbon, students. So, okay, 12. So at 12 AMU, atomic mass unit value, you will get your carbon peak. So the thing is, hydrogen is 1. So as I said, this is one of the rarest technique where one can identify the hydrogen. And our detection limit in tough sims is ppb, of the order of ppb, parts per billion. It's very sensitive technique. And when we are talking about mass spectroscopy, mass resolution is very important, and I will not explain detail about mass resolution. And the thing is, up to order of 5 decimal even, we can actually resolve. So this is one of the example. Silicon hydride, silicon 28 and hydrogen 1, 29 and silicon 29 is there. If your mass resolution is not good, you can't actually resolve these 2 peaks. Okay, so if you have poor resolution, then both actually these peaks will come and give a single peak, broader peak. You can't say whether we have silicon hydride or silicon 29. So that is the importance of actually resolution, where we get actually very high mass resolution here. And this is one of the example of our data diamond like carbon. You can see actually in their respective atomic mass units, you have different structures, carbon, nitrogen, silicon, etc. And chemical imaging, another technique is chemical imaging. Chemical imaging means to visualize, anything to visualize. And our technique is to study the composition of the materials. And we can visualize how our elements or molecules present in our materials, how they are actually distributed over the surface. So that is the concept of imaging. So one can actually visualize using chemical imaging analysis. Okay, so this is some forensic actually data. It's not my data. I have taken from this website, IPT-Bhubaneswar. So if there are some fraudulence in signature, somebody is putting sign on paper and another person is putting some, suppose there are some white kind of the things they are putting, and over that, if there are some actually fraudulence you find, or if you have some you see actually there, then you can actually detect using this imaging spectroscopy, and you can see actually how the signature overlay, and by 2 color overlay method you can have an idea about whether it is. So this is another actually to check the homogeneity of elemental distribution. So I'll not go into details. And I'll show directly depth profile. Depth profiling is to see how your elements or molecules are getting distributed with respect to depth, from the surface to how much depth you are interested, and inside the inside your surface or interfaces, how your elements or molecules are getting distributed. You can analyze out of this. So I'll give one example, and in depth profile, depth resolution is very important, and in top sims we are having actually now 0.5 nanometer of depth resolution. So this is one of the data actually. This is a multi-layer structure. You can see these 4 fingers. You think actually each fingers are one layer each, and these are multi-layer structure. And at the interface, how they are varying, how they are getting diffused across the interface. The layer diffusion is there, or the sharp interface kind of things you can see by using this. And this is the depth profile data. You can see blue and red alternative layers are there. This blue layer, then red, all these things. So this is gallium nitride, aluminum nitride multi-layer structure, and this blue is gallium nitride layer, and after that aluminum nitride peak is coming, then gallium nitride. These are alternate layers of gallium nitride and aluminum nitride structure. So you can see very sharp interface, and you can visualize by using depth profile analysis. And when we do seams, then there we get generally a crater well-like structure after actually doing this sputtering. So once you measure that crater depth and fit that value into your time scale data, you have the depth scale, and you can measure each and individual layer thickness, and their how much depth, their interfacial diffusion, etc. All these things can be measured, but I will not go into detail. Then 3-dimensional, actually it's the combination of 2-dimensional imaging and depth profiling. If you combine, then you have a 3D visualization. Certainly when we are talking about some nanomaterials, thin films, but you can see only over the surface, but you can't see their intricacies actually, how their elements particularly they are getting distributed or molecule distributed. So it's very difficult. So when you are doing actually such type of analysis, 3D visualization, you can see how this looking like. And we have separated out the gallium nitride, as I said in the depth profile data, and aluminum, these thin sheets of aluminum nitride and gallium nitride. When we combine, you can see the total structure, and your multi-layer structure looks like this gallium nitride, aluminum nitride, like this actually they have oriented. So this is one of the very important technique to analyze or to visualize the samples which you are preparing for your study, or for making any device, or for any industrial applications. Okay, so I almost covered about the basics of time of flight secondary and mass spectrometry. I think the time is over, so I'll stop here. I'll not go. There are many things actually to say about, but I'll not. So I think I almost covered about the electron spectroscopy and mass spectroscopy for transition metal oxides. Thank you all for your kind attention. So this is the summary actually. I covered electron and mass spectroscopy. Ashwini? Another page didn't come. Okay. Thank you, sir.
Hello. Thank you, sir, for your nice presentation. Sir, I have one simple question. We all read about Fermi energy. So Fermi actually, nuclear scientist, according to the Fermi Dirac statistics is there. So statistical mechanics, but Fermi energy, we understood that semiconductors are having band gap. So highest occupied energy is called as Fermi energy. Whether that is temperature dependent or Fermi energy?
Yes, temperature dependent actually. If you have Fermi level, In semiconductor, if you will talk about semiconductor, you have actually different donor label, acceptor labels, and Fermi label accordingly actually Fermi label actually shifts. If you N-type or P-type semiconductors.
But Fermi energy is fixed for a particular semiconductor.
So since you are talking about Fermi Dirac distribution, you know that curve, Fermi how Fermi function actually varies with the temperature. And there is absolute zero actually, there is a step function like, and with temperature actually how they are varies. So you know that. So and when we are talking about band theory and metallic or insulating or semiconductor, accordingly actually we have band gap. And metallic case actually both valence band and conduction band actually overlap.
Thank you.
Okay, thank you. I think really there is shortage of time already. It is delayed, I think. Not for your talk, but session already is delayed. I believe you have to finished it in right time. So let us thank to Dr. Dalai once again.
Thank you.
Thanks, Dr. Manas Kumar Dalai, and also our thanks to Professor Dr. Sushanta Banerjee. Now I invite Professor Dr. Sushant Banerjee over the dais to present a memento to Dr. Manas Kumar Dalai. Thank you, sir. Sir, please here, sir. One more. So now I request Dr. A.K. Chobe, sir, from CSIR IMT-Bhubaneswar. He is the senior principal scientist there, to present a memento to Professor Dr. Sushant Banerjee. Dr. A.K. Chobe is also the member of Advisor Committee RAMM-2023. Thank you, sir. So now we will have our parallel sessions. So manufacturing parallel session will be in the second floor conference room. Okay. Those who are interested for manufacturing theme parallel session may please proceed to the second floor conference room. Our volunteers will guide you. Here we will have the session on materials theme. Hello. So to chair the session on materials, now I invite Dr. Bankim Chandra Tripathi. He is presently the chief scientist at CSIR IMT. He has over 25 years of research experience in minerals, materials and metals. He is involved in various research activities pertaining to recycling of industrial wastes. He has guided more than 10 students for their PhD degree, 4 postdoctoral researcher, and to his credit he is having over 120 research publications. He has also 4 national and 2 international patents. He has been to Australia, Canada, Mexico and South Africa on various research assignments. One of his technologies on alum from aluminum DOS residue has been commercialized at 20 ton per day alum product. He has received National Societal Innovation Award by NRDC, that is National Research Development Corporation, New Delhi. He has also received Sir C.V. Raman Fellowship and worked as visiting professor at Materials Engineering Department of University of British Columbia at Vancouver, Canada. With this short profile of a very prominent scientist, I invite him to the dais to chair the session. Sir, please.
So, good afternoon everyone. Hope you are not sleeping. Okay. Because the lunch was so delicious, I was feeling sleepy. Okay. So, hope you are not sleeping. We have a very good session now. But first of all, let me thank CIPET for giving me this opportunity. And this is a very apt conference for the present day need. Because the world is going through a lot of turmoil on industrial waste, and we have to have recycling as one of the big aspect of the any conference. Now you will see whenever you go to any conference, you will see recycling is a big issue, and many publications or papers will be there on recycling. Okay, but here remanufacturing is another point which caters to the need of the recycling, because unless and until we have remanufacturing, we can't reuse it. Okay, so I saw that this conference having materials and manufacturing is a very good topic what they have chosen, and it's a right kind of issue solving problem that has come to the common people. So let us see, there are actually 6 presentations in the afternoon, and I wish all the presenters will do their best, and they will restrict to their presentation up to 10 minutes, and we'll be having 1 or 2 minutes discussion session with some question and answers. So I will request Dr. Biju Kanti Mandal to start his presentation. So, Dr. Mandal, please.
A very good afternoon to all. Today my topic is effect of alkali treatment on mechanical, thermal and biodegradability behavior of the polylactic acid bamboo fiber green composites. Why we have chosen this area? Because now the recycling is nowadays the biggest solution for particularly for polyolefin materials, and if we think about biodegradability, another very good area for bioplastic material, bio-based material, biocompostable material, polylactic acid is play a very vital role. Polyhydroxybutyrate, which is called the biopolymer or biopol shortly, that will play a very vital role in our daily life. Lots of polyolefin materials we are using, particularly for commodity plastics, particularly for engineering material, particularly for specialty polymers. We are using in our day-to-day life a wide application due to their wide application area, particularly in the packaging sector, particularly in the automobile sector, particularly in the aerospace industry. If we think for specialty polymer, aerospace industry is the biggest application for specialty polymers. But problem is that, where is the problem? Problem is that the biodegradability, particularly for polyolefin material, particularly for commodity plastics, when we are throwing in environment, the soil pollution will occur. The soil pollution, I mean environment pollution can be created by this material, commodity plastics. So my talk is about polylactic acid bamboo fiber green composites. So this is my topic content, introduction, problems of polyolefin, green composite and its advantages, objective of the work, material, methods of synthesis, characterization, result and discussion, and finally conclusions. So these are the, so green plastic, when we talk about the green plastics, particularly for biodegradability, because the polyolefin materials are non-biodegradable, particularly for packaging sector. Lots of 40% plastic material goes into the packaging field, but when we are throwing in the environment, it is not biodegradable. So considering this view, so for packaging, particularly for agricultural sector, cutlery items, particularly for this item, these are not biodegradable if we made by polyolefin material, but in certain percentage of the natural fiber, if we incorporate into the polylactic acid, I mean PLA bioplastics, it may degrade under certain condition. So that is my theme. So green plastics play a very vital role. You know, the various types of composites are there. Metal matrix composites, ceramic matrix composites, polymer matrix composite, and fiber reinforced composite. I have taken as a fiber reinforced composite, where polylactic is the matrix and fiber is the reinforcement. Various percentage of the fiber I have incorporated by treated and untreated alkali. So I have seen effect of alkali. I will show you the data. So composite is basically matrix and the reinforcement. This is the combination. So polylactic acid here as a matrix, and reinforcement part is the fiber, that is called the bamboo fiber. Because why we have chosen, it has no hazardous problem, sustainable and eco-friendly, low density, green composites are biocompostable, suitable for the application in the field of packaging and agricultural, lightweight, corrosion resistance, and design flexibility is there, and overall it is environmental friendly and non-toxic, biodegradable nature, also cheap. That's why I have chosen this green composite for making these green composites. So this is the objective by thinking this. This is the objective of my work, to synthesize eco-friendly biodegradable composite material made from PLA and bamboo, reduce soil pollution from polyolefin based composite, to prepare lightweight, cost effective. This very term is very important. Polylactic acid cost is very high. Somehow if we incorporate certain percentage of the fibery material under suitable condition, under treatment condition, it may be cost effective. That's why I have incorporated into the fiber material into the polylactic acid matrix to improve the thermal stability of the composite and to develop the eco-friendly biodegradable composite material suitable for the application in agricultural and food packaging industries. So these are the material composition and material data. Density 1.25 gram per cc, MFI, melting point 160 to 170 Tg, 58 to 62, and bamboo fiber on the other hand contains some cellulose, hemicellulose, lignin. These are the material. And surface treatment before going to incorporation of this material, I have taken the bamboo fiber strip, washing, cleaning, and removing the dust from the fiber, 2 hours treatment with the 5% sodium hydroxide solution at 60 to 80 degrees centigrade, and finally wash and dry it. And NO's addition enhance the ductility and of the brittle composite. These are the best composition of my composite. Virgin PLA 100% untreated, U5 mean 5% bamboo dust I am using, along with the 10% castor oil in all cases, untreated 10%, treated 5% and treated 10%. This is the best composition of my composite material. Synthesis of the composite, PLA and bamboo fiber treated and untreated, manually mixed with the, along with the castor oil, which helps in the processability of the composite material, extruded into narrow stand, passes through the cold water, cutting into a smaller chips, compression molding, then mold sheet is ejected, and finally sample prepared as per a standard for characterization.
So this is the flow chart for making the composite material. These are the characterization technique, mechanical characterization done by tensile, specific gravity, thermogravimetric analysis, and differential scanning calorimetry and also biodegradability by soil burial test. So mechanical test data shows that the PLA shows the more strength in compared to PLA fiber reinforced composite material. But if we see the 5% treated and untreated, the 5% treated shows the more strength in compared to untreated fiber, because the bamboo fibers uniformly disperse into the PLA matrix to improve the interfacial adhesion as the lignin is removed from the fiber by alkali treatment. So this is the density test shows that the density virgin PLA to untreated treated fiber gradually increases, and due to the compactness and compatibility is the phenomena by which is enhanced the density also, and fiber treated fiber reinforced composite shows more density than untreated fiber. And you see the data, the density is gradually increases by the incorporation of the fiber material. So DSC studies shows that the melting point of the PLA is 170.73 degrees centigrade, whereas the incorporation of the bamboo fiber 5%, it come down to 156.35. But again, treated fiber, it shows more, 159.73 degrees centigrade, somehow more in compared to untreated fiber. So this behavior also contradictory behavior, more studies required for these cases. If we see the thermogravimetric analysis, first is the PLA curve, 50% degradation occur at 43.36 degrees centigrade, whereas the second PLA plus 5% bamboo dust, 347.65 degrees centigrade increases the thermal stability, and whereas in case of treated bamboo fiber, it is 355.24 degrees centigrade. Alternatively, we can say that by the incorporation of the bamboo fiber, the treated and untreated and also PLA, if we compare, the thermal stability gradually increases by the incorporation of the bamboo fiber, but treated fiber shows more onset degradation of temperature, that means thermal stability of the more in compared to untreated and PLA. And this is the last for soil burial test. If you see the number of months for the weight deduction, the virgin PLA, untreated and treated fiber, the treated fiber shows the more degradability behavior with the increasing of time, means months, week, gradually under biocompostable condition. That is my objective, to make the polymer biodegradable. So soil burial is one of the tests, and other tests also there for taking 6 to 8 months time for making fully biodegradable. But this is the one of the easiest test, where under composting condition I have put and I have checked weight loss of the material. So I have seen that the treated fiber undergoes more susceptible to biodegradation at faster rate in compared to untreated and as well as virgin PLA. With this, I conclude my seminar, improvement in ultimate tensile strength of the treated fiber reinforced PLA composite, overall thermal stability behavior of the PLA bamboo fiber reinforced composite, alkali treated bamboo fiber composite shows more tensile strength when compared to untreated fiber, and biodegradability of the treated bamboo reinforced composite is more when untreated fiber. These are the my project students, they are doing work. Thanks to CIPET, IPT-Bhubaneswar testing department, whole team for doing some test this laboratory. With this, thanks to all.
Thank you, Dr. Mandal.
If
Nicely
any
presented and timely presented. So thank you so much. Any question from audience side? Limit to one question. We can discuss it later during high tea.
Sir, so far this polylactic acid we are claiming as compostable material.
Polylactic acid.
Yes,
Yeah.
PLA. So what is the major difference? What is the compostable and biodegradable? The basic difference.
Biodegradable means directly, when suppose if you take some paper, some cellulosic matrix, microorganism directly attack due to presence of some functional group is a very important factor. Cellulose content, suppose a paper, if you throw in soil, it will degrade immediately. Because it contains some hydroxyl group where microorganism attack and destroy. That is biodegradable. But PLA is not biodegradable under that condition. Under certain condition, under composting condition, and means some soil with some compost, it will mix, and 70-30 ratio will get the better result. Under that condition, we are putting the sample, and we have checked after 15 days, 1 month weight test. So under some temperature, under some moisture condition, certain condition, that biocompostable will be done. Biodegradable means microorganism directly attack and it will destroy in soil.
Without any conditions. Okay.
Thank you, Dr.
Thank you,
Mandal.
sir.
Very nicely said.
Okay, thank you all.
Let us give him a big round of applause. One more question. Okay, one more question.
Hello. Sir, this treated fiber and untreated fiber.
Yeah.
So in all the properties, treated fiber giving more. So what is actually happened?
Actually, when you are treated some alkali, some fiber, the fiber structure, the modification, when your lignin will leach out into the fiber system. So more interfacial adhesion will take place. That's why polymer to fiber interfacial adhesion will take place. That's why properties improvement more. I think if we need more improvement properties, some coupling agent and compatibilizer, if we add into the system, it will increase more and more. So that will play a very vital role for the case of natural fiber reinforced composite system.
Very good.
Super, sir. Thank you.
Okay, thank you.
So now you can see how important is the project now. So thank you, Dr. Mandal.
Okay,
let's go for the second presentation by Mr. Ravindra Reddy. Is it there? Okay. So please stick to 10 minutes. Okay. Just show the salient features.
Hello. Good afternoon. My topic is design and development of pylon foot bolt adapter using epoxy glass fiber composite for application in transtibial prosthetics. Okay. This is the transtibial prosthetics is the artificial limbs. It is a part of artificial limbs. So in that, one of the part we have taken for replacing with some polymeric material. Actually, it is a aluminum material was there. It is getting frequent problems. So we have studied problems, and we have suggested some of the polymeric material as an alternative for replacing that. Okay. So these are the contents. So prosthesis, generally prosthesis is the artificial devices, artificial parts which is used to replace the missing part of the body. Okay. So here there are mainly external parts and external body parts and internal body parts. Two types are there. Both the things can be replaced with the prosthesis. Generally limbs, ears, nose, external parts of the body and other internal parts like hearts, lungs also can be replaced with the prosthesis. Here in this study we have concentrated only on limb prosthesis. That limb prosthesis also again divided into two, arms and legs. We have, and in arms also two types are there, and legs also two types are there. We have concentrated only on the legs transtibial, that is the part which is below the knee. Okay. In transtibial processes, we have taken one of the part, it is pylon foot bolt adapter. Okay, this work only focused on the one of the part which is made in aluminum. It is replaced with the polymeric material to get better mechanical properties. Okay, so this is the transtibial prosthetics. Mainly it consists of three parts. One is socket, pylon, and foot. Okay, and another last one is adapters which is used to connect pylon with the foot as well as pylon with the socket. So two adapters are required for each transtibial prosthesis. Okay, so in the two adapters also we have taken only the one adapter, that is pylon foot adapter, which is used in this part here, this one, bottom one. Okay, so we have taken that part and studied for the alternative material. Okay, this is the part. Pylon is the segment of the prosthetic which transfers load from the residual limb inside the socket to the prosthetic foot on the ground. This pylon is fastened to the socket and the foot using adapters. So these are the two different adapters. One is at the bottom, it will connect the foot, and the other one is to the socket. Okay. So transtibial prosthetic requires two adapters. One is that is a socket. We will call this one as the socket, top one, and bottom one we will call it as a adapter. Okay. So this is the part. This is made with the aluminum. So by casting process, this component is manufactured till now, and most of the components are damaging or breaking during after a period of usage. Okay, because of voids, and voids generally main reason for failure is voids. Okay. So generally these adapters are made with different materials. Mainly these three materials are there. Titanium, which is the best material, but the difficulty in this material is the process of manufacturing as well as the cost of the product. Okay. And second material is aluminum. It will have the decent mechanical properties and lighter in weight. Okay. But this is having generally this aluminum is using because of ease in manufacturing, because by casting process it can be manufactured easily. That's why this material is generally using for this adapter. Okay. So but the problem with the properties of the material. Okay. So and then it is replaced with the plastics also can be used. They are having the high strength to weight ratio. The weight of the part, this part will be very less compared to other two materials. Okay, this is the, so and it will have the better mechanical properties also. It will give almost equivalent mechanical properties like aluminum. Okay, so here these are the three different criteria for selecting the material. We have taken these criteria. One is mechanical properties, second fabrication process, how it is fabricated, and the last one is the weight and economic, how weight should be as minimum as possible, and it should be available in a lesser price. Okay, so for this we have selected epoxy plus hardener and glass fibers. This we made one composite, and we this combination of these three things, and we made some one material. Okay, different combinations we have considered. So because why this is selected, because it is having the better compressive strength, and it is easy to manufacture, and weight also light, and it is economical. That's why we have selected this material. Okay, so these are the advantages and disadvantages of epoxy. So main advantage is great mechanical properties. Okay, and it will not give any take any moisture. It will not attract to any moisture, and it is also will not be affected by fungus. And high temperature and chemical resistance also good for this material. Okay, So, and some disadvantages also is there. The main disadvantage is the curing of this epoxy. Curing only the main difficulty in this. Okay, how it is cured? Okay, and this epoxy's proper mixing, if you are not done, means you will not get the greater, you will not get good properties also. So mixing or combination also plays a major role. So here we have selected epoxy of this grade, Apofine 757, and hardeners, 2 hardeners we have taken. Why we have taken 2 hardeners, I will tell you. And then 2 hardeners of different grades. One is 951 grade and other one is 3486 grade. And again we have taken the silicon rubber, liquid silicon rubber for making the molds, and then glass fibers to get properties to be for improving the properties. We have taken the glass fibers as a filler. So this is the procedure to we have followed for making the prototype. Okay, we have made only the prototypes, okay, to test the properties. Okay, so first we made one 3D model. Then we have a second stage. We made the 3D printing of the component by using FDM process. We have taken the material for making the pattern. This will act as a pattern. Okay, we have taken nylon 6 material and we have made by using FDM 3D printing. Okay, we done 3D printing by using FDM process, fused deposition modeling. Okay, then we have used this pattern for making the mold. We have used the liquid silicon and we have made mold like this, and we have inserted this pattern, and then we have poured the liquid silicon material and we have allowed it to cure. After curing, we have removed the pattern, and it is a silicon mold, so it is easy to make the make the component easily, and we can easily remove from this mold. But it may not be useful for producing more number of components. Okay, only for sample production we can do by using the silicon molds. Okay, so after making the silicon mold, we have made the epoxy mix by adding epoxy and hardener. We have and some added, and then we have poured in the mold. Okay, and we have inserted the glass fibers as per the different layers. 2 layers we have tried. After inserting the glass fibers, we have, after curing, we have removed the component. Okay, this is the sequence we have followed to get the component. So small design modified. Initially, the aluminum component was having made like that, but we have provided some ribs, extra ribs we have provided to get some to improve the mechanical properties. Okay, so for epoxy material, we have added the additional ribs on the outside surface in the vertical ribs. So and combination of different materials we have taken like this. Okay, epoxy we have added hardener in the 5:1 ratio, and it is cured in the room temperature. Okay, it took around 4 hours to get the component. Then we have taken 10:1 ratio. It took around 10 hours time to get the component. Okay. Then hardener we have taken 3486. It is and we have used the ratio 8:3. Epoxy is 8 parts and 3 parts of hardener. It took around 72 hours of time. Then we have combined hardener 951 and 3486. Then we have made one combination 32:7:1. 32 is the epoxy and 7 is the hardener 3486 grade, and 1 part hardener 951. And we have got at least around 24 hours it took to get the curing. Okay, all this curing done at the room temperature. Okay, generally to get cured very fast, we have to do at other temperatures like 60 degrees or 120 degrees depending upon the hardener. Okay, but we have all tested at room temperatures itself. Okay, so the hardener combination 1 and 2, it is light extremely exothermic and comparatively less exothermic, because it is because of the property it is getting cured very fast. Okay, and by adding but with this hardener 3486 grade, it is very slow curing. It is almost taken 72 hours. So to increase that, to decrease the time, so we have added one part of H951 grade, so that it is the curing time reduced to 24 hours. Okay, for making the faster, we have added one part of first hardener, H591, okay, 951 to get faster action. Okay. So these are the different combinations we have taken, and epoxy and hardeners in the 4 categories we have taken. First 2 categories we have not added any glass fiber, and second 2 same, but we have added with glass fibers. Okay. So we have added glass fibers, and we have taken the samples as per ASTM standard, and we have studied these 3 different parameters: compressive strength, flexural strength, and impact strength. Okay, and studied, and we have tabulated. Okay. Specimens are also prepared as per the standard. For specimens also we have made the molds, and in that we have poured the resin and fibers and hardeners, and we have taken the samples from similar.
One more minute.
So from the results, so this is the average strength and average compressive strength we have calculated. We have taken the different samples, and we have tested, and we have done the compressive strength, and we have made the average strength only we have taken, and I am showing the average results only. Okay. So epoxy plus H931 H951 resin showed a compressive strength of 98.16 megapascal. Okay. Whereas after adding glass fiber, the compressive strength is increased to 112.71. Okay. Similarly, epoxy and 2 hardeners, it is shown compressive strength of 92. Both are nearby only. Okay. Very. And then we have added glass fiber. It is increased to 92. Is increased to 99.73. Okay. Similarly, flexural strength also we have studied. Flexural strength, first case it is variation is more, and after adding glass fiber, the second case epoxy and 2 hardeners, it is shown 66.9, and epoxy, 2 hardener and glass fiber, it is shown very some little less it is shown. So these things to be studied more. Okay, but first case it is improved glass fiber. First place the flexural strength is improved. Okay, second case it is some little difference is there, that to be studied further. Okay. Then impact strength is increased very well after adding these glass fibers. Okay. Initial case the impact strength is very less. When adding 2 layers of glass fibers, the impact strength is changed drastically. Okay. So this is another advantage. Okay. So from this thing, so whatever the third combination, whatever we have used, epoxy and 2 hardeners plus glass fibers, is shown better results, better mechanical results. So we have manufactured the component with that, and we have tested, and further more testing to be done. Only it is in the initial stage. Okay. So so these are the future scopes are there. Okay. Only we have done the preliminary work, and preliminary studies we have done in this work. Okay. So more studies to be done for the newly developed components, field tests to be done, and what are the results to be get. Okay. So some other tests like scanning electron microscopy, and it is fatigue strength also to be done, and finite element analysis also to be done for this combination. Okay. Thank you.
Thank you, Ravindra.
Thank you, sir.
So any question? It's another example of a very good, excellent research work. Okay, this is a need of the day now, because I think most of these materials we are importing.
Yes, sir.
So it's a very important area, and it has got lot of applications and lot of utilities for basically Divyang people. Okay, so it's a very important area of work, and if we can develop something, some process, some know-how at lower cost, then definitely it has it is going to be give a big boon to the society. So any question? Yeah, Dr. Mandal.
I have one small question. Sir, what type of hardener you are using here? Epoxy and hardener, na? You are using. What is the role of the hardener, and what type of hardener, how it is play a role, for why you are using?
here the grade of the hardener that is suggested by the manufacturer. Okay, depending on the epoxy grade, he suggested these two hardeners. Okay, one is fast curing and other one is slow curing. So these two suggested by the manufacturer, we have taken the two and we have studied.
Okay. So are you in touch with a manufacturer?
Manufacturer of this raw materials.
Or raw materials?
Whatever hardener, that is some code is there that is not disclosing. I am telling you, amine type hardener is suitable for the case of epoxy resin, and diamine is suitable for your cases, for your prosthetic and whatever the revamp people, whatever you are doing some product, that diamine type hardener is suitable for your cases.
Okay.
Oh, okay, thank you, sir.
Good. Let us give a big round. Okay. Here's one more. Okay.
Is there any, I mean, how much heat it can resist? Is there any experiment on that?
How much heat?
Yeah.
Heat.
Heat.
Why do you need heat? Basically, you tell me.
Because maybe due to if this is attached to someone living, then it may be due to the living style or maybe that's why.
Usually these type of things are more suitable for ambient conditions, but for specific applications like fire
up to
or some
120 degrees centigrade, it will not give any effect.
How much?
120 degrees centigrade.
Okay.
Up to 120 degrees centigrade, it will be okay. After that, it will change its
It
phase.
will start melting, right?
Not melting,
but
it will not melt.
इसका ये खराब हो जाएगा. ठीक है.
It is a thermoset material, so it will have some other effect.
Okay, let us give a big round of applause to Mr. Ravindra.
Thank you, sir.
Thank you so much, Ravindra. So now we have a online presentation, I think, by Mr. Kausal Kumar Saraswat. Huh? वो नहीं है. Okay, so he is not there. Now we'll move on to the next presentation by Prasanti Parida. Am I correct? Is it there? Miss Prasanti, you have got 10 minutes, so please try to conclude within that.
I am Prasanti Parida from Ravenshaw University, and I am going to present the topic effective promotion of oxygen reduction reaction activity by cobalt doping in praseodymium magnesium oxide at B site. Contents: first introduction, then material synthesis, then material characterization, then result and discussion, then conclusion, then reference. First, fuel cell. Fuel cell is the device which produces electricity by converting to chemical energy into electrical energy. And one type of fuel cell, that is direct methanol fuel cell. It consists of two porous carbon electrodes, that is anode and cathode, and consists electrolyte solution H2SO4. Then at anode side, we continuously supplied fuel, that is methanol, which combined with water to form carbon dioxide and oxidized to carbon dioxide and H plus ion and electron. Then electron moved to anode to cathode from outer circuit, and H plus ion which is moved to anode to cathode, and at cathode side which as oxygen is supplied as oxidizing agent which combine with H plus ion to form water, and cathode side reduction occurs and water is removed to outer side which is a non-polluting agent. Then oxygen reduction reaction. Oxygen reduction reaction is the cathodic half cell reduction reaction in which oxygen is reduced to water and hydrogen peroxide. It occurs in two medium, acidic medium and alkaline medium. In two medium, direct 4-electron pathway and 2-electron pathway occurs. In 4-electron pathway, it generally forms water, and in 2-electron pathway, it forms hydrogen peroxide. Then electrochemical study. First we prepare the ink, then ink load on the electrode, then we take the measure OR, then first take CB. In CB we measure whether the reduction peak appears or not. In RD, onset potential and current measures. In RD, percent of HO2 formation and transfer number of N electron measures. Day-to-day study about OR gradually increases noble metals like platinum doped alloy, which very costly and lower stability. Then transition metal, which was lower stability. So we used rare earth based peroxide, which was more stability and more catalytic activity towards OR. Then peroxide, which is AbO3. In AbO3, Ab nearly occupy all elements of the periodic tables or leads huge amount of properties. So material synthesis, first we take appropriate amount of praseodymium nitrate, cobalt nitrate and manganese nitrate, then added EDTA and citric acid as chelating agent. Metal and citric acid EDTA take ratio 1:1:2. Then stirring at 90 degrees Celsius about 4 hours until the gel formation occurs. After the gel form, it heated into the oven at 100 degrees Celsius. After that, calcination occurs at 750 degrees Celsius for 4 hours. After the calcination at 750 degrees Celsius for 4 hours, all the catalysts appears to be single phase and the main peaks appear 110, which appears to be orthorhombic structure. Then figure B is the enlarged XRD pattern, which is clearly seen that some peaks are shift to lower angle and some peaks are shift to higher angle. It is clearly seen that cobalt doped in peroxide is successfully obtained. Then the PCM 0.9, PCM 0.8 is the particle size and D spacing. Mapping. In mapping, we seen that all elements are present and all elements are uniformly distributed. And it is the same image of PCM 0.6, 0.7, 0.8 and 0.9. It is clearly seen that size is gradually increases with decrease the doping at B side cobalt when doped at peroxide. Then EDX image. In EDX we found that all the elements of peroxide is found, no other elements are found, and the ratio of praseodymium, cobalt, manganese and oxygen are nearly equal to the corresponding stoichiometric ratio. Then CB. In CB image A, we clearly seen that in nitrogen saturated electrolyte there are no peak is found, the redox reaction are negligible. In oxygen saturated electrolyte there is strong cathodic reduction peak found. So in all the reduction peak are nearly equal except PCM 0.7, which shift to the positive onset potential, which is a good catalyst towards OR. In figure B also LSB curve, all catalysts have onset potential nearly equal except PCM 0.7, which have a positive onset potential, which have a good catalyst towards ORR activity. In figure C, RRD, we calculate the transport number N electron and percentage of HO2 formation. In figure D, we calculate the electron pathway, either 4-electron pathway or 2-electron pathway. So from KL plot, we found that straight line plot at a different potential, or we observed that the electron transport 4-electron pathway observed. Then methylene tolerance. Methylene tolerance is an important factor in ORR measurement. So methanol we add 600 seconds. Then we found PCM 0.7 have 75% have a more methylene tolerance than platinum carbon. So it have a good catalytic activity towards ORR. The chrono we measure the stability of catalyst. In figure B also seen the PCM 0.7, 71%, which have a more stability than platinum carbon. So it have a good catalytic activity towards ORR. Then conclusion. Conclusion, we found that both methylene tolerance and chrono, that PCM 0.7 have a more catalytic activity than platinum carbon. So cobalt doped in praseodymium manganese oxide at B site, which have a good efficient result for ORR in alkaline medium. These are the some references are given. Thank you.
Good. Finished in time. Any question from the audience? Prasanti, just tell me what is the difference between Joule gel method and hydrothermal method?
Hydrothermal method and
Joule gel method.
Sol
You have
gel-
used salt gel method.
Sol gel. In sol gel method, we take the solution, then heated it in oven, then calcination takes place. In a hydrothermal method, we centrifuge takes place, and hydrothermal it takes up to 24 hours heated into the
Centrifuge.
First we heated into hydrothermal in
Under certain
hydrothermal
pressure.
instrument at in oven 24 hours something. Then centrifuge takes place. Then
So are you afraid?
Hmm.
Are you afraid?
Again,
Why you are so cautious?
no.
Okay. So it's a good piece of work. You are also working with Dr. Padi. Okay, good. Very good piece of work. But publish soon. You have not published yet. Okay. Okay, good work, good work. Thank you. Give round of applause to her. Thank you, Prasanti. So now we have another presentation by T. Swetha from CLRI, CSR CLRI, Chennai. So Swetha, you have got 10 minutes. Okay, please try to finish up quickly. Okay, thank you.
Good evening all. Myself Shweta, a junior research fellow of DST Inspire, currently pursuing PhD on fabrication of polymer nanocomposite under the supervision of Dr. P. Tanikaivelan, CSIR Central Leather Research Institute, Chennai. Now I am going to present about fabrication of nano titanium dioxide incorporated polysaccharide protein-based hybrid films for packaging applications. Introduction. Packaging is a coordinated system of preparing goods for transport, distribution, storage, retailing and end use. So I can say like it is an essential tool in product protection, marketing and customer satisfaction. So overall it is a tool which enhances the shelf life or longevity of the food items without addition of any preservatives. The study found that food packaging encompasses many different materials, of which 33% comprises of papers and cardboards, of which 45% of almost plastics, which includes both flexible and rigid plastics, 12% of metal, 5% of glass, and remaining 4.5% of other packaging materials. So coming to the problem statement associated with the existing plastic-based packaging includes the unusual pile of plastic poses major threat to the biosphere even when better recycling rates can be attained. Present recycling initiatives fall short of expectations. The life cycle of non-biodegradable plastics entails the release of dangerous endocrine disruptors and micro and nanoplastics in the food environment and plastics in the food chain even when better recycling rates are attained. So currently the packaging industry is focusing more towards sustainability and smart packaging materials. The main obstacle associated with the bio-based building blocks includes lack of homogeneity and batch-to-batch performance variability. These are the pre-rotops gelatin and chitosan biopolymer. Silver, titanium dioxide and chitosan adipate as nanocomposite. They used for the antibacterial coating for fruit storage, whereas gelatin film incorporated with T polyphenol nanoparticles enhances the controlled release of antioxidant related studies. They also studied the polyelectrolyte versus polyamphylate behavior of gelatin chitosan polymers, gelatin and chitosan with silver nanoparticles, whereas gelatin and chitosan with protein crutase and hydrolysates, and gelatin and chitosan with polylysins. They also studied the biodegradation of the packaging applications. This is the scheme. Our work is done to find some improvements over the prior art. The present fabrication of the hybrid film is more compact than the prior art. This shows the schematic of polysaccharide protein based hybrid films. For this, we prepare different composition of films using solvent casting method by varying the composition of gelatin and chitosan. The following composition of gelatin and chitosan we prepared are 1:1 ratio, 2:1 ratio and 1:2 ratio. For this 2% gelatin solution is prepared by dissolving it in distilled water for about 30 minutes, and 2% chitosan solution is prepared by dissolving it in 5% of glacial acetic acid solution for about 1 hour 30 minutes. Then the obtained films were characterized for its physical and organoleptic properties. It is evident from the result, gelatin and chitosan of 1:1 ratio possesses the higher tensile strength of 25 megapascal. Though gelatin and chitosan of 1:2 ratio possesses only the tensile strength of 14 megapascal, it is preferred for the nanoparticle incorporation because it possesses better organoleptic properties, that is in terms of flexibility, higher flexibility compared to the other two composition, that is gelatin and chitosan of 1:1 ratio and gelatin and chitosan of 2:1 ratio. So it is preferred for the nanoparticle incorporation. Then the synthesis of titanium dioxide nanoparticles. Titanium dioxide nanoparticles is synthesized via non-aqueous Salzgill route using titanium tetrabutoxide as precursor and nitric acid as a catalyst, and then the titanium dioxide nanoparticles were characterized further. The XRD spectra of titanium dioxide shows the high intensity peak at 25.3 degree, which corresponds to 101 plane, which confirms the formation of crystalline anatase phase of TiO2 with the tetragonal crystal structure. The other peaks at 35 degree, 46 degree, 54 and 55 degree, 64 degree corresponds to the respective planes, which further confirms the formation of anatase phase of titanium dioxide nanoparticles. From the same images, it is evident that the particle possesses spherical morphology and are slightly agglomerated. Slightly agglomerated, and the average, and then the hydrodynamic size of the particle is calculated through DLS, has been shown here. The average size of the particle is around 480 nanometer. The increase in size can be attributed due to the hydrodynamically coupled water around the nanoparticles. Here is the schematic of nano titanium dioxide incorporated polysaccharide protein based hybrid films. In this various percentage of to the hybrid solution of gelatin and chitosan solution, various percentage of titanium dioxide nanoparticles was incorporated, and then the obtained films were characterized further. From the same images, it is worth mentioning that no interfaces were identified in the film matrix, revealing high compatibility between the two, that is of gelatin and chitosan, and generally smooth and compact morphology is achieved because of its associative interactions. And it also shows that titanium dioxide nanoparticles is distributed throughout the matrix, and however at the higher concentration of titanium dioxide nanoparticles, where we can evidently see that there is an agglomeration in the film matrix. This is the XRD pattern of the hybrid film. The XRD pattern of the titanium dioxide nanocomposite film does not reveal any distinct characteristic peak of titanium dioxide, which might be attributed due to the masking effect manifested by the gelatin matrix, gelatin chitosan matrix on the TiO2 nanoparticles. Then the FTR spectrum of the hybrid film. The FTR spectra reveals the similar characteristic peak of the parent molecule, which confirms the successful incorporation of the titanium dioxide nanoparticles without affecting the gelatin chitosan structure. Then the physical properties of the hybrid film. For the control film, gelatin and chitosan of 1:2 ratio possesses the tensile strength of 14 megapascal, whereas with the incorporation of 1% of titanium dioxide nanoparticles, it also shows a similar value like 14 megapascals. But by the incorporation of 2% of titanium dioxide nanoparticles, it shows the tremendous increase, that is almost twice the amount of the tensile strength, like 27 megapascal. But where it goes beyond the 2%, that is for almost 5%, it shows the decrease in the tensile strength of only 8%, 8 megapascal. Then the contact angle for the hybrid films. For the control film, it shows a contact angle of 70 degree, With the 1% incorporation, it shows the higher contact angle of 79 degree, which shows this improvement in the surface hydrophobicity increase. Then with the addition of 2% and 5%, it again shows the decrease in the water contact angle. Conclusion. Titanium dioxide nanoparticles incorporated gelatin chitosan composite film shows better tensile strength and good hydrophobic properties which extend the shelf life of the perishable items. Nano titanium dioxide incorporated polysaccharide protein based hybrid films is expected to be used in the food packaging industry, but it needs to be specifically evaluated for its food storage capacity. This can be also used in dye degradation or dye adsorption related studies, and our future work and expected outcome is the addition of the particle to the polymer matrix will expected to improve the film's UV blocking, ethylene scavenging and antibacterial properties. These are my references and thank you.
Excellent, Shweta. Any question? Oh, okay, yeah.
What is the natural source of gelatin?
Gelatin from leather fibers, sir. Collagen and we converted into a gelatin.
Natural source क्या है?
Leather fibers.
Leather fiber.
Okay, I have a couple of questions, Shweta. When you are adding titanium dioxide at higher concentration,
yes, sir.
why the strength is decreasing after 2%?
Everything, the affirmative matrix of the nano size and the higher surface area is no longer effective after a specific percolation limit. Everything has a percolation limit.
But what could be the reason behind it?
Because of the agglomeration, sir. When it tends
because of the agglomeration.
Yeah, when it tends to agglomerate, when we do further characterization, it tends to break easily when we apply a small amount of stress.
Okay, and one more thing, do you know that titanium dioxide is going to be banned in near future? Do you have any idea on that?
No.
Please take a look on that.
Okay, sir.
So far my knowledge goes, it's going to be banned in America soon.
Okay, sir.
And there could be some other reason behind it. So just look at it, okay?
Sure, sir. Sure.
Thank you very much. Such a nice presentation. And we should give a big round of applause to her.
Thank you, sir.
Thank you so much. All the best. So we are in the last presentation of the day. Ms. S. Parthavi Priyadarshini. It's here on, okay. So you are a student? You are a student? Okay, please try to restrict it to 10 minutes, huh? Okay, thank you.
Good afternoon, everyone. I am S. Parthavi Priyadarshini, a final year civil engineering student from Gandhi Institute for Technology. And I would like to thank CIPET and for organizing RAMM-2023 and giving us opportunity to the young engineers to represent their research work. And today my research work is on replacing cement with BOF slag, which is basic oxygen furnace slag. So today we'll be discussing about these components. So first of all, I would like to address on why I chose BOF as a substituting material, because as we discussed earlier to this event a day before, that around in 2023 to 2027, the atmospheric temperature is going to rise to 1.1 to 1.8%, which is really concerning and is hazardous. Because with the increase in temperature, there are many natural disasters that might have come. So to reduce that, we also have to look at the industrial waste, because industrialization is contributing more to the increase in temperature. So we have to recycle the industrial waste, and here BOF is an industrial waste which comes from the iron slag. And using this, we are creating concretes. So why we are substituting with cement? Because cement production contributes to 8% to the carbon emission every year. That is why to reduce the manufacturing of cement, we are substituting with more recyclable material, and in this case BOF. So what is BOF? BOF is a slag or basic oxygen furnace, which is a byproduct of from the iron ore. In blast oxygen, basic oxygen furnace, oxygen is used for the combustion, through which iron are separated, and rest is the slag, which is we call the BOF slag. So this is the properties of the BOF slag, which we have calculated. So the physical properties, its colors vary from gray to black, and the texture is rough and angular, as you shown in the figures. And the density ranges between 2.8 to 3 grams per centimeter square. The particle size is ground to 100 microns to match the 90 micron size mark of cement. And the porosity should be less than 100, so that it becomes less water absorbing, because we cannot use the concrete which is more water absorbing. And these are the chemical properties, where the constitution of BOF slag is silicon dioxide, aluminum oxide, ferrous oxide, magnesium oxide, and calcium oxide. And calcium oxide is also present in cement, and it is a major part of cement, so it is ideal to be substituted with cement. And the reactivity, it shows the pozzolanic reaction with cement, which helps in binding and provides the durability and strength to concrete. So these are the advantages of using the BOF slag. In the figure you can see the scanning electron microscopic characterization and activation of the BOF slag in the cement. And the advantages are, it reduces greenhouse gas emission, because as we know that cement manufacturing is providing more to the CO2 emission. So by substituting it, we can definitely lower the CO2 emission. And it is very cost effective, because for the research we have purchased a 50 kg pack of cement, which ranges around 500 rupees, but 1 ton of BOF only consists of 2000 rupees, so we can it is cost effective. It improves durability, reduces cracking, reduces water consumption during the curing process, and it improves workability and it improves sustainability. So here is the particle size comparison, and the blue line you are seeing here shows the cumulative graph of cement, and the dotted line, it is known as the frequency curve, which is shown by the BOF slag. So in shipping process, where 100% of cement particle is passing through the sieve, but 80% of elements is passing through the sieve, because we cannot grind the BOF slag to that fine extent to reach exactly of the size of the cement. So this is the partition. And we are using M35 grade concrete, because we want to make it for the pavement. And these are the test conductors. So in the test we have substituted in a different proportion, which is 10%, 20%, 30% and 40% respectively. And these are the results. First we have seen the compressive strength. In the first chart we have tested for M35 grade, which means the concrete having compressive strength of 35 Newton per mm square. So first one is the normal concrete grade, and you can see the results, but as we are substituting in the above manner, then we are getting the most results from in 30% substitution. And in the third table 2 here, we can see that the flexural strength. So flexural strength is a part to check tensile strength of the concrete. And here the second second sample is providing us with the best sample, and water absorption we are getting the least in the 40% addition of BOF. And this is the graphical representation of the above results. So these are the challenges and limitations of using the BOF. First is quality control, because we have to check whether what are the compositions of the BOF, because if any composition we have found out or we require, if it differ from the actual composition we need, then we cannot use it. So then availability. India is the largest producer of iron ore, but the iron ore is mainly produced from states like Odisha, Maharashtra, Jharkhand. So in the northern part or northeastern part, we cannot get more of the iron slag, so availability of the iron slag is less there. So then environmental concern. We know that in the iron steel making process, there is many greenhouse gases are emitted. So we cannot control that. That is why it is environmental concerns are there. About the cost, where, as I said earlier, then that where the availability of the BOF is less, then obviously their cost will be more. And compatibility with other materials, this is a key thing we have to concern while making the concrete or substituting with any other material. So from the above calculations and test, we have concluded that around searching from every aspect, that 30% substitution of BOF to cement gives us the best results. That is why it can be substituted to our concrete materials and can provide us with better. And this is my reference. Thank you.
Very good. Another excellent piece of work by young researchers. Big round of applause to Parthavi. So any questions? Okay, no question, but I have one question. How confident you are that you can replace cement with 30% cement with BOF slag?
Sir, because while creating concrete, we are mainly looking for three aspects, which is compressive strength, flexural strength, and water absorption, because these are the key element, and we have tested on that basis. And from the various results, we got the best result in the 30% of 30% substitution.
So you are very sure?
Yes, sir. Because
okay, good, good. Okay, very good. Thank you. Huh?
Thank you, sir.
Okay, so let us give big round of applause to all the presenters. They presented well and best on the background theme or theme of the seminar. So it's a very good day now. Yeah. So seta he gala. Seta separate present kole. Huh. Separate. So okay, thank you everyone. Thank you the audience for your nice patience and your feedbacks. So hope this type of presentations will go on, and our young researchers will do better work and try to keep the society green and sustainable. Thank you all.
Thanks, sir, for chairing the session. Now I invite Sri K.K. Mahapatra sir, Director and Head, CIPET CSTS Baleswar, to felicitate Dr. Bankim Chandra Tripathi sir with a memento for chairing the session at RAMM-2023. Sir, please. Thanks, sir. So now we will have a 10 minutes break. All the participants are requested to visit to the ground floor to the stall. The exhibition visit is now scheduled for 10 minutes. Meanwhile, we will be arranging the dais for the valedictory session. All are requested to leave the room and visit the exhibition stall. You can have group photographs there for your sweet memories at RAMM-2023, and we will join here at 5:15. Thanks. Please please vacate the room and visit the exhibition stall. Volunteers are requested to guide the participants, delegates.
Hello.
All delegates from industries, our sponsors, they should attend the valedictory session. We will be felicitating for their supports towards organizing the conference.
fruitful results. By making HFFR, we have made our contribution. Success is not a destination. It is a journey, a path paved by continuous growth. That is why, with over 30 years of experience, Dev Plastics has emerged as the leading polymer compound manufacturer in India. Our installed capacity of 239,000 metric tons makes us the largest polymer compound manufacturer in India and also strengthens the credibility that we share with our shareholders and customers. Our 5 strategically located state-of-the-art plants exhibit our commitment towards modernity, technical advancement, and world-class R&D. Through ingenious collaborations with leading institutes and erudite professionals, we continue to push the envelope of innovation. Our diverse and ever-expanding portfolio of compounds enables us to work across industries, ranging from PE, PVC, filled, pipe, footwear, and peroxide. We have now also scaled up to include compounds for white goods, automotive, and electrical appliances. By introducing a 66 kV super clean HV cable grade compound for the first time in India, we have furthered the quest for excellence in dielectric materials for cables and wires. As global leaders in XLPE compound manufacturing and HV compound production, our extensive R&D has borne fruitful results. By making
From traditional industrial materials to modern high-performance advanced materials, every change of the materials has been promoting the progress of human civilization. As the cornerstone of industrial development, modern high-performance advanced materials, with their application and development stepping into the golden age, have become the invisible force to promote industrial progress. Born in the tide of reform and opening up, Kingfa seized the moment, took the momentum, and opened a new era for the development of advanced high polymer material industry. Innovation is the engine of enterprise development. In the process of development, Kingfa has explored an independent innovation way, with market as the orientation, enterprises as the foundation, and industry university R&D collaborated, relying on the innovation platform established by organizations such as State Accredited Enterprise Technology Center, National Engineering Laboratory, State Certified Laboratory, the first UL CTDP. Kingfa has performed a comprehensive research of the prospective applications and solution of new plastic materials. Kingfa has successfully developed modified plastic series with the world's most complete varieties and has set up a scientific and rigorous quality control system to provide reliable quality. Innovation furnishes tremendous power to Kingfa's development, transformation, and upgrade. In every success Kingfa achieved, we see mark of innovation. In recent years, Kingfa has won 3 National Science and Technology Progress Awards. Over time, Kingfa has established cooperative relationship with Gree, Medea, Samsung, Sony, Toyota, Ford, Apple, Volkswagen, Philips, and other well-known enterprises at home and abroad, growing together and sharing achievements with the partners, providing high-quality advanced material products for society, creating a better life. Kingfa has realized the increase of employees' happiness and made the employees and the company grow together. At present, Kingfa has brought together 15 academician consultants, more than 100 experts from home and abroad, more than 100 doctors, and many other excellent talents. Kingfa has committed to provide the society with more qualified products and more satisfying
Good afternoon to the all. The National Conference of 2 days on recent advancement in material science, materials and manufacturing, RAMM-2023, has arrived its final destination. Here, I, Avinash,
and I, Rashi, we both are absolutely delighted and honored to welcome you all to this valedictory ceremony. In order to grace this occasion, I would like to welcome you on the dais, Dr. Ashok Kumar Sahu, Sir, Chief Scientist, retired CSIS IR, IMT-Bhubaneswar.
Along with, here we have our Chief Manager, Technical and Principal, Dr. P.C. Padi, Sir, CIPET IPT-Bhubaneswar, Dr. Ashwini Kumar Mahapatra, Sir, Manager, Technical and Dean, Student Welfare, Dr. Debarat, Sir, Convener, Dr. Syama Prasad Mohanty, Co-Convener, Dr. Trupti Ranjan Das, Co-Convener. And also we welcome the dignitaries and researchers, scholars, faculty members, sponsors, industry delegates, and all the students present over here.
The power of National Anthem unites us and fills our hearts with love for our country. So, before proceeding the program further, I would like to request all the dignitaries and individuals present over here to stand for the national anthem. हाथ नीचे.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
Thank you all. Welcoming is an art. It's a proud from the heart to express at this juncture. May I take the pleasure of inviting our principal, Principal CIPET IPT-Bhubaneswar, Dr. P.C. Padi sir, to give welcome address and conference outcome briefing.
Good evening to all. First of all, respected Dr. Ashok Kumar Sahu, sir is the Chief Scientist, retired IMMT Bhubaneswar, CSIR lab. CSIR is, IMMT is one of the CSIR lab, and sir is having a very strong background in the area of minerals and materials. He has delivered his keynote address today morning, and respected our delegates, all industry delegates, and the faculties and officials came, academicians from all part of the country. I welcome all the people to this platform, and we are very much delighted to organize this 2 days conference. You are all aware that this conference RAMM-2023, that is recent advancements in materials and manufacturing, that is the 2 days requirement in the present day scenario. The material is the input and manufacturing is the output, which is the core importance for the growth of the nation. That's what, keeping an objective of the same thing, we thought to organize such type of conference to just integrate all the eminent scientists, academicians, students, fraternity, research scholars, and industrialists, so that there will be a clear vision of close connect between the academia and industry, so that, as you are all aware, that without connecting the academia and industry, you can't achieve the goal and your objective cannot be fulfilled. That's why this is a platform. I hope definitely this might have been a very informative session these 2 days. For your kind information, we have received more than 100 abstracts, out of which we have selected 60 abstracts, and out of that 36 oral presentations, 2 plenary lectures, 4 keynote addresses, and 45 industry delegates participated in this 2 days national conference. And this 2 days conference, I hope the complete materials, both ferrous, non-ferrous, plastics, and its allied areas have been connected. The lectures, whatever are delivered, I think they have connected to all these areas, and more than 250 participants joined, and I hope these 2 days conference might have been immensely benefited to everybody. And this is not only 2 days, these 2 days will keep us connected for the further course of time to just take forward our research activities with various industries, with the organizations and all. And I am just this welcome address, I can tell that I hope these 2 days are very highly informative, and such type of thing will keep continuing. I am thankful to all the delegates, and that all have come and with patient hearing for these 2 days, and we will now this 2 days conference is getting closed, and today is the closing ceremony now we are organizing. I hope we will keep connected further also, and once again I welcome to all on this auspicious occasion. I hope it will have a very wonderful ending of the session. Thank you very much.
Thank you, sir. It is our privilege to have with us. We rarely get this kind of an opportunity to listen the words of personality like him. We are honored to have with us a distinguished personality who has not only contributed significantly to the area of mineral processings.
His accomplishments and hard works are a testament to his hard works and perseverance. He has been honored with multiple awards for his research papers and numerous patents. He is always willing to share his knowledge and experience with students. We are lucky to have our honorable guest, Dr. Ashok Kumar Sahu, Chief Scientist, retired CSISR, IMMT-Bhubaneswar, today to share his insights with us.
Very good evening to all, respected dignitary on the dais and up the dais, dear delegates. I think these 2 days, I congratulate CIPET for organizing the very wonderful national conference, having a lot of participation from all around country in the area of materials and manufacturing. As of I know, only 2 points I want to tell all the delegates. Work should be done not in isolation but in a team. So wherever we are lacking in our expertise or we are lacking on a subject, we should have a collaboration. Maybe it is R&D collaboration, or it is academia R&D collaboration, or it is academia or R&D or industry collaboration. Unless we have that, then we cannot progress more, because we will all work in isolation and it will be in the paper and report. So always as R&D organization, CSR, we have learned, unless we have a very good commercial exploitation of our findings, then society will not be benefited with that. So with this mind, with this background, we can tell always we look forward to innovation and its exploitation by commercial exploiters, so that our work will see the day of the light and it will be beneficial to all of our society. It is not only us but society. The one point, another is the technology level, the level we are working. In the lab, we are working on the technology level 1 or 2, because we are proving our concept in a very low level, lab scale level. But we should find a very good way to make it up, scale it our innovation to the higher level, so that it will have a attracts you, it will be attracted by the industry, those who are doing commercial business type thing. So they will be attracted to take your concept and take your technology to the masses. So these 2 points I want to tell, and I think you have learned a lot in this national seminar, and further, as Dr. Padi has told, it will continue, and this is a good platform to interact with your peers and interact with the students, so that you get knowledge and also exchange knowledge. Thank you. Wish you all the best. Thank you. All the best. Thank you, sir.
Thank you so much, sir. That was indeed motivating and extremely informative. We are so honored by your presence on this occasion.
The event was successfully conducted, behind which there was one hand of support of our sponsors. There were few bankrolls of our sponsors. Their contribution let us meet so many esteemed, talented and knowledgeable personalities.
Today we have come together to express our sincere appreciation towards our esteemed sponsors. It's time to express our gratitude. Here we have a monument, a token of our appreciation. Therefore, I request Dr. Ashok Kumar. Therefore, I request Dr. Ashok Kumar Sahu, sir, Chief Scientist, retired, CSRI IMMT, Bhubaneswar, to give monument to our sponsors. So first, we have a platinum sponsors, Kimpa Science and Technology India Limited. The second platinum sponsor we have ITC Limited, ITC Life Science and Technology Center. I request all the ITC team members to please come on the stage and take the memento.
The next platinum sponsor is Sudhakar PVC Product Private Limited. The next platinum sponsor is Astral Limited. The next platinum sponsor is Tata Metallics Limited. The next platinum sponsor is Chemical and Petrochemical Manufacturers Association. Already taken. The next platinum sponsor is the Supreme Industries Limited.
Secondly, we have our gold sponsors. In gold sponsor, I would like to invite MS D-Day Plastics Industries India Limited and his team to take the memento. Next we have GAIL India Limited. Next we have silver sponsor, CSRI Institute of
Next up we have silver sponsor. The first one is CSIR Institute of Minerals and Materials Technology. The next silver sponsor is Expro India Limited. The next up we have Rourkela Engineering Limited, India Private Limited. Next up we have our bronze sponsor,
Geol India Private Limited. Next we have bronze sponsor RAN Fluid Tech Private Limited.
Radiant Fluid Tech Private Limited. The next bronze sponsor is IML Limited.
Next bronze sponsor we have Nature Tech Private India Private Limited.
Next we have Ashirvad Pipes Private Limited. Last but not the least, we have IREL India Limited.
Now, let's now celebrate the achievement and success of our peer who activity participated in event held during these 2 days. Therefore, I request our chief guest, Dr. Ashok Kumar Sahu, to present the award to the best oral goes to
Ankita Subrashita Godia. She's not there? Okay. For oral. And the next one is Rahul Rane. For oral. They are not there. For the next is the best poster presented. First one we have Gaurav Das. Okay, it's an online one, sorry. The second one is Surabhi Bahana. We value our intellectual and research persons and nurture it through a perfect blend of knowledge and development in various fields. We are fortunate to have such grateful personalities here whose expertise and insights made this event successful. Thus, I would request Dr. Ashok Kumar Sahu sir to facilitate with memento Dr. P.C. Padi sir, conveyor of RAMM-2023.
Next, I would like to request Dr. Ashok Kumar Sahu sir to facilitate with memento Dr. Devarat sir, convener RAMM-2023. Okay, sir.
Next, I request Dr. Ashok Kumar Sahu sir to felicitate the memento to Dr. Shyama sir.
Now I would like to request Dr. Ashok Kumar Sahu sir to felicitate with memento Dr. Trupti Ranjan Das sir, co-convener RAMM-2023. Now I would like to request Dr. P.C. Padi sir to felicitate with memento Dr. Ashok Kumar Sahu sir. Thank you all.
The world is round. The world is round, and the place which may seems like an end might be the beginning. At the end,
for the vote of thanks, I would like to invite our Dean, Student Welfare, Dr. Ashwini Kumar Mahapatra sir.
Good evening to all. This is my great pleasure. I stand in front of you all to give the vote of thanks. It's a very tough job. because we are ending the session with vote of thanks. But again, it is a start that we are thanking you for your continuous support in the same, in every aspect to CIPET IPT Bhubaneswar. As we come to the close of the National Conference on RAMM 2023, both in the physical and as well as the online mode, I stand here with immense gratitude for the collective effort and enthusiasm that has made this event a true success. I extend my sincere thanks to our distinguished guests, both those who graced us with their presence in person and those who joined in us online. Your support and insightful contribution have been invaluable, bridging distances and enhancing the global dialogue on materials and manufacturing. I would like to give many thanks and heartily thankful to the plenary session provided by Professor Dr. Ashok Kumar Ganguly, then plenary session by our Ashok Sahu sir, and all the keynotes provided by the industry delegates and Dr. Sushant Panda from VSSUT and all other delegates, those have keenly given their immense research and contributed a lot to the students' fraternity, research fraternity and industry fraternity to grow with their knowledge and deliver it in the real field, and it will give them a true platform to explore in a broader way. It's a good thing that I will also would like to mention here, we are very much thankful the suggestions, feedbacks, their blessings, their wishes, everything given during the their session along with their research topics and their knowledge. So this is a good thing that we got many information so that it will give us a illumination further for the betterment with this conference, and we would like to slowly, as they have given their suggestions, feedback, we would like to make it from national to international conference next time. So this is the good thing we learned in this conference. A heartfelt appreciation goes out to our sponsors. So as already told by our anchors, again I will not leave the names because the session, the conference made success due to the sponsors. Without their support, it might not be easy at our end to proceed with in a grand success with all the types of arrangements. So I once again thankful to the platinum sponsors, ITC Limited, CPMA, Astral, Kingpa, Sudhakar Pipes, Supreme Pipes, Tata Metallics, and gold sponsor GAIL India, Dide Plastics, silver sponsor CSIR, IMMT, Expro India Limited, Rourkela Engineering, and the bronze sponsors Asrivad, Nature Tech, Rarian Fluid Tech, Joel India Limited, IREL, Email, everyone. So core up the heart of mine and as well as from CIPET IPT Bhubaneswar, we are very much grateful to the sponsors. To our speakers, researchers and delegates, where you presented your work on stage or shared your expertise through virtual platforms, your dedication to advancing scientific knowledge has been the driving force behind this conference. Your willingness to adapt to the challenges of online participation has made this event a truly inclusive and collaborative experience. I want to acknowledge the efforts of our organizing committee, technical support teams, and volunteers who worked tirelessly to ensure the smooth operation of both the physical and online aspects of the conference. Your adaptability and expertise have been critical in facilitating this hybrid mode of interaction. To our participants, whether you engaged in face-to-face discussion or virtual mode session, your active involvement has created a dynamic atmosphere of knowledge sharing and networking. Your enthusiasm has reinforced our belief in the power of academic collaboration regardless of the medium. Once again, thank you to our supports, guests, speakers, committee members, and participants, both physical and virtual. Your collective dedication has made this conference a memorable and enriching experience for us all. Again, I am very much thankful all the members of CIPET IPT-Bhubaneswar, CIPET SARP LARPAM, Dr. Smita Mahanti, our Principal Director and Head, Principal, Convener, Co-Convener, all the participants and the press, media, the technical support by our light and sound, everyone, I am heartily thankful to all of them. And last but not the least, the real function, the real conference is supported by the SERB DST. We are very much thankful to them. One in all, we are very much thankful to all the individuals involved directly, indirectly for this conference. Thank you all. Thanks a lot. Now, I will just request our co-convener, who is a writer, speaker, everything. He will just conclude with a light moment with his quotes as a vote of thanks and last moment of this conference. Thank you. Dr. Trupti Ranjan Das, please.
Thank you so much, sir. Without your support, Dr. Ashwini Mahapatra, without your support, sir, would have not have possible arrange this such type of gatherings and the moment. एक लाइन में मैं खत्म करूंगा. सफर वो है जो कभी खत्म नहीं होता. बहुत दिन 2 दिन थोड़ा साइंस वाइंस हो गया ना, थोड़ा रिलैक्स हो लेते हैं जाने के टाइम पे. सफर वो है जो कभी खत्म नहीं होता. वादे वो है जो कभी तोड़ा नहीं जाता. वादे वो है जो कभी तोड़ा नहीं जाता. अरे हम मिलेंगे किसी एक दिन, हम मिलेंगे किसी एक दिन किसी एक सर्दी की मौसम में. मिलेंगे फिर किसी एक दिन किसी एक सर्दी की मौसम में. आप होंगे हम होंगे, आप होंगे हम होंगे, क्योंकि ये जो दूरियां है ना, वो ज्यादा दिन नहीं रहता, वो ज्यादा दिन नहीं रहता. तो just I want to say, finally we reached at a point, or finally we reach at the destination of this 2 days national conference. I can say that we are at a stage of comma, not full stop. That means a pause always brings with new thoughts, innovative ideas. I can promise, but I can say you, again we can meet at RAMM 2.0. Thank you so much. Thank you. And again, जिनके बिना ये काम नहीं होता वो हमारे प्यारे वॉलंटियर्स हैं, हमारे स्टूडेंट्स हैं. उनके लिए मैं ये बोलना चाहूँगा कि आप लोग सब एक बार स्टेज ऊपर आ जाइए. जो वॉलंटियर्स हमारे हैं, प्लीज कम टू द डाइस, प्लीज.
We are very much thankful to our volunteers for their support. For the last 3 to 4 days, they have been working day and night to make this conference successful.
Sir, 1 minute. I request all the faculties, all the staffs of CIPET IPT-Bhubaneswar and CIPET SARP LARPAM to join at stage for a photograph, please. All the CIPET IPT faculty, staff and CIPET SARP LARPAM, just 1 minute. We will take a photo, and lastly we will combinedly take a photo of all the sponsors. Please 1 minute. After this photo, we will take a combined photo of all the sponsors present here. Now we request all the sponsors to come on the stage. All the sponsors to come on the stage for a photograph, group photograph. After this photograph, we all should join with the high tea. There is high tea in the second floor as well as in ground floor. After this, we all should join with high tea. All should be there for the high tea, please.
आप लोगों का ऐसा डिसिप्लिन हमेशा चाहिए। आगे जितना भी इवेंट होगा आप लोग ऐसे ही डिसिप्लिन से काम करिएगा। वी आर प्राउड ऑफ यू।